Hello, everyone. How's it going?
Hey, morning, good afternoon, good evening, folks. Thanks for joining us. We know that you're tuning in from all over. So thank you for spending the day with us. We're so happy to have you here. And for the second virtual ML.net, well, technically it's the third because we have this
Technically
conference.
okay.
Yeah, sorry, go ahead.
Well, we were just speaking about this earlier, rightly, is that it's exciting to see the second year take shape. And we didn't really know when we created this conference a year ago how this would kind of evolve and become something new. And it's exciting, I think, to see the diversity of the talks this year, the depth of them as well, and kind of the complexity. And as well, like tons of case studies, which I think I'm personally really excited about seeing myself.
Yeah, totally. There are a lot in terms of people actually using it out in the real world. If I recall back to last year, Bree and I we did a full day workshop, and there was a little bit more involvement from Microsoft. But it being a community conference, right? It's really great to see it now being fully, by the community for the community.
Yeah. Two full days now, fantastic talks. It should be lots of fun.
Yeah.
Is there anything we should tell attendees now? We have a full schedule, of course, starting in 6 minutes, full day today, and then the full day tomorrow. Are there any practical things we should tell them?
Yeah.
Everything will be recorded. So if you miss something, don't worry. That's always a question that comes up.
Yeah, recorded. We should be going live through YouTube and Twitch as well, right? But yes, you can find our recordings on YouTube. Do we have a link handy for the Slack channel here that folks can join? There's a Slack group organization. What do you call those? A space in Slack where you can join. And this is, of course, we try to have this as a community for for the conference. But of course, after the conference, you can continue conversations. If you meet somebody virtually, collaborate, things like that. It's a perfect place for you to do that. Also, yeah,
I'll find the link to that as well. It's a good point. I'll find the link and put it in the chat here.
Yeah. And while you're doing that, let me sort of pull up the schedule here so folks can kind of get a sense of what's going to be happening over the next 2 days. So if we go here, back to my screen, let me just zoom in just a little bit. All right, so in a few minutes, we're going to have JK joining us to talk about an intro or how machine learning can be simplified for developers with ML.net, right? And then we have this BERT models, right? So deep learning and applying it to financial analysis. Now back office operations following that, followed by some F# talk. So for F# folks who are interested in this, in using ML.net and in this case, notebooks as well, they can certainly check this out. There is the Xbox achievements and how to unlock them with .NET. So that sounds like a lot of fun. And then we have object detection here, as well as anomaly detection with drones. So that's just on day one. And then in day two, you have, again, sort of using automated ML, F1 race strategies, DevOps, consuming models with Roslyn, rock, paper, scissors, and then last but not least, moving data science project to a product. So there's tons of stuff here for you to check out. And again, all this will be recorded so you can, come and go as you please. But we'd really love it if you spent the day with us and got a chance to check out each and every one of these talks.
Absolutely, yes. I think that's I don't even know which one I like the most. They're all fantastic. And I think one of the things I'm excited about personally, of course, is the case studies. Those are really going to be interesting, I think, just to see how it's used in a while. But there's so many other topics here, vertical slicing, for example, in data science projects that I think would be fun. JK's talk that's coming up in a few minutes here as well, giving a broad overview of the tooling. I think it's also exciting. So it's going to be a full 2 days that I don't want to miss a minute of.
Yeah, for sure. But before we even get started, of course, none of this could be possible without all the wonderful speakers that we have here joining us and that are contributing their time, right? Because it's a free conference. They're contributing their time to teach folks and to show them, hey, all the cool things that they're doing. But also, I just want to give a shout out and thanks to our sponsor, Excella. who is, helping makes this possible as well.
Absolutely, yeah. Excella sponsored last year's conference, and they're sponsoring this conference as well. So Excella, for those who doesn't know, they're my employer, which is also fun. But they're a small tech firm out of DC, consulting firm. So they do a lot of things, machine learning being one of them. So, but also .NET. So if you have any of those kind of thoughts, definitely check them out.
And if you have any questions at all anytime during the conference, you are free to post them in the chat, whether you're on YouTube or Twitch. We'll have moderators on, moderators being us three and John, who's not yet with us here. We'll be there to help answer questions and then help field questions to the presenters as well at the end of their talks. I think all the presenters will give 5 to 10 minutes at the end of their talk to be able to answer questions. So ask away.
Yeah, for sure.
No question is a stupid question. We love questions. Some we can answer, some speakers can answer, but I think the more questions you ask, the better, I think. Let's get an engaging and fun conversation going here. And again, if you have questions going forward and you want to collaborate and talk to peers, join the Slack channel and create projects together and collaborate. One of those examples, for example, is the MLOps.NET open source library that I started doing last year. And it was through the Slack channel, actually, that I got to meet a lot of people around the world that could help and collaborate on that project. So definitely try to do those things. I think that will just make the community stronger and more vibrant.
Yeah, for sure. Should we kick it off with JK now?
Yeah.
Let's do that. Yeah, so let's add JK here to the stream.
It's awesome to be back for another virtual ML.NET community conference.
Yeah, we don't have a keynote, but I guess you're kicking us off. So let's say that you're the keynote for this talk or for this conference.
All right. So yes, welcome everyone. Good day, good morning, good night, depending from where you're coming. And I will kick off with machine learning simplified for developers with ML.NET. I am Yene Kavka. You can just call me JK. I'm senior software architect, actually solution architect now at SSW. You can follow me on all of the social medias, GitHub, Twitter, my blogs, and I'm a .NET Core developer as well as EF Core developer as my main profession. But I really like to tinker with AI. I really loved ML.NET. I'll let you know a little bit more why later. And recently, I'm starting to do Home Assistant, home automation, and ML.NET is starting to help me out automate some things that would be really difficult to do it manually. And hopefully, I'll do a talk about that soon. All right. So the way I'm going to do this talk is I'm going to actually give you a quick story of why I actually started with machine learning. So you can, if you ever struggled with machine learning, that's fine. You're in good company. And then I'm going to move into what is machine learning. And at the end, I'm going to give you what ML.NET Model Builder is and how you can get started really quickly. I'm going to give you a real example, real scenario that I have built for bank transactions. And I'm going to show you how to do this in about 5 minutes. All right, so let's get started with what was my goal? How did I actually get into machine learning? I had a very simple goal. I have on one side bank transactions, and I want to get categories out of it. I wanted to save money. I wanted to figure out where money goes, and I wanted to figure out how to save money based on that. Now, when I tried to figure out how to do this, I was just like, okay, I have this text, and I just need to get into that text. So first, of course, in high school, I was like, okay, I can just write everything manually in Excel. That worked for about 6 months until I gave up. It was accurate, but a lot of manual work. But then I gone into uni, and then I was like, oh, wait, I can use C# for this. And I tried to do rule engines. I tried to do like 3 different versions. they all end up with one very significant problem. You have to maintain a database over and over. It's almost like you need to make it learn on its own. And that's where a few years later, I was like, that sounds like a machine learning problem, doesn't it? And I was like, machine learning has to be the answer. And I quickly realized that one does not simply learn machine learning. At least that's what used to be true. Now it's a little bit different. And the reason why that was the case is because machine learning was that rabbit hole. And when you learned about something, then you realize, okay, to better understand that thing, you need to learn other things. And then you realize that the other things has another rabbit hole. In order to understand those things, it's another rabbit hole. And then you spend a couple of weekends and you ask yourself, what did I learn? I know how machine learning works in theory, but I don't actually know how to use it. And, like all very ambitious projects, time is infinite, but I never seem to get enough of it. And it ended up in the failed dreams drawer, and I thought I'll never come back to it. And that was true until ML.NET came out. If I remember, it was 2018. And what they said is very, very interesting thing that really hooked me back to the machine learning. It's not just for .NET developers. We also did need to have machine learning experience. And I was like, yes, I want this. I don't want to learn everything about machine learning, not at the beginning. Later, when I have something working, sure. And when I looked into ML.NET, I was like, oh, okay, this is Microsoft Machine Learning SDK, works offline. That really resonates with me. It's simple yet powerful, like all .NET libraries should be. It's already been powered by a lot of Microsoft products already when it was launched. Now it's being powered by a lot of different various scenarios, which I'm sure we're going to hear a lot today. If you already have a data scientist and they're already doing machine learning, it already supports some of the machine learning models like TensorFlow and Onyx. So you don't actually need to use ML.NET to train your own model. And in the end, what hooked me the most at that time was it has one of the most powerful samples in GitHub that I managed to find at that time. There was the GitHub issue classifier. I literally just swapped their Excel with my Excel, removed a couple of columns, and I was just like, wait, did I just done what I was trying to do for so many years? And it's done in less than an hour.
Sorry to interrupt you there, JK. Would you be able to hide the notification up there? It seems like it's blocking some of your slides.
I wasn't aware that was actually visible. I thought it was from StreamYard.
No, thanks. Yep, looks good. Thanks.
So yeah, I managed to successfully build a solution in an hour just by going to GitHub project, replace an Excel, and bang, done. And this is why I'm so really hyped up about ML.NET, because it managed to get me into machine learning really, really quickly. And that's also what I'm seeing with a lot of people that I show ML.NET, that they actually are able to get into machine learning and start learning the more difficult things about machine learning after they start to understand, oh, okay, that's how it works. That's all of the caveats I need to understand, and understand how now things can go wrong because I have an actual thing that works for my scenario. All right, now hopefully I got you hooked so that I can take a step back and show you what machine learning is. So, because at the end, I'm going to show you that ML.NET Model Builder can do everything I'm going to show you right now, just in a couple of clicks. But if I show you this now, you won't appreciate or understand what's happening. But if I show you this now, you'll be like, oh, all of this stuff just happening in a couple of few clicks. So let's go into the machine learning. So to best understand what machine learning is, the best explanation I managed to find is to compare it with classical programming. So first, if you look at the classical programming, we have rules and we have data. If you're a developer, you might get rules as specifications for a specific feature and data like inputs in your form. And then you write rules, and when you process all of them, you get an answer to the user. Now with the machine learning, it's a little bit different because you need to have all of the data as well as answers ready ahead of time. And then you put that into machine learning, and then as a result, you get rules, which you can then use in classical programming, for instance, to get the right answer. So you wouldn't need to write the rules in the classical programming. So it's kind of like a reversed from the classical programming. And to give you an example, I think rock, paper, scissors is something that a lot of people understand. So if you have rock, then paper will win. If you have paper, scissors will win. And if you have scissors, rock will win. And here we have the logic written in a classical programming. Now, if we do this in machine learning, we'll have a little bit different, because what we're going to have is like an Excel sheet, and we'll have on one column, it's going to be opponent and some of the combinations that the opponent can do, and another column that we have the winning combinations. So we're not telling the machine learning the rules. We're just saying that for this value on this column, you should get this value on that column. And this is a very simple example, right? But what if we complicate it a little bit? There's a game called Rock, Paper, Scissors, Lizard, Spock. And now if we add new rules to it, which no longer goes one-to-one, but you have that, say, scissors can not only beat paper, but can also beat lizard. Now, the classical programming would be a little bit more difficult, but for machine learning, everything remains the same. We just have an Excel with, for what opponent gives you, this is the winning combination. And you can add as many different rules as you want, and the machine learning will learn from the examples. And this is where the power of machine learning comes from. It basically tries to learn from the data that it has, rather than you needing to write it manually. All right, and you might heard about machine learning being able to improve over time. So how does machine learning improve over time? So what we do is, first we have training data. Imagine that Excel that I showed you for tic-tac-toe, sorry, not tic-tac-toe, rock, paper, scissors. And then we put it into a machine learning training algorithm. And then we get out of that a model. You imagine that model to be like a zip file that has the rules of determining that scissor, that for scissor, give paper. Now, this is not where the story ends. We now need to deploy it to different devices, like desktop and mobile. We need to deploy it to web. We need to deploy it on IoT Edge. So we can use that model. And this is where ML.NET is really good, because we can actually deploy on all of those devices. But this is not where the story ends either. Once we use this model in production, we can actually get feedback, whether it's that from the users who uses our application. It might be, for instance, from the IoT devices. Say that our drone has flown in conditions that hasn't flown before. It can give us the feedback how it behaved in those conditions, so the next time it could improve. Then what we do is we collect all of this feedback, we try to improve that data, and we trickle that back to the training data. And this is how machine learning gets continuously better. So if you ever wondered, okay, machine learning does get better, but how? I hope that you now have a better understanding how the whole cycle works. All right, so now I have talked about machine learning from BERT's view for quite a bit. But what is actually machine learning? Like, okay, it does learn from data, but what specifically is machine learning? And to better understand what that is, we should look at different categories of machine learning. For instance, the simplest one is supervised learning. What it means is, like, we have rock, paper, scissors. We had labeled data. So for specific columns, we have a specific category that we want to target, or a particular value that we want to predict or forecast, and that's labeled data. We want to get from one data to another data. The simplest example of that is classification. Say, for binary classification, we want to determine if a tweet is positive. If it is, it's going to be yes. If it's not, it's going to be no. Multi-class classification would be if you want to determine what apples do we see. That is usually supported by decision trees. Then we have regression, another subcategory where you can use it for house predictions, stock price forecast, and things like that. And then we have unsupervised learning, which is unlabeled data. That means that we don't specifically tell the machine learning what we're looking for. We're trying to determine that indirectly. So let's go to just a moment. And one of those examples is clustering. A most popular example of clustering is product recommendation. So we're trying to find, for instance, buyers that purchase similar things. So we cluster them together, and then we can say, okay, for this purchaser that buy all of this stuff, other people in the similar group bought all of that other stuff. So we can do a recommendation for the things they haven't bought yet. Then we have dimension reduction, for instance, which allows you to reduce the complexity of the data that you have. And that can allow you to auto-generate graphs or optimize your data for faster processing. And the last one, the last big category, is reinforced learning, which I believe we're getting more and more nowadays. It's a machine learning that basically tries, fails, learns, and then repeats until it masters specific tasks. And that would be, for instance, self-driving cars. That would be in robotics, for instance, if you have looked at the robotics, dynamics robotics, I think it's Boston Dynamics. They have to use reinforced learning a lot. And in games, we're getting more and more reinforced learning. And it's really cool because you can actually make the AI learn on the fly, which is great for gaming. And this is just a oversimplification, just a couple of things that I cherry-picked from the machine learning. There's a lot more to it. And before I move away, I just want to give you a little bit of glimpse of what it means. For instance, if you want to do multi-class classification in this machine learning path, if we look at what you need to do a multi-class classification, you will come to terminologies like trainers or training algorithms and stuff like that. And in ML.NET, for instance, you have all of these trainers available. You don't have to know what they do and stuff like that for these purposes. But basically, each trainer is specialized for different kind of data. Some is great for big data, some is for small, some for repeatable data, some for unique. And you can read about the trainers if you're interested. There's cheat sheets for that to figure out which trainer you might want to pick based on the data you have. But we don't actually need to know for this particular case. It's just for you to know there's a lot more about machine learning than just this. Now, ML.NET allows us to access most of what we see here very simply. Right now, unfortunately, reinforced learning is not available, but there's a couple of .NET libraries available that allows you to do reinforced learning if anyone is interested in that. All right, so if I want to get started with machine learning, now let's put aside frameworks and stuff like that. If I just want to learn what type of machine learning I need to look at, how do I start? Well, the simplest way to figure that out is to find out what is the scenario you want to achieve. So what would be a scenario? Well, is a tweet positive? Well, that would be binary classification, how much or how many of something you want to figure out. Then categorizing bank transactions. That would be multi-class classification, what category you want to choose. House price prediction. That would be regression. Again, very similar to a tweet, how much or how many, but just getting a bit differently. And product recommendation. That would be clustering, which group the specific data belongs to. And there's few caveats when you start with machine learning. Machine learning won't magically solve all of your problems. You kind of have to understand your data because you have to guide machine learning toward the right solution. I'm going to show you in the real demo roughly what that means. And you should start with something simple like classification. In our case, we're going to start with multi-class classification, but you can also start with binary classification. That is fine as well. All right, so now the fun part, finally, ML.NET Model Builder. Now, remember how at the beginning I said the ML.NET allows you to apply any machine learning experience. And when you go to ML.NET, you used to have this page where it just shows you all of the possible scenario that you should start. That's the first thing you should do is like, what thing I want to build first. And when you go to ML.NET Model Builder, that's also roughly the thing that you get. And when we look back into the original flow, we had training data, ML training algorithms, and then model. ML.NET replaces this middle part. We still need to have training data, and at the end, we'll get a model, which we then consume in the application with help of ML.NET. We have a bit of a problem if we just start directly with ML.NET SDK, because it kind of wants us to select what kind of trainer we want. So how do we solve that? Well, ML.NET Model Builder comes to the rescue, which essentially is just a wizard for ML.NET SDK. So it uses ML.NET SDK and it will generate the code for you. And what it does, it will pick up the best trainer for the scenario you want to pick. And it will also change over time depending on what data you put in. And what I'm going to also show you, it allows you to do really quick prototyping. You can quickly change the shape of your data, what do you want to ignore, what do you want to change to something else, and I'll show you that as well. To get started with ML.NET Model Builder, I'm going to show you the Visual Studio variant of the ML.NET Model Builder, but you also have VS Code version, which is supported on Mac, Linux, and Windows, as well as a CLI version of that, which is also supported on all of the platforms. And to get started, I believe you still need to search for preview features in Visual Studio and just make sure that you have enabled ML.NET Model Builder. And if you don't have that, you can just go to the .NET Microsoft.com apps, machine learning, AI, ML.NET. But the easiest way is just to type ML.NET, and it's usually the first link. So that's the easiest way to go. And you go to Model Builder and get started in case the instructions are a bit out of date. All right, now let's get started with the demo. And what I'm going to do is I'm going to have a pre-existing data set, which is going to be from a bank that I use, then migrate it to a financial app that I used for years, where I manually classified all of the data and then export it to CSV so I can import it into the ML.NET Model Builder. And this is what the table looks like for the ML.NET that we're going to use. We can see here we have dates, we have account, that is credit card or debit card, the category, the one that we're most interested in. Tax, this is a little bit tricky one because it's a column that I manually edited in the application. So this one can cause a little bit of problem if we want to do automated machine learning. Then we have expense, we have income, in this case it's all zero, the currency and all of the other details. And at the end, this is the main thing that I want to use to for classification, is the description of the transaction. So this is going to be our main focus. All right, finally, demo. So let's go to Visual Studio. I already have prepared here a project. And just to verify that you have the extension installed, just go to the here, ML.NET, just type ML. Just make sure that you have ML.NET Model Builder installed. And if you don't have it, you can just search for preview and preview features and verify that you have enable ML.NET Model Builder. Now to get started, we right-click on a project, we do add, we go machine learning, and what we'll get is picking up a scenario. What do we want to actually build? Now, over here, we start with text classification, which is the multi-class classification, value prediction, which is regression, image classification that uses TensorFlow, another machine learning library. Then we have recommendation that is clustering, and object detection, which is done on Azure. If I, for instance, go to image classification, you can see that I can actually select multiple environments, but most of them right now only supports CPU. And if I scroll down, you can actually see some limited scenarios. So for instance, if you're interested in forecasting, which is predicting a value that will be in the future, unlike value prediction, which tries to predict what price would be based on parameters, you can click on this and it will redirect you to a URL to a GitHub sample that you can then clone and then retrofit for your own scenario. As far as I know, I believe Bree will confirm that all of these scenarios are later going to be supported as full-fledged scenarios in ML.NET Model Builder. So you can use it without, you can do these samples without writing any code. All right, let's go to text classification. We select the CPU, and now we start here by adding data. we're going to start by adding unfiltered bank transactions. You can also select SQL. Let's just go there. You can connect to a SQL database. I got a CSV, so I'm going to stick with CSV. I think I'll need to just quickly do that. And what I want to do next is predict, select what columns I want to predict. In this case, it will be categories. And over here, we can see a couple of lines of code, a couple of lines of data, 10 of them, what we're actually importing. So we can verify if this is the right data that we want to process. I'll now go next. Now here, if you don't know how long you should do processing, you can just put 0. You get this nice pop-up telling you rough times how long to process. It does suggest 10 seconds for under 10 megabytes. I would say for this particular machine, I'll just put 30 seconds. And now we can see down below, over here, that I started training. You can see the trainer. So this is the missing piece with the ML.NET that you need to know which one to use before you can start using, say, multi-class classification. ML.NET Model Builder does that guesswork for us. It actually takes the data, tries to figure out, okay, which trainer would be the best, and then tries to run machine learning algorithms on it. We got a result. It believes that average perceptron over is the best. Now, I can put a little bit more time. I think I would need to put 2 minutes because I'm streaming and all of that stuff to get more machine learning algorithms, but generally the first one is the best one. And I'm going to go next. I'm going to hide here. And we are now at the evaluate part. Now we actually have the model. Now we could just go next, 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 and we'll get to the code. But we can actually try out how our machine learning model actually works. So for instance, I can do predict, and we get the right prediction. Now, the interesting thing about this model is, if I write some gibberish here, and I do predict, we have the same accuracy, 98%. And let's write some gibberish here as well. Same value. Here we can write the same same value. Almost looks like it doesn't matter what we write over here. Okay, it seems to matter 1% for this one. Let's do this. If date. Okay, dates seem to do something, but I don't really. Okay, if I put it in a lower, in a date that was roughly at the time that the transaction happened, there's no difference. So what that actually tells us that most of these columns actually are not required. So what I can do is I can go here to advanced data options, going back to data, and I can look at the date and I can say, okay, not only we the ML.NET Model Builder for multi-class classification does not have a specific date type, we actually don't need date types, specific dates and times in combination of those two for multi-class classifications. A more useful type would be day of the week or month or quarter. That is useful for the multi-class classification, a data that repeats itself. Something that is constantly unique or incremental actually is not that useful for multi-class classification. It can actually make the results worse. So I'm going to Ignore that. I don't really want to depend on what credit card or debit card to use, so I'm going to ignore that as well. Income, it's constantly 0, so it doesn't matter. Now, in this case, expense amount in currency are the same, so I can safely ignore one of them. So I'm going to ignore the currency. In main currency, we don't need it. It's constantly Australian. Yeah, this one as well. And now when I save, we have nice smaller model. Now I can go back. I can train again. Now I'm going to train for 15 seconds. Hopefully the machine is not going to get too busy with streaming and get us the model within 15 seconds. Also, if you have any questions, you can write on the YouTube comment and I'll have a look. All right. Actually, we can see that the training speed has increased significantly. We went from 13 seconds to 10 seconds. So that's because the complexity of training has reduced significantly. Now, if you try to predict, we have still a very high accuracy. Now, somebody who have remembered that I mentioned something about tags, you might have remembered this particular column has been entered manually. And this is something that will likely be empty when I actually get this transaction. And that means that this tag actually is not reliable. In fact, most of the time, we'll end up with wrong results because it will expect those tags to have a certain value. So for instance, if I put a different transaction, there's a good chance that it will not know what it is because it has too high reliance on the column that we no longer are able to have the right value because we entered them manually when we dealt with that data. So because of that reason, we need to go back to the data. We need to go ignore, save. And now finally, if I go 15 seconds, train. And we should get the model here. Yeah, it took 9 seconds. Nice. It's almost a second faster. Now, this has a little bit less accuracy, but 80% is still pretty good accuracy. And now if I put something else, it will now treat the .NET Foundation organization as investment, or you could say, yeah, investment. But there's still a little problem with this model, and this is where a little bit of data science and playing around comes in handy, is what happens when I starting to change the amount. So at 1 0, nothing significant changes. I add another 0. Actually, it has a better accuracy for some reason. I add another 0. Now it thinks that it's something health related. Okay, that's strange. Now I add another 0. Oh, okay, now it thinks it's a transfer and it thinks like 18%, there's a couple of other things. Now what's going on here? Why adding zeros all of a sudden the machine learning wouldn't work nicely? Well, that's because we have a lot of transactions that are biased toward its specific categories like health or what we had previously, transfers, and yeah, health and transfers. It will gear toward those categories because these ones had high values. So it will make an assumption that if it's high value, it's probably that. And it will ignore the description, which should be the main thing that should look. Now, you can solve these problems with data science, make more balanced models and stuff like that. But you can ask yourself, do I actually need expense amount. And after doing some experimentation and stuff like that, I realized, no, I don't need it. I actually only need descriptions. So when I do another training, I should end up with a machine learning model that literally gets one string in and one string out, which is really awesome. So over here, we literally have just one string. I can replace this. I can see that it's very certain that is investment. I can say remove a good chunk of this, do predict. It still thinks it's a prediction. I can take this text, I can make some random stuff of it because, you know, in bank transactions, those numbers do change. It still works. It still thinks it's investment. In fact, I can remove most of it and it works. It's like magic. And once we're happy with machine learning, now that we managed to do it like sprinkle of data science, experimented with data, trying out some extremes, and then realizing, hey, we don't need that data, we don't need that data. You could even go to, say, the actual Excel. You could open it up. You could fix some of this data manually. You need to close the Excel before you try to retrain it. Because Excel is keeping the file locked. But you can just do this cycle of quickly retraining, trying out, and then trying again without needing to ever write any code. You don't need to generate new application. It just works. You just experiment until you're happy with the results. And at the end, what I do is add to solution, and then optionally, if I want to do this as a web API, I can deploy this model to Azure, for instance, or if I want to learn more about data science or how to improve machine learning data or how to improve the data, there's also a link here to documentation for that as well. But for now, let's focus on what do we get. So I'm going to change the project to be the newly generated console application over here. And the console application is very simple. It generates the input model, which is the description of the transaction. We run this consume model predict with this input. We get the prediction result out, and then we output it. Now, if we run this, we're going to see that for Spotify, it thinks it's leisure. Now, it doesn't quite support emojis. I think it's because of the console application, not the actual machine learning, ML.NET. I can also change this to something else. For instance, I can change it to this. And it will work as investment. Now, what I like to do for this demo is I like to replace this output with this output. So all I did right now is just replaced how we display data, how we replace the response, because now I can show you that those lots of numbers that you've seen previously actually are mapped to specific category, original category that we have previously. So here I can clearly see that for most of the categories, there's a very high probability that it is that category, but for the investment, it is a very high probability. And if I, for instance, change this to this one, which is going to be, why is it not copying? I have snippets on my other screen. It should be, yeah, this should be home utilities, the ANZ internet banking, sorry, the BPay vConnect. So yeah, you can see that, I can just change a couple of things. If you want to drill in, you can see that the predict is just a static class in this model that you can share in your Blazor application. You can share it in your web APIs, in your console applications, Xamarin, MyUI, whatever .NET application that supports, I believe it's .NET Standard 2.0. We can actually verify that. Yeah, .NET Standard 2.0. This should work. And as far as I heard, we also might get some support for more scenarios. I believe we have right now the ability to do multi-class classification on existing trained model, but we might get a little bit more later on. All right, so with that, go back to the presentation. Now, you might also want to run all of that, what I just told you, in command line. For instance, you would love to run this in GitHub Actions or in Azure DevOps as part of deployment. You want to generate a model. Well, for that, we have a AutoML CLI, which is very similar to ML.NET Model Builder, but in CLI. And it works on Linux, Mac, Windows. And it's literally the same thing that the model builder uses behind the scenes. So here down below, I'm showing you just an example how to use the ML.NET CLI to get identical result than what I've shown you in the ML.NET. And lastly, I want to show you is, so over here, I have a live demo on this GitHub where I'm using the ML.NET SDK to run it locally on my browser. I can go offline, and this is still going to work. And I can use the prediction inside the browser. So this doesn't have to be locked on your web API. You can actually push this to your browser. For instance, if you go to Network Pane and you refresh, I'm literally downloading the model zip file to the browser so I can use it offline. So if you want to build something like that, you can. All right. In summary, what I have shown you is how you can import CSV to the ML.NET model builder, how you can tweak columns and and use a little bit of data science to get a lot better results, the ending model, and how you can then generate the project and then use that machine learning model. Oh, and you can now run this in all of the .NET Core application. And I can happily say that I have a solution that in the background gathers all of the data and over time adjusts how it categorizes all of my bank transactions based on the feedback that I give it back. So if it doesn't classify something correctly, I just fix it once, it retrains, and then next time it will get it right. All right, so that's everything from me. Do we have any questions?
That was awesome, JK. Thanks for that. The Blazor demo really is always really amazing to me.
Yeah.
I will take a look in the comments. If anyone has questions for JK, please post them now. I know a few people commented on the Blazor stuff. There's just a question, Blazor, question mark?
Blazor. Okay, so if you're familiar with Angular, React, Vue.js, this is something like that, but in .NET.
I think they knew it was Blazor. I think they were just very excited that you could use it in Blazor.
Okay, yeah. So you can use it in Blazor. This is an actual Blazor application, and I can show you that that's the truth, because we should be seeing DLLs. Where are the DLLs? Interesting. I am showing all. Well, you can see here blazor.webassembly.js. Usually there's a lot of DLL showing over here.
So beyond maybe for like presentations, what would be some use cases for using ML.NET with Blazor?
All right, so a use case that I'm currently developing for myself is I'm doing a home automation for my home. And what I want to do is I have smart plugs that can track electricity usage. And I want to do kind of two things. One is to figure out in what power state different devices are. For instance, is my desktop in usage or not? Is it in hibernation? Is it sleeping? Is it being used? Then, for instance, Xbox, is it currently idle? Is it updating? Am I using it, and stuff like that. So I want to be able to kind of do clustering of those different states automatically based on the device type. So then I can smartly turn them off when they're not in use. And another thing I want to do as a combination of that is to do like a pattern recognition. For instance, if I turn on Xbox, I play it for a day, and then I don't play it for 3 days, and I do this pattern for a couple of times. I want to be able for the machine learning to figure out, okay, JK is playing console, and then after it turns off, it won't be using the console. So once the console is not in a state that it would be updating, it's in idle state, turn it off after a day of not using it, and then turn it back on a couple of days later. So that's kind of the things that I want to play around to do. There's a lot of other scenarios. There's one client that wants to use it for forensics, which, if you have a company that does a lot of shady stuff, how you can figure out what's the difference between a company that doesn't do shady stuff and company that does shady stuff, based on the public data of what charities they're putting transactions and what frequencies and which charities and stuff like that. It's really fascinating. There's so many scenarios that we would need to pick a topic before I can start talking about the details. But these are a couple of things that I'm currently working on.
That's awesome. And this particular demo, is it available to the public? Can people check out this demo?
Yes. So this one actually uses the SDK directly, not the ML.NET model builder. But I do have, I do have, where is it? I believe it's this one. I do have instructions on how to replicate my demo. And it has quite a few of the same suggestions, although I do need to update it a little bit.
I think, you'll need to make a few updates, which actually that leads me to this question. So Andre asked, is there any difference between Model Builder available in VS 2019 and the Model Builder that is available when we fill out the form with the sign up for the preview thing? And I can answer that one. So right now we have a kind of a preview build with a private NuGet feed. We're just gathering feedback. Anyone can sign up for it. It's just a little more complicated to set it up. So those changes were not reflected yet in JK's talk. So JK, you'll definitely have to update your talk next time. But we're for build, we plan to release that. So it's just in the public NuGet feed with the new features. So a lot of the stuff that JK showed, all the stuff JK showed will be there, but then there'll be, exactly. This is the newer version here.
Yeah, I wasn't quite sure if it's safe to do it yet.
Yeah, exactly. And that's why it's in preview. So totally makes sense. By build, we'll have that out, and JK, you'll have to update everything. Hopefully that's a good thing.
No worries. I prefer for things to update over time and getting better than having been static. Like, I've been using this since 2018, and I can say there's been massive updates to ML.NET. It's become a lot better in these 2 years, actually 3 years, and it's incredible journey to see all of the changes. There's been a lot of feedback that we gave and been implemented, and I'm super happy now. I'm showed this to a lot of people, and they are also very happy with it. And I hope that everyone that watched this session and all of the other sessions later, you'll see a lot of cool things.
Yeah, definitely. And I mean, all the great changes that we've made has been because of you all, right? Because of the community helping us drive the direction and telling us your feedback and what you want. So continue to do that, and thank you for doing that. And we've got another question here. Where did it go? Oh, so what about Xamarin? Is image classification supported? Do you want me to answer that, or do you want to answer that, Jake?
Yeah, you can answer that.
So I guess it depends so these are kind of two questions. So within Model Builder, you can train image classification models. You can train both locally on your CPU, locally with GPU, or in the cloud with Azure ML. And you can see that actually on JK's screen right now, that image classification is there. We also have an image classification API for training that runs on top of TensorFlow.net. So it uses a process called transfer learning. So you can train custom image classification models. And so for Xamarin, kind of. So there is a big announcement coming up for Build, which I will let you all in on since you all are awesome. And maybe I think I might have announced it before, but for Build, we plan to have ARM support, ARM64 support for training and inference. So that is a big one that people have been asking about for a very long time. So I hope you all are excited about that. And that will be, I think Build is May 27th, I want to say 25th through 27th. So that'll be one of the big ML.NET announcements there.
Yeah. And yeah, that's one thing that I really wanted, because I want for people to not only be able to just play around with the model that is in the browser, but being able to upload their own Excels, do the training, and then play around in the browser, allowing people who want to follow the things that they do, just do them live.
Right. Yeah.
For us presenters, that is really awesome for others to get that learn, and for others, for the electricity example that I mentioned, that means that you can take your phone, hook up to a service that takes the electricity usage, and then do the machine learning on your phone, for instance, say machine learning clustering on your phone without needing to connect to Azure services.
Yeah, it's really exciting. We're also working on more Blazor WebAssembly support. That one's a bit trickier, but we are working on that as well. But yeah, the ARM one is pretty exciting. So we have it already working also on the Apple M1 devices. So yeah, so look forward to that. And actually, it's open. ML.NET is open source, so you can take a look at. Michael Sharp is the one working on this. He's been doing awesome work. So you can check out, what he's been working on, and yeah, and I think there's a whole design doc for it on GitHub. So yeah, very exciting. Any last questions for JK? We've got a few minutes before our next speaker. So we'll see in the chat.
Yeah, and if anyone has any questions, there's a Slack for ML.NET. You can join that. And I'll be still awake for about half an hour to watch the stream, and I'll look up for any questions.
Yeah, and we just posted a comment, but we want to get feedback, and I'm sure JK would appreciate feedback on his talk for anybody who is here watching. So, we have this feedback form. Feel free to fill it out. and leave some feedback for JK and just us in general. And it looks like, yeah, catch JK on the Slack. He has his Twitter handle there. Can they reach out to you on Twitter?
Yes, exactly. So you have Yannick underscore Kafka. Unfortunately, I wasn't able to get the JK one.
Awesome. So thanks a ton, JK. This was awesome. Great kickoff for our the rest of our conference. And I'm sure we'll be seeing you soon. And I'll get Louise back on here, and then I'll be taking you off the stream. Bye, JK.
Well, thank you for having me, and have a good night. Well, good morning.
You too. And we've got Louise back. You're on mute, Louise. Come on.
Of course.
Year and a half already.
At least once. Well, that was really great. Thanks, JK. As always, awesome talks here. And you know, we saw that a lot of folks were joining from all sorts of places. I believe I saw Germany somewhere, Sudan. So thank you, folks, for joining us. We're really, really happy to have you here with us. All right, so we are ready for our next talk, and let's bring Priyanka here. Let's see here. That's the stream. Hi, Priyanka.
Yes.
How are you doing? Thanks for joining us. So Priyanka is going to be talking to us about using BERT with ML.NET. So for folks who you know, want to use this sort of new state-of-the-art model and are interested in how you can use it with ML.NET, Priyanka is going to show us how. So with that, let me sort of remove ourselves and just before we sort of start, if you could click the hide button there, that way you know, it doesn't block your slides. Yep, that would be great. Awesome. All right.
Okay, so I'm starting then. It's visible, right?
It is. Yep, we can see your screen.
Yep, my screen is visible, right?
It is, yes.
All right. Okay. So thank you, Luis. Thank you, Bree. And yeah, so great event. I'm also excited to, to hear the other talks as well. And very, very good evening, good morning to all of you. Okay, so it's night here in Singapore. And yeah, I'm excited to be talking about how we used ML.NET to leverage the state-of-art NLP model, which is making waves right now, which is what we call as BERT. Okay. So yeah, so this is what the session today will be about. It is about a bot for question and answering using BERT. It is a specialized trained version using SQUQD dataset for question answer purposes. And also, if time permits, we will also delve into FinBERT, which is for exclusively analyzing financial statements. We will sentiment analysis of financial statements. So we will see, you know, why we need a specialized model like FinBERT for that purpose. And both of these implementations, we will see how we use ML.NET and how ML.NET facilitates a great way to use a SQUQD and FinBERT. So this would be how the presentation will flow today. We will discuss about the real case business scenario which we are facing, and you know what made us look into using Q&A BERT and why ML.NET. Okay, so quickly we'll run through the BERT basics, which will just touch upon that because this is not something, you know, which we are going to learn today. We are not talking about NLP or BERT today, but we are more concentrating on the ML.NET implementation of BERT. So how we use that. So yeah, so this is how it will go. So the current business problem statement which we are facing is, you know, we are an investment house, all right? So asset management and investment house, and that's why what happens typically is we have analysts, research analysts, and portfolio managers who will have kind of, you know, small documents running maybe a couple of pages, or you know, maybe 5 to 10 pages, which they call as call reports, which are like some testament to how the client is performing. So some information about client, like, you know, the stock holdings, the current financial condition of the client, the current geographical and political situation in which the client is situated, all those sort of things. Who are the major stakeholders? What is the future? What was the past? Why should we invest in this client and sort of stuff. So it's like a research document, okay, and that will be uploaded into the system, and that will be reviewed by portfolio managers, directors, and all to make suitable investment decisions, stock investing and stuff like that. Okay, so typically the data we have collected is maybe over like 10 years, and we have more than 5 million of these call reports, which we term, and they keep on accumulating like every quarter, right? And portfolio managers, when they are going to look for these particular call reports to make some informed decisions, they will not, I mean, most of the time, because a particular company, the scenario might keep on evolving over the years. So let's say, given the pandemic situation, maybe pharma companies and IT companies and e-commerce companies, their share prices surged a lot, or their financial situation, stock situation, share prices situation changed a lot. And so hence these call reports will also keep on evolving, right? So when portfolio managers are wanting to search some stuff, they will ask very specific pointed questions like, what was the market share of TSMC in the last quarter, or what is the shareholding structure for Tencent Music, or what is the current initiative for Tesla and stuff like that. Okay, so the before BERT and stuff, so we have been working on this project for like the past 5 years and approximately. Okay, so we implemented the classical Q&A bot with the Azure bot framework, right? So which means we uploaded all the FAQ documents, so most of the questions which the analysts or the portfolio managers are bound to ask, those sort of things. We also tried to implement LUIS, okay, but given the sheer amount of information which we have, and the amount of and the ad hocness of the questions which the portfolio managers or directors or end users can pose to this particular use case, is totally like limitless possibilities, endless possibilities. So you cannot really sit and make rules like, if they ask this, then they should point to this document and stuff like that. So it needs to be more than just a solution with Q&A and LUIS. So we need to understand the context of the question which the portfolio managers are posing, and then accordingly search the answer within all these humongous amount of call report documents or text corpora which we have with us. So the workable solution, the robust solution which we look at, it will need an understanding of the statement, right? So there are other AI-based solutions out there using NLP or using LSTMs, right? So long short-term memory, neural networks, and so LSTMs and all. What happens is LSTMs will suffer from short-term memory. So which means if your text is running into pages and you are asking about something which is connecting your first page to the third page, then that long context cannot be remembered by LSTMs to answer a very coherent to give a very coherent answer to the question. So for example, if you pose very specific questions, like if you have a paragraph describing the shareholder structure of a particular company, and the question is, who is the major stakeholder, or who is the major shareholder in this particular ABC company, then when the question is very pointed and sort of very crisp and specific, LSTMs will still give you the answer. But let's say, for example, there's one page where you're mentioning a stakeholder, but then by the third page, the context has changed, and maybe due to some business scenario changes, the shareholding structure has been now changed and modified, and then you pose a question, LSTMs will not remember that long a context, right? And then, of course, another classic example which we have is confusion between words. Like if we were to classify sentences, so consider the two sentences given here, like her skills with hockey stick made her stand out as a player. And the second sentence is her skills with the jockey stick made her win the competition. So now the first sentence is clearly something related to sports, outdoor activities, whereas the second one is related to technology and gaming. LSTMs won't be able to classify the above sentences differently. They will try to put them in the same, in the same class, right? So these are the few limitations which we suffer with the existing solutions, even word2vec for that matter. So word2vec, when you look for word embedding, sentence embeddings, we came across a lot of shortcomings. So I published a blog on that. I'll share the link at the end of this the session. So all the solutions we implemented and what were the shortcomings and why we went for ML.NET and BERT. Okay, so when we talk of BERT, which is bidirectional encoder representation with transformers, right? So it is nothing but just imagine it as a deep neural network. So within the hidden layers could vary anywhere between 12 to 24. Okay, so it has been trained on a huge text corpora, and for various scenarios, like you have QA BERT, you have clinical BERT, you have distill BERT, you have Roberta, and lot of other variants out there. Cybert for scientific publications. So a lot of versions out there for different use cases. And they provide you pre-trained versions, pre-trained models, which you can then use transfer learning, fine tune on your own data set, and then customize it to your business case or use case. Or maybe if your the pre-trained model itself is enough to address your purpose, then you need not even fine tune it. You can use the pre-trained model as it is and then start using it on your for your use case. All right. So yeah, as I was mentioning, these BERT versions. So you have the pre-trained models, which is BERT, video BERT, bio BERT, cybert, clinical BERT, transbert, gbert. Okay, and then you have a lot of other sample use cases for that. So video BERT is used for video captioning, predicting the given a set of videos, analyzing what it is for and stuff like that. And they are used across. So FinBERT, as I was saying, is used for financial statement analysis. All right. So these are all the BERT versions out there used for different purposes. Okay. And in BERT basics, just remember that compared to all other models out there, which is LSTMs, or we have GLOVE or ULM Fit and all those existing NLP models, the major difference is BERT will parse the text from both the sides, like left to right and right to left. So you can consider it as bidirectional or even non-directional. Okay. And it uses attention mechanism. So attention mechanism is like it will try to think about the context surrounding the word. So for example, if I'm talking about a green apple, for example, then that apple, so green apple, so it will try to always try to predict, like if given the apple, green apple or green and apple, then it will always try to give more attention to what we are talking of, like she was eating a green apple. So when you look at the word eat, then of course it will try to assume that the next two words or the next couple of words would be talking about that eating stuff. So yeah, so this is kind of it makes use of the attention mechanism to learn the contextual relationships. And because when it comes to context, right, you need to know the context, like for given a word you need to predict the next word, or given a question you need to pass the text and give the correct answer to that. So which means you need to understand the contextual relationship between words, for which a very very simplistically put, it will be passing the text from left to right and right to left using the transformer encoder mechanism. Okay. And so this is sample use. I mean, this is a sample working of how BERT is used to predict the next word or the next sentence and stuff like that. And this is exactly what we will be using also in our ML.NET programming. Okay, so when we are building an algorithm using ML.NET, so these are the essential BERT basics which we need to understand. So what happens is each start of the sentence, it will have a kind of a token. So that is to mark the start of the sentence, right? Start of the sentence. Then each sentence is marked by the separator token, which you see as SCP here. So the SCP token which you see here, it is a sentence separator. It will be trying to differentiate between like the first sentence, second sentence, and stuff like that. And then randomly, so it is also using something called as MLM, which is like mask language model. So mask language model, what it does, it randomly within a particular sentence, it masks 15% of the words, okay, 15% of the tokens, and then tries to predict it. Also, it will do a next sentence prediction, which means is, for example, if my if the sentence is like my dog is cute and his color is white, or my dog is cute and he is very fluffy, so it will also try to do this kind of next sentence prediction, true or false, like which is the first sentence and is it a logical continuation to the next sentence or to the previous sentence. So this also it will try to do. So mask language model, this we are also using this in our ML.NET algorithm, which I'll share the source code also, and the next sentence prediction, which is like, is it a next sentence or not? Okay. So now jumping into with BERT Q&A. So let me just make it clear that, this is a very brief overview of how BERT works. So BERT in itself is a very huge in-depth topic which can be covered over a separate session altogether. So because our target is more about Q&A bot and BERT, and I just wanted to show you that this is what we are going to be also using with our ML.NET source code which is given. So that's why this was essential that I at least show this, that how we are masking the tokens and how sentence separator and CLS tokens and start of the sentence and all is used in BERT. Okay, so now when we are using BERT Q&A, okay, so in Q&A we have the squad data set. So squad data set is pre-trained on a lot of pre-existing question sets out there. Okay, and the squad data set is available as a ONNX also. So online neural network exchange is a format where you can consume the model between different platforms. So let's say you have a model which is built using TensorFlow, Keras, PyTorch and all, and that you want to consume it in our ML.NET. So then or Azure machine learning platforms. So you can convert them, so it's interoperability between different platforms. So squad, the squad model is available in the ONNX format, and which directly we are using here in our ML.NET. Okay, and so for the question and answer, right? The question and answer BERT, the basic criteria is that we have a BERT, and then there is an extra vector that will tell us the beginning and the end of an answer. So what constitutes the question, what constitutes the answer, that sort of thing. Okay, so this is about a brief about the squad data set. So you have about large scale label data sets for reading comprehension. Okay, and there are about million 100,000 answerable questions, 50,000 unanswerable questions from a set of Wikipedia articles, and then it has been adversarially written by the crowd workers. Okay, so that you don't have just like very specific matching answers, right? So there's a lot of effort done for building a robust squad data set. Okay, and so in our use case, normally we are not going to use the fine tuning later on. So normally with all the BERT models out there like Roberta, DistilBERT and FinBERT and all, what we typically do is the pre-trained model, we just download them or we just consume them, and then on top of that we fine tune on our own custom data set. But for our purpose, like because our document size was not that huge and it was not very specific also, right? So whatever domain knowledge is out there, we are not doing anything different from that. So we didn't do any fine tuning for our purpose. So we just consumed the squad data set as it is, did not do any sort of fine tuning on our custom data set. We did add some words to our vocabulary. So the existing vocabulary within squad model which you have, we added a couple of, I think about 1,000 more words to the vocabulary to make it specific to our use case or our documents. But apart from that, we didn't do any transfer learning or fine tuning further. Okay. So I will, before going to the demo, let us see the source code because the demo itself is very, very straightforward. You just feed a question to the BERT model and you will get back the answer. Okay. But what essentially we are trying to do is, so if you look at that, there are two aspects here. So we have a BERT web API, and then you have the ML.NET model here. Okay, so BERT web API is just to consume the model which we have built using BERT here. All right. So you will see that, for the purpose of the demo, I have a web API method here, which is a HTTP get method. So we'll be passing the context, so which is a string, the paragraph which we want to give as a context to our BERT Q&A bot, and that this will be the question. The response we will get will be a token and with the probability. So token is the answer, we'll get back the answer, and with the probability. So possibly, there could be scenarios in which there are multiple possible answers as identified by the BERT bot. Okay, and then it will align them, it will give them according to the probability, the highest probability being first. So normally if it is a one single token with probability support of like 80%, 85%, and etc. But like if there are multiple tokens, because maybe there are really multiple answers, or maybe it was not clear on the question and on the context and the question, and there could be multiple tokens there, then it will order them by probability. All right. So this is about the controller method. What we actually do is, if you look at the, so this is, as I was saying, this is the ONNX feature for consuming the model which we have there. All right. So just to explain you a bit about ONNX, I'm very sorry that I forgot to include the slide for ONNX. So ONNX is online neural network exchange, which I mentioned earlier is like interoperability between different platforms. So for example, if you look at this is our C# application. Okay, so ML.NET is there, and then you have your model, which is which is created in using PyTorch or any other framework, and then that could be converted into an ONNX and could be easily integrated into your application. So fortunately, if you look at Squad BERT, there is already a ONNX version available for that, which we are directly consuming. In case of FinBERT, for example, there is no ONNX readily available version. So which in case, for which we are trying to convert the PyTorch version into ONNX and then trying to consume it. Okay, so more about FinBERT later, but this is what we are essentially doing here. So
hey,
if you
Priyanka, sorry to interrupt you there. Could you make the font a little bit bigger?
Sure. All right. Is this okay?
Maybe just a little bit more. Just a little bit more.
Yeah.
Yeah, that's perfect. That's perfect. Thanks so much.
Okay, no problem. Okay. So this is where our we are setting up the ONNX transformations. So these are the standard methods. If you so this is the ML context class, which is our a model context. Okay, so this is the transformer. So these are the standard features which you see with ML.NET. All right, and then you have something like, these are the BERT features. Okay, BERT features are nothing but like, for example, I was telling you, right? So we have the unique IDs, the segment IDs, the input masks, and the input IDs. Okay, so the model which you're consuming, so these are the sort of, what you can say, data columns for that, right? So you have segment IDs, you will have an input mask where we are randomly masking the input, 15% of the input tokens. You have unique IDs, input IDs. Okay, segment IDs are the segments, the sentence. Okay, so segmented sentences. Okay, then sorry. Yeah, so these are some of the methods in where okay, so let us look at the BERT configuration here. So BERT configuration is you're giving like the max answer length, the max sequence length, vocabulary file. Vocabulary file is where we have this vocabulary file. me check. Yeah, here. So vocabulary file is the vocabulary file which you have here, which is this file. Okay. So these are the words which you're which you're feeding. So this is kind of your dictionary, data dictionary. All right. So these are the words which we have. Which we there were a few which is already available out there, and then we have also annotated using the expertise, in-house expertise from our own data analysts, our own business analysts, fund managers, hedge fund, trading algorithm team, and all those things. So they have also contributed to this vocabulary. Okay. And for example, for some sentences, like for example, a playing. Okay, so that will be split into play, and so ing, so stemming, lemmatization, tokenization. So all of these things are taken care of. Okay, so that's why when you see this hashing here, so hash xing, so this is nothing but yeah. So this vocabulary is contributed a lot by few of the data scientists, data analysts, and NLP specialists, domain specialists in our team. Okay, so this is the vocabulary file here. Okay, and then you will have, yeah, so there are a few methods here, for example, where you're actually predicting. So in that predicting, what you're going to do is you're getting the sentence which we are giving the context which you are passing here. So if you look from our prediction controller, this is what you're doing, right? You're calling the predict method and you are passing the context and the question. So context is the paragraph and question is the actual question to which you want to get an answer to. All right. So if you look at this, so this is the actual the predict. Yeah, this is the actual predict method which you are calling. And what you're doing is, so what happens is when you get the question and the context, first you're tokenizing it. All right. So when you're tokenizing it, then which means you're breaking the sentence. So whatever context you have, you're breaking it, separating out. You're doing the input masking. You're segmenting the sentences into different, assigning them segment IDs, assigning input IDs, and all those things. Okay. And after that, you're calling the predict method here, prediction engine.predict encoded feature. All right. So whenever after you get the tokens here, so just to show you the tokenized method. Yeah, tokenized method, you're just separating out. Okay, so you're tokenizing the sentence, and then you're also giving the separation token. So you saw that ESEP token in the file, right? So that each sentence is separated out by separation token. So that is the separation token. Tokenized sentences is here. So when you're doing the tokenized sentences and tokenized subwords, right? So after tokenized sentences, you're also doing tokenized subwords. So I told you, right? Some of the words which you saw in the vocabulary were like this, right? So for example, when the word is a long word like embedding, so it will be broken up into subwords like M, and then bed, bedding, embeddings, like this. Okay, it will be broken up into subwords. All right, so this is what you are doing. You're tokenizing the sentences, and then if there are other words in the sentence which need to be tokenized into subwords, so that also you're doing. You're tokenizing into subwords. All right, and finally, this is the tokenized sentences, tokenized subwords, and after that, these are the tokens which you have. So CLS token, which is like the start of that sentence, separation token, masking token, where we are randomly masking. So the same slide which we have, CLS, masking, separation token. So all these things are also given here, which are the default tokens. Apart from the default tokens, you are tokenizing the sentences, you are tokenizing the subwords, and finally, you are giving out so when you're calling the predict method, sorry, where is it? Sorry, excuse me. Yeah, so when you're calling the predict method, this is what you're doing. So when you're calling the predict method, you're tokenizing the sentences, subwords, and then you get the you're encoding the tokens, right? And once you encode the tokens, then you're calling the predict method of the ML.NET, right? So prediction engine, you have this predict method and you're calling that, right? And when you're getting that, when you're getting the best prediction from the result. So best prediction is if you have multiple tokens, then you order them by probability. And let's say there will be some tokens which will be predicted by more than 70% probability, with more than 80% probability, which is like good enough confidence level for us to treat it as an answer, right? So in that case, we are just generally, if the confidence level is more than 70%, you are just returning the first token which is available to you. Maybe for a question, maybe because all the probabilities will add up to 1 or 100%, so then it will give you 3, 4 words with varying probabilities. But let's say if the first token which is returned back to you is more than 70% probability, we still treat it as good enough to be an answer, and that will be like the best result given to you. If there are like different tokens with very close probability in proximity to each other, so 40%, 30% and stuff like that, then you return multiple tokens. So this is what you're just giving out here, okay? And so you're giving the predicted tokens, and then you're stitching back the sentence together, right? So maybe if it is like a set of tokens, then you are just stitching it back together to make a coherent answer, all right? And you're returning that with the tokens and probability. Most of the time you will be seeing like a single sentence returned to you. Very rarely we have seen like this is we have already implemented it and it is in production stages. So very rarely we see that the stitch tokens are probably 2 or 3 sentences and with very close probability to each other, okay? So this is the high level implementation. GitHub code is under publishing, okay, because the vocab text is something which we can't really release as it is, because we have words which are very specific to our organization, specific to our domain knowledge, and kind of NDA is there in the vocab text, so we need to get permissions. But apart from that, we have also taken inspiration from one of the similar published library for Q&A BERT out there. So we've taken inspiration from that. So we will be making this publishing it on GitHub for everyone to use with some limitations on the vocab text file. Okay, so let us see this in action. All right, so I've already this is already running. Okay, now let us look at the sample paragraph which we have here. You can give any any paragraph. So the sample paragraph which I'm doing here is so this is again something which happened just recently. So my husband Amok fell down on the tennis court and had an ACL injury. So these are just $20 is the space character. Okay, so I'm just encoding the spaces as percentile 20 and then feeding it to the query string. Okay, so this is the context. Context is Amok fell down on the tennis court and had an ACL injury. Okay, he got operated on 20th of February 2021. He is now in rehab. The surgery was successful. So this is our context. So someone fell down on the tennis court, had an injury, got operated, the surgery was successful. Question, so this is the question. Why was Amok operated? All right, so let us give this entire stuff to our REST API. So this is the predict I'm calling. The context is the entire sentence, and the question I have posed is, so if you look at the question here, question token, question a query string. So question is, why was Amok operated? All right, and if you just let it run. So as I said, the tokens are returned. So tokens, why was Amok operated? Because he had an ACL injury, right? So tokens and ACL injury, probability it is 86%. So 86% confidence, it is telling me that why did Amok get operated? Because he had an ACL injury. So although you see like that from the text is not very clear. So he fell down and had an ACL injury. He got operated and the injury was successful. Sorry, the surgery was successful. So question is, why was Amok operated? So it is, trying to predict that. You can also do it on longer text here. So this is like for TSMC, and you can try out. So this is the actual, this is, one of the call report statements which we have about TSMC, the company description, the shareholding structures and stuff. And then we are asking it question. So let us do one of those things also, which is talking about TSMC. So established in 1988, TSMC is the largest independent foundry with 20% market share and blah blah blah. And our question is, what is the country of TSMC? So we are asking it about country of TSMC. All right. So we will just give the context here again and see it in action. Sorry. So Taiwan, it gives Taiwan, and the probability is like 100% probability. So you can play around, give it different paragraphs, ask ambiguous questions, ask confusing questions. Most of the time, I should say about 70 to 75% of the time, the answers returned to us in our actual business scenario are quite satisfactory. So this is something, which we are quite happy with the way it has shaped out to be. Okay. So yeah, moving on to FinBERT now. All right, so moving on to FinBERT. So a Q&A BERT was like, a scenario where we are using the squad data set, and because as I said, the text corpus which we have, the text, the documents which we have, the text content in the document is not very specific, right? So you're talking about shareholding structure and you're talking of other, routine stuff out there. So not very specialized. So you have vocabulary which is specialized, but apart from that, the text itself, you need not have any sort of specialized training to suit your business needs and stuff like that. So whatever squad data set out there, BERT-SQUQD serves our purpose. Now, when it comes to financial sentiment analysis, okay, of annual 10K reports, specifically annual 10K reports. So what is 10K reports? So it is a comprehensive report which is filed annually by public companies about their financial performance. Okay. Now, typically what happens in the 10K reports is you are glossing over the information. So no company will be very willing to publish about its bad performance or the quarters where, they plummeted badly and stuff like that. So they'll be always glossing over, and doing this analysis of 10K reports requires a lot of understanding of the hidden subtext. Okay, so you're trying to present even the most shattering information very euphemistically, very mildly or very positively, trying to be upbeat about it. So when actually we are doing this analysis of 10K reports, to understand whether the sentiment is neutral or positive or negative is a big challenge. Okay, so why we need to do this analysis is because, of course, it is a useful tool for investors to make important decisions about their investments. So let's say post-pandemic era, what could be the share prices of all the asset management houses or real estate companies or digital companies or fintechs and stuff like that. All right, so this is like about forecasting what could be the next sector which could be booming or which could be performing badly. So it is a challenging task, financial analysis, because the vocabulary, unlike what we see in your BERT Q&A, squad data set and all, it's very highly specialized. And you don't have any label data in that domain. So for squad and all, you have, or your video BERT or your image BERT, you have annotated data sets. You have ImageNet is there. You have for squad, you have Q&A. I mean, for Q&A BERT, you have squad data set. So which has like sufficient amount of annotated documents, text, and the training data itself is very huge. Okay, but for financial sentiment analysis, it requires a very specialized knowledge of that domain, right? And which for that your labeled data sets are missing. And general purpose models, so if you try your normal squad BERT or sentence BERT for word embeddings, right, if you try to use them on your financial sentiments, more often than not, you will be failing to gauge the actual sentiment. Okay, so mostly the sentiment will be positive or neutral only because of the way in which your 10K reports are worded. So let's say if you look at this sentence, shares of food delivery companies surged despite the catastrophic impact of coronavirus on global markets. So now if you were to look at this sentence, it has positive words also like surged, but you have negative connotations also which are talking of catastrophic impact of corona, right? COVID. So which means if your normal NLP models out there are supposedly analyzing this, they will be confused about whether it's talking of positive thing or it is talking of something because of the words like catastrophic which give a very negative connotation. So is it positive, negative, or is it neutral? Okay, and so it is like depends on the context in which you're looking at. So it is a positive message for food delivery companies, but it is a negative connotation for the entire global market scenario. Okay, so now this is where why it is difficult for 10K reports is because without getting confused with the rest of the sentence, we have to understand in what context the message is positive, in what context it is negative. Okay, so that's why where we have this FinBERT. So FinBERT was developed using BERT as a base. So base is BERT, and but then again as we saw in case of Q&A BERT and other BERT models, you are using the BERT base and then fine tuning it on your specific database, a data set. Okay, so it is fine tuned for financial domain. Okay, and then especially for sentiment classification. So for sentiment analysis, okay, so this is we are using BERT, you doing transfer learning, and then you are building our FinBERT, and then it is fine tuned for specifically sentiment classification, sentiment analysis. So for data sets for FinBERT are the Reuters TRC2. Okay, and this data set is public, but then you need to have some sort of licensed access for that. So financial houses, investment houses, asset management firms will be typically requesting for the licensed access. Okay, and for the sentiment analysis, we are using the financial phrase bank, so the data set from financial phrase bank. So this is how it goes. So these are the financial news which you have. Okay, so whatever coming from Bloomberg or your earning call transcripts, annual 10K reports. Okay, so here you have these NLP phase where you will have term extractions, key phrase extraction, and those things. You have semantic annotation, which is like your financial ontology. So you have defined your specific financial domain. Okay, then you have your annotated financial news. Okay, and then you are doing this sentiment analysis on that, and then trying to tell whether that particular annotated news is positive, negative, and then you have this search engine on top of that where you will feed the query to that, and you will get result whether that query you fed is positive or negative. So in our case, the sentence which we saw, that share prices of food delivery companies surged despite catastrophic impact of COVID. So then the user query, it will try to give you the positive and negative results accordingly. Okay, so for FinBERT, as I was saying, we are running short of time here. So for FinBERT, we are trying to do the exact same implementation which we did for Q&A BERT. So we will be downloading the BERT. We will be downloading the Reuters data set, and I think for the annual 10K reports, they are generic, right? I mean, they're not specific to our company or not specific to emerging markets or those things. So we can directly download those sentiment analysis with phrase bank and Reuters model, Reuters trained fine-tuned FinBERT model, and start using it, right? Problem is ONNX format right now. So we are trying to still convert it, and also we are trying to see with ML.NET whether we can directly consume the PyTorch version, okay, of FinBERT. So still working on that. That's work in progress. So right now we were just trying to see if we need some specialized vocabulary which is very specific to our markets, which are like LATAM markets, and which are TAML markets, which are emerging markets, and those things. So we were checking with our domain specialists and our linguistic specialists whether we need any specialized vocabulary or the general FinBERT will work. So they are still in process of analyzing those things. But this is what which we want to achieve. So I'll show you the demo for sentiment analysis. So this is, let's say this will be the UI, and users will be copy pasting the entire 10K reports if they want, or maybe, one particular query which they want, and try to gauge the sentiment of that. So let us, get the exact sentiment which we were talking of. So these ones, so share prices. So let us try to do this in the FinBERT, and let us see what sort of sentiment it is returning to us. All right. And it's a bit slow here, but then we can also add multiple sentences, so multiple, yeah, and then here it is positive, which is correct. So share prices of food delivery companies have surged but despite of the global markets plummeting. So the sentiment is positive, and then you can play around this, try give multiple sentences, but this is what we tend to achieve. This is the final goal we want to achieve, where we will be giving a interface, and we will be feeding, user will be feeding it either for Q&A, bot will be feeding context. So that same context, they can ask for a sentiment analysis also, they can ask for a question answer sort of scenario also. And yeah, so this is what we plan to do for 10K reports. It is very important for portfolio managers, especially in this pandemic era, to try and predict the future of certain sectors. So we deal with a lot of sectors like health, real estate, utilities, energy, and stuff like that. So in those sectors you have different companies. So you have in energy sector and all, you have companies dealing with semiconductors, ionic batteries and all. So future of those post pandemic, and are there any new clients which you are supposed to consider before before proceeding for the next quarter and stuff like that. So for all these things, sentiment analysis is really an important use case for us, and this is where FinBERT comes into picture. So sorry, this FinBERT is a work half done. This is what we are trying to achieve, the same way what we did with Q&A bot with ML.NET. But yeah, so that is about it. So that is about how we use ML.NET for performing our Q&A and FinBERT. And I'll be happy to take any questions if there are.
Awesome. Thank you, Priyanka. That was great. Let's see here. Switch back here. Yeah, thanks for that really great talk. It really is, it really shows the extensibility of ML.NET and how, even though the model wasn't trained using ML.NET, right, you still were able to take advantage of it inside of your .NET applications, and use it, right? And again, the other benefit to that, right, is this is a sort of a state-of-the-art model, and that's been tried and true across various domains. So it's really nice to see you actually using this in production. Let me switch here and take a look at some of the questions here. Well, first, let's get this one out the way here. From Andre Abrantes, are the code and slides available anywhere, GitHub, or just publicly available?
Yeah, I just told you, right, that we'll be publishing them on GitHub with some modifications to the vocabulary file, because they have some very specific data, vocabulary specific to our use case, our clients, investors, and stuff. So yeah, we'll be making them available on GitHub after some, getting some clearances.
Okay, great, perfect. Thanks for that. So look out for that, folks. You should be seeing that, soon.
Yeah, getting some great views here as well, great feedback as well on your talk. I think Anthony has a question. Luis, could you bring that up?
Yeah, absolutely. So, well, he's got several questions. So one of them is, and I think you kind of covered that, but just to make sure that folks are clear on this question here is, what is the purpose of the pound in the vocabulary? Were those tokens in your domain specific data?
So I mentioned it, right, because there will be words which will be broken down into subwords. So you have embeddings. So embeddings would be, so M, and then you're masking the first two words, EM, those are the hash, then bed, then again masking the rest of the things, and ING, those sort of. So you just imagine that when you are working in NLP domain with word to vec sort of things, then you have all these, words which you break down into their roots. So playing will be broken down into play, for example. So same way, when you have big words, so embeddings, or let's say something like, if I were to talk of financial markets, something like upsurging, all those things. So the hash is where you're breaking down the words, and then the hashes are the, what you can say, placeholders for the previous words. So embeddings will be EM, hash, then the next word will be BED, those sort of things. That is the purpose of that hashes in the vocabulary.
Great. Yeah, thank you for that. That was a really good explanation there. We have another question here from Gregor, who is actually going to be speaking later today, who really liked your talk. But their question is, you said that you were also working on another model which you wanted to get from PyTorch to Onyx. What are your challenges with that process?
Yeah, so the thing is, so FinBERT, right? This is the FinBERT which we're talking of, which we are trying to get it into ONNX. See, the challenge right now is nothing as such. The only thing is we are just waiting for our domain specialist and our linguistic specialist to give us clearance that you can directly use the phrase bank or the Reuters model directly, download it, and then convert it into ONNX and start using it. So we are just waiting for that clearance, and that's why we have not yet really implemented any POC or any such thing surrounding that. So that's the only thing. Again, I think that, I think I read somewhere, correct me, Luis, if I'm wrong, that, ML.NET also you can consume PyTorch model. Is that right? With ML.NET using some library?
Not yet. That's certainly a question Bree could answer, but in short, it's something that the team is exploring. So, but at the moment, you cannot natively do it. You have to go through Onyx, right?
Onyx.
So BERT, PyTorch to Onyx, but it's certainly something that's being looked into.
And we also requested for, the FinBERT guys itself to publish an ONNX model and give it to us. Because there are some challenges with the PyTorch to ONNX conversion as well. You see, you get a lot of errors if you try to do that. So we requested, like, how the SQUQD is available directly. Can you have also the FinBERT for us? Let's see what they reply. So we have this question on the GitHub project for that process AI. Let's see what they say.
Right. Yeah. Thanks for that. Yeah, that's a really great place. Just in general, right? GitHub, if there's questions or anything like that, that's one of the best places where you can go, because chances are, if you're asking that question or if you're requesting a feature, you may not be the only one who's thought of this or who's having an issue. So the more visibility, the more likely it is that those features or those issues will be resolved. Right.
Yeah.
So we have another question here from Antonio, and this is related to the Q&A. So you have two components when you're trying to use BERT. One is the context, and the other one is the question. So
Yes.
In relation to the context, how big is the context the users have to provide for the Q&A? And just to kind of maybe a bit of a follow-up there, right? Is it paragraphs? Is it sentences? How big is it, and what is it?
Okay, so if you look at that, right, for the demo purpose, I just use a HTTP REST function, HTTP REST call. So which means you will have a certain sort of limit on the amount of data which you're passing to the query string. But if you look at the actual code which we are using for production, I'm not sure if you are able to see my screen. Yeah. So here you have post wherein you can give the question view model itself. So there's no limitation on, the amount of data you are giving to the view model. Absolutely. So the view model, if you look at the view model itself, it will have, if you look at the view model here, it will have this question and context. So yeah, it's okay. Sentences, paragraphs, anything is okay. You can absolutely, give anything. So for our case, if you look at the paragraph which we are feeding, that is not typically more than one one or two pages of a Word doc. So should I'm not sure if you're running into tens of thousands of pages, or if you're actually feeding the entire 10K reports to the Q&A bot, how crisply it will perform or how accurately it will give you the results. But couple of pages, 5 pages, up to 5 pages is still okay and still accept.
Yeah, I think of it, I don't know if this may be a good analogy, but it's almost like watching a movie, right? Like you'll watch like a certain portion of a movie, but if somebody asks you a question when either, it hasn't gotten to a specific scene or something like that, like you can't really answer that because you don't know, right? So it's like, it's very, going back to the name itself, that's why it's called context. It's very contextual. It's like, you're asking me questions, but, it's going to be dependent on, the context of what it is, right? So a bit of a follow-up on that. So there's no limitation in terms of, sort of like what you can pass in through your requests to your endpoint, and there's no limitations that you're imposing. But does the model itself impose like a minimum or I guess maximum number of characters or tokens that you can pass into it?
Not sure. I have to check on that. Not sure. I'm not sure of that. So I'll need to take a look on that and get back to that. So
yeah, for sure. Yeah. So I know that 10Ks. So many moons ago, I was in the financial services industry myself, and I know that the complexity of 10K reports, because 10Ks, 10Ks is just like, hey, you have to report something. Text as it is, it's very unstructured, so it's very difficult to solve the text problem. And until some models like BERT came out, it was a very hard problem to solve. But also 10Ks are not standard, right? So there's that additional problem. It's like, where do you take, like, what pieces are relevant? So how are you, I guess, addressing that problem of like, so you've kind of solved part of the problem in terms of interpreting text and analyzing text, but how are you getting around the problem of sort of like, well, the reports themselves are not standards. I can't know for sure that every time in page 1, I'm going to find certain, perhaps revenue figures, or in page 2, I'm going to find this. It's really dependent on the company. How are you overcoming that challenge?
Yeah, right. So for 10K, right, the data scientists which are working on 10K reports, they are extracting only maybe the summary part, or maybe they are doing this web scraping and they are extracting only certain amount of text. So which means, for every 10K reports that are published, even that is not standardized. Like, for example, if you do web scraping using your web scraping tools like Octoparser or Selenium or whatever that is, still 10K reports will not have like page 1 could be shareholding information, page 3 could be annual performance information and stuff. So what they have done is they have identified the companies which we are dealing in. So in emerging market equities or in developing markets, and the companies which we are investing in right now. So they have collected all the 10K reports of those specific companies. They have developed a framework wherein it's very customized. So very customized, they will look for the text which we want to extract. So there are about maybe 5,000, 6,000 reports. So they have defined a framework going through segregating companies by sectors, and for those sectors, at least those 10K reports will have some standard information, standard way of presenting information. They will extract the text. There are outliers, of course. So for those outliers where the web parser throws error, then they will have to manually extract the information and feed it to our machine learning pipelines or to our data lake. Okay, but 70% of the times the framework which they have defined for extracting very specific information from those reports works for us. But yeah, there's a lot of pre-processing work involved to define those framework engine rules. So we have written an engine itself where you will have those markers for specific sectors and segregating the reports into those sectors, and then scraping them and taking out the information which we need for sentiment analysis.
Great. Yeah, no, that's really good. Thanks for that very detailed explanation there. Let's see here. Let me just check if there's any more questions in the chat.
I think we covered all the questions I see so far. But if anyone has any more, feel free to post them. Otherwise, feel free to post them in the virtual ML.net Slack community as well.
Yeah, absolutely. Yeah, and I'm going to paste here into the chat. Again, very much like the last talk, we would love to get your feedback. So if you go to that link there, aka.ms/virtualML feedback, this not only helps us, but it also helps our speakers get feedback in terms of how, what you would like to see them cover within the domain of their talks. So make sure to leave us some feedback there. All right. So with that, we'll just give it another second to see if maybe any last minute questions come in. With that, Priyanka, is there any sort of last minute questions, thoughts that you'd like to leave folks with?
No, I think, I'm looking forward to a lot of promised enhancements in ML.NET, frankly, because we try to use ML.NET a lot wherever possible. Even for AutoML, we are trying to use ML.NET in a lot of places. So yeah, I would really be interested in seeing the proposed enhancements and upcoming versions for ML.NET, especially PyTorch 2 on NX. And I mean, great job, guys. ML.NET, seriously, like if you want to do simple things, regression models and all, end users were really happy with how you can just drag and drop using the model builder, which is in preview right now. So yeah, so it's really awesome. So yeah, I wish you all the best and look forward to more features.
Thanks so much. Really appreciate you. Yeah, we really appreciate you taking the time to join us here. We know is it early or is it late for you?
It's like just about to clock 12.
Okay. All right. Gotcha. Okay. So you're almost like JK. It's pretty late for you. So we really do appreciate you coming on and spending some time with us and teaching us.
Nice. My pleasure. Thank you, guys.
Okay. Take care. We'll
see you. Yeah, take care. Be safe. Bye-bye.
Thanks. You too.
Bye-bye.
All
right. That was awesome. Well, we are 30 seconds away, I think, from the next talk here with Rafael, Luis. Are you excited about that?
Yes, sure.
And here's Rafael.
Hello everyone, and chat. Hello, guys.
How's it going, Rafael? So Rafael is going to be talking to us about back office operations and how you can enhance them with ML.NET. So with that, let me go ahead and share your screen here, and I will take us off. Take it away.
So now stage is mine, right?
Yep, it is.
All right. Hello everyone. Thanks for joining my presentation today. My name is Rafał Lewandowski, and I will talk about enhancing back-office operations with ML.NET. I would also like to thank organizers of this conference for allowing me to participate in it, and my company, mBank, as well. A little bit about me. I've been working in .NET Stack for about 4 years, mostly in writing applications in C#, Visual Basic, MS SQL, and React.js. I'm software developer at mBank, which is one of the biggest banks in Poland, for about 2 years. I work in a back office teams, as you may have seen from the title, and we basically support various business users and helps them to optimize their work. I have no machine learning background despite studies where I have learned some basics. So I may be a good example how .NET developer can use machine learning in applications. The presentation will be split into 4 parts. In the first one, I will talk why we have chosen to try on ML.NET. Then I will walk you through different use cases, and each will be ended with a demo, some facts, figures, business case, and code samples. In the end, I will try to summarize what I have presented. So why ML.NET? Well, if you're from .NET Stack, you should be familiar with APIs, with the syntax, with everything that comes from this tool. It's working from Visual Studio, which is standard for creating applications in .NET. So you should be very familiar with it already. Then again, another reason for that, is it doesn't require data science background, so we have tools such as Model Builder, where you just select a machine learning scenario, you pass the data, and the framework will figure out what model will work the best on this data. And finally, it's working on premise, so you can very easily set up a working environment on your machine. And in production, you don't have to upload the model to the cloud in order to make it work. Let's go with case number 1, which is assigning documents to a team. So we have an application here, which main purpose is indexing documents, or you can call it describing documents. An employee looks at the scan of the document, he has some form, and he can fill this form based on the data from the scan, or alternatively, he is looking at already filled form, compares it to the scan and check if it matches each other. And there are many document types processed, such as mortgage loans, account opening, account closing. There are approximately 200 of them. And most of these document types have teams dedicated to each other. And first step in this processing pipeline is to assign a document to a team. Most of the documents can be assigned automatically, because every document has some metadata called application number, which consists of prefix and some number. And this prefix tells us to which team does it belong. For example, this KGB shortcut, we didn't have the CIA one, is a shortcut from mortgage loan in Polish, so mortgage loan team is processing these documents. However, there are some special document types which cannot be assigned like this, and looking only at the prefix isn't sufficient. So you have to open the document, look at its first page, and then decide where it should be assigned. Some statistics. So as I previously mentioned, we have over 200 document types processed. Each month, there are 300,000 documents processed through this application, where 40,000 of which are these which aren't assigned automatically. This slide shows some samples. How does the document looks like? Even though, as you can see, they are from the same prefix, their layout is different, and they are processed by different teams. Another sample which I got here is a little bit more tricky, because from what you can see, the layout is quite similar. So if you only would take a quick glance, maybe you couldn't decide where to assign it. So we have performed an experiment with ML.NET framework in order to check if this process could be automated with this framework. All right, so in order to make your program work, you have to define some inputs and outputs for the model. My first approach was to use image classification task. So I have created two models. I'm putting a label here, which will be the class we will be predicting, and an image source, which will be the path for the file. And in the prediction class, we store the prediction, which will be the label that the model will produce, and also array of the scores for each class which this model is classifying. After specifying inputs and outputs, we can load the data. I'm using ML Context API to do this. First, I'm creating a collection of the samples. So for each sample, I'm putting a label for it, which will be the class, and a source to a file. Okay, so after we have the data loaded, now we can make the training happen. I have decided to use AutoML API. So this is something similar to the model builder. You just specify experiment type, which will be the multi-class classification. You put the data into it, and the framework will look through various model types and decide which model works the best on this data. After the training, you can evaluate the model. you pass the testing set, which contains the samples that the model has never seen before, and check how it performs on the new data. And finally, you can save the model. Okay, let's go to the evaluation number 1, training number 1. As you can see, this table looks quite confusing. Well, it's called confusion matrix, but I will try to explain how to read it. So on the right side, you can see the training time. Then we have a testing split. So when you are performing machine learning experiment or task, you have to split the data before, so that you are training your model, and then you're evaluating the quality of the model on the data that he has never seen before. Then we have some accuracies and log loss. So the pattern here is that if the accuracy is closer to 100% and the log loss is closer to 0, that your model is performing well. And now to the table. These values from 0 to 6 are the classes which I was predicting. You can see the labels for them in the below. I don't understand them either, so don't worry. Let's focus on the numbers. We have recall and precision factors. So for the recall, you read it from the left to the right. So for example, for class 1, we have 220 samples from class 0 predicted as class 0, 101 samples from class 0 predicted as class 1. And if you divide this number of correctly predicted samples by the total number of the samples, you get the recall. And for the precision, you can read it from the top to the bottom. So again, with the class 0, you have that 220 samples from class 0 were correctly classified. Then 19 samples from class 1 was classified as class 0, and so on. And as you can see from this very first approach which I took, by taking just 10% of the data which I had for the training, resulted that most of the classes has precision and recall over 90%. Only one class is different from them, which has below 70%. But I will try to improve that later on. So another training which I performed is that I took half of the data for the testing purposes, half for the training. One thing to note is that the training time has increased significantly, because previously it was less than an hour, now it's 1.5. But this taking more data into the training resulted in a better model. You can see that the accuracy has changed from 90% to over 95%. Log loss has dropped, and recall and precision for these classes are now closer to 90%. For some classes, even almost 100%. So this is very, very nice model we have here. And final evaluation which I took was kind of the standard way. So this most usually you take 20% of the samples which you have for the testing purposes, rest for the training. And I have performed this training and evaluation. And as you can see, we didn't improve in accuracy. So that means that maybe we are overtraining the model. So it's not having an ability to work well on the new data. And I have chosen the model after evaluation number 2 as my reference model for the next slides. This slide shows how recall was changing through the time. So the very first training where only 10% of the data went for the training, you can see for this class is performing poorly. For other classes, it's not that bad. Increasing the amount of the training data resulted in a better quality model. And after putting even more data for the training, you can see that some classes are also increasing, but some are dropping. So this means that we're overtraining. Another approach which I took was text-based approach. In order to extract the data from the images I had, I used Google's library called Tesseract. OCR is a shortcut from optical character recognition. Okay, this code is also pretty straightforward. You instantiate Tesseract engine, you pass Tesseract data directory where Tesseract files are stored, you specify language which you will be predicting, and then I have a helper method which takes an image as an input. It returns a text, and I'm sanitizing it also. I'm removing any white spaces, tabular characters, and so on, and replacing pipe character with empty word because I was using pipes as my separator later on. And as in image-based approach, you have to specify inputs and outputs. So the output for the model looks exactly the same like for an image-based approach. The input model is quite more complex. I'm loading some additional data to the model, but the most important columns are description, which contains the result of the OCR process, and the document type, which is the label that I will be predicting. Again, we have to load the data. I'm using ML Context API. I'm loading from text file, specifying path to the data, what separator I have. So this is the one which I was previously removing, and whether the data has header or not. What's different from the image-based approach, I'm also shuffling the data because I don't want to be dependent on underlying structure of the data, how it is stored. I couldn't do this for images because the data was located on some network drive and my application was crashing, so I have to move it manually. And in the end, I'm specifying the split between the training and testing set. Okay, when it comes to the actual training, in order to make your model work, it expects some numbers as an input. So if you have words and labels and so on and letters, you have to convert it to numerical values. And in order to do that, you can use featureized text transform. Then the result of this transform is concatenated into features column, which is the vector which contains all of the features you have. I have only one, but if you have more input columns, you can concatenate them here. After specifying how the data is preprocessed, I can train on it. I select the trainer. Trainer is an algorithm which will train your model. I've selected this one called SDCA because I have read from the documentation, it stated that it has good default performance. It doesn't require tuning, which you will see later on the statistics. And I have test metrics because I'm evaluating the model quality on the test data. Okay, we have evaluation number 1. As previously, I have splitted the set into testing and training set. I took 90% of the samples for the testing purposes, and the very first thing to notice here is the training time. So previously, the training took at least an hour, and now it's below 1 minute, which is very high increase. Then you have accuracies, which now are close to 99%. So even though I took only 10% for the training, 10% of the data for the training, I'm getting already very, very good results. Precision and recall factors are also close to 100%. Only class number 5, which is this one, black sheep, I called it black sheep, is performing a little bit worse. Okay, so like in previous approach, I've split the set equally. I took 50% of the samples for the training, 50% for the testing. And even though I took more samples for the training purposes, as you can see, the time is still below 1 minute for the entire process. I have increased the accuracies, the recall and precision factors for the classes. You can see that some classes already has 100%, which is very good. You can get more than that. And evaluation number 3, the standard way, I have took 20% of the samples for the testing, 80% for the training, which resulted in having a model with accuracy close to 100%, recall precision also 100%. The only class which was below 95% is this class number 3. And as previously, I'm also comparing how recall was changing through the time. So now we don't have such dramatic increase. All of the splits worked very similarly. We're beginning from the 90%, and by taking more samples into the training, we're constantly improving the model. So this model was my final model for the text classification. And this slide shows the comparison between the best image model versus the worst text model. So the best image model was the one which I took 50% of the samples for the training. The worst one is only 10% of the samples for the training. And even though this is only 10% of the samples, you can see that the text model is outperforming the image model in almost every class. So as I mentioned, the training time was smaller for the text model. So this is very important in my opinion, because when you have a model which you can train in less than a minute, you can do some experimentation, you can change the parameters, maybe the trainer, and you have the feedback almost instantly, while on the image model, you have to wait hours and hours. Also, what I have noticed is that the textual model was lighter. So in result, I've got a model which weighted about 6 megabytes, while the image model was 100. So this is also better, and it was predicting faster. Okay, so now I have 2 models. I want to use them. In order to do that, I created .NET Core Web API. In configure services method, you have to add prediction engine pools. You specify what was the input for the model, the output, and then one important parameter called model name. You will be referencing to this model name later on in the endpoint, so you have to specify it. Then a path to the file, to the model file, and Boolean watch for changes, which basically allows you to swap the model during API runtime. You don't have to turn it off. You just swap the model. It just swaps the model itself. Okay, the first endpoint which I created was an image endpoint, so the code is pretty straightforward. I'm passing an image to an endpoint, saving an image on a disk, then creating a sample for the prediction engine, making a prediction. So as I mentioned before, you have to remember this model name, passing this sample and returning the result of the prediction. Text endpoint is the same. The only difference is that you are passing textual data instead of the image. So you're creating a sample, predicting on that sample, and returning the result. Okay, let me now show you some demo which I prepared for you. Okay, in order to visualize this API, I have used Swagger. It allows you to test your endpoints and to see them in a web application. Let me start from the image classification. Let me choose the file. So these are the files which are real production files without client's data. The file name corresponds to a class which should be predicted, so you will be able to see if it matches. And seems that the model is behaving correctly. The original class or the true class was this one. We're predicting the same one with very high score. Let me pick another image. And seems like something is wrong, right? So I was showing you some statistics that the model has very high accuracy. that the precision is very high, accuracy is very high, and now it's not predicting this particular sample. Why is that? Well, explanation is quite simple. When I was training the model, I have used real production data, and now the samples which I'm showing you has been anonymized. So I have put some black boxes here where client data was. So the image model learns from the features, and now I have altered the image. The feature has changed, and the model cannot predict on these samples correctly. But we have another endpoint for the text, and I have a result of the OCR for the very same images I was showing you. And now let me quickly make a prediction on this text. And as you can see, that the class which was predicted is the correct one. So it seems like the textual model is more resistant to some changes in the data which it receives. So I can even delete maybe half of the data, make a prediction again, and still I get the very same class with high score. I can delete maybe this one, execute. Still, we're getting the same class. The score is lower, but you're getting the point, right? That even though I don't have complete data for the model, it's predicting correctly. Okay, into the presentation again. And we have case number 2, which is sensitive data detection, in that case, ID cards. Business process is quite simple. When a client of a bank has a loan, credit card, maybe any other financial commitment, and he's not fulfilling it, he's not paying. After some time, after agreement is now made with the client, this debt is sold further to the external companies. And in that process, we exchange the client's information, the documentation for the client's electronic version of it. And before the data is passed, it must be cleaned, because we cannot pass the sensitive data. The monthly scale is that approximately 100,000 pages of the documents must be looked at to find these documents. So as you can see, this is a very big number, and business user came with the solution themselves. They created a Python application to make this classification possible. But as we are .NET developers in .NET team, we have decided to give a shot for the ML.NET and try to make the same predictions within this framework. This picture shows how ID cards in Poland looks like. The left one is the older version of the ID card. The right shows the current one. As you can see, we can both have the front of the document, the back of the document, so we must be prepared for various scenarios. This one is a real production sample. So as you can see, the quality is quite different from the previous slide. It seems like this was taken from some phone, then this photo was printed, then it was scanned, so the quality is quite poor. Fortunately for us, image classification is quite resistant in that matter. I won't go you through the training or evaluating process, because it's the same like the previous example which I was showing you. I will go through the training because it was more interesting. So as previously, I have used, in the first approach, I have used 90% of the samples for the testing purposes, 50% for the testing, and 20%. And this led to a model which accuracy was close to 100%. Also, log loss was very low. Recall and precision were also very high. Okay, so when I had the model trained, I decided to compare how it will behave on the very same data which Python application was tested on. So I have a set of 19,000 images, 22 of which are ID cards. So as you can see, the ID cards are a tiny fraction of the whole set. So in order to find one ID card, you have to look at 1,000 other images. And by the comparison, it seems like ML.NET model has better precision, so it's producing less false positives. However, unfortunately for us, there was this one sample which hasn't been predicted correctly. So in this business case, what we care about the most is this recall that every sample that you have in your dataset must be classified correctly as an ID card. And I have decided to do something about this. I have decided to use a technique called image augmentation. So it's basically a set of operations you're performing on your original images, and in result you're getting new images which you can train your model on. The most simple way you can do that is to open each image in some graphical editor, alter the image, and then save it as a new one. But I have decided to use a library for that, and which I will show you soon. Going back to this slide, on the left you can see the original image. The right shows an image after augmentation is made. So in this particular sample, you can see that the image was cropped a little bit. The image was blurred. Again, another example, you can see that the image was rotated. The contrast was changed. It seems like it's a lot brighter than the original one. And another example, the left image shows the original image. On the right, you can see that the image was cropped and the perspective for the image was changed. So this sample may simulate the way you're taking the picture of a photo. And the code is also pretty straightforward. So the library which I was talking about is called ImageAug. So you have to specify an order of the operations and what operations you want to apply. So for example, here I'm flipping left and right, I'm cropping the image, flipping up and down with a certain ratio. So in that case, 20% of the images will be flipped. And after making another training on this bigger data set, I evaluated its quality. As you can see from the previous training, I increased slightly in the recall, but the difference is very minor because it's only one sample. I have performed the test on this big set which I was talking previously, and unfortunately it didn't help. The very same sample which wasn't predicted correctly before wasn't correctly predicted now. What's positive though, that before augmentation this sample got around 7% of the score, and after augmentation it was somewhere around 14%, so we have an improvement here. Okay, and in order to for this demo, I have prepared some sample application which would mimic the Python's version behavior. So application has 3 phases. First one is that you have to extract images from the PDF. So we're working on PDFs, and in order to be able to predict on them, you have to take each page from the PDF and treat it as an image. After the prediction is made, we can log the results to a file. In the phase 2, you can load this file into the spreadsheet. You can filter the results. You can order by some values and make a decision which data should be removed. And in the last phase, you're removing the sensitive data and creating new PDFs. Okay, let's go with the demo number 2. This catalog shows the sample documents which I prepared. Let me open this one maybe. As you can see, this contains some form. and then we have a scan of an ID card. Another example which I'm showing you is similar, so you have a little bit more pages, and in the end you have also an ID card. And the third one simulates the way that the production document looks alike, because it has almost 100 pages. Production documents can have 200 pages, 300 pages, or even more. So you could imagine how painful it was before any machine learning was introduced in this process. You have to scroll each page and see if there is a scan of the ID card. And in this sample, I have put them in the very end. Okay, the application is quite simple. You have one configuration file where you specify the pipeline you're working on. So we have 3 pipelines, one for the training. I won't show you it now because it takes a lot of time. Another one is classification. So for the classification, you have to specify 2 variables where your data is stored. So this is the path to the 3 documents which I have shown you, and a path to the model. So once you set up the mode, you can run the application. You can see that the folders has been created. It corresponds to the PDF it was created from. It contains images, pages from these original PDFs. And after the conversion is made, we're classifying on these images which are in these folders and making a log file which will contain the results of the prediction. Wait a little bit longer. I can see the fan of my computer, so it's working underneath. Okay, we can see that the classification has been finished. So we can open this file in some spreadsheet. I will open it in this text editor. So starting from the left, you can see the time the classification was performed on the class. This one means that it isn't an ID card. This one means that it is. You can see the score and the path for the file. So starting from the top, you may pick this one because the score isn't too high. Well, so it might contain an ID card. Let me open it really quickly. And it doesn't, so it can stay. Then you have the sample which was predicted as an ID card, so you can inspect this image as well. All right, it contains, it's true, so you can specify that this one should be removed. And going from the top to the bottom, you can see another ID card. So I won't take a look at it. I will just remove it. So once you have specified which files should be removed, you can go back to the same configuration file, switch the pipeline, and you have some more variables connected with this pipeline. So first one states if these documents are processed automatically. If they are not, you're just loading the file, and wherever you have specified the file should be removed. So this true value, they will be removed. Also, you can set it to true, and then based on some thresholds, the data will be removed automatically for you. Okay, let me run the application again. As you can see, the processed PDF catalog has been created. It contains the results of this flow. Okay, the process is finished. Let me open the original file, which contained this ID card, and then the same file, but as you can see, it doesn't contain this sensitive data. I can also put this application into automatic mode, which I was talking about. So let me set it to true. You specify which class will be removed, and minimum score to treat something as this class, which is 50%. So basically, we're taking everything. Also, the min score for no ID card, which states that every sample which is no ID card, but its score is less than 95%, will be removed. Let me run the application again. I have a prompt where I must decide whether I want to perform this automatically. I specify the yes. And as you can see, we have the same processed PDF catalog for the result. Let me open it real quickly. So the document 1 has been removed completely because the score for this second page or the first page was only 63%, which is less than 95. And the rest of the documents has removed sensitive data as well. All right, that was all. And then now let me summarize it real quickly what I have presented to you. So first thing to mention, and the most important in my opinion, that it's working right. I have shown you some real-world samples, how this ML.NET framework can be used. We are classifying images, text, ID cards, and with very good results. Another thing to mention that entry level for this framework, if you're a .NET developer, you should already be familiar with the APIs, the syntax, and you shouldn't have problem using it. And last but not least, great documentation and GitHub samples. So the solutions which I have presented to you were mostly based on the samples from the GitHub repository, which I recommend you should take a look into. All right, so that will be all. Thanks all for joining me. If you have any questions now, you can ask them, or alternatively, you can write me an email or message me on LinkedIn.
Awesome. Thanks, Rafał. That was very cool. And we have a ton of questions for you, mostly from Jose in the chat. So, Jose, I'm going to start with just top to bottom. First, what's the goal of ML Context API that you've used to load your data?
So this is the tool. ML Context API is an API which allows you. It's just a toolbox, right, for this ML.NET framework. So you can have operations of loading data there, the training, the splitting the set, various transforms on the data, and so on. So this is the toolbox which I was using.
All right.
Does it answer your question?
Jose, feel free to type in the chat if you need more context. Okay.
ML Context Auto API, as I understand, right?
For this, and this next one, can you tell us more about the method mlcontext.auto? Will it choose the best training algorithm for?
Yes. So you specify the data, you pass the data, and it's looping through various models, evaluating how does it work on these models, and returns the best one. I can go back to this slide, so maybe you will be able to see it better.
And to clarify, Rafał was using the AutoML.NET API.
Yes, so this is this API. We're creating an experiment. We're looping through various models, storing the results, and here we're selecting the best model from this experiment.
Nice. And our tooling, like Model Builder and the CLI, run on top of the AutoML.NET CLI. API. Okay. So next one. Does Tesseract recognize handwriting and printed characters, and does it need some additional configuration to do that?
Handwriting, I don't know, maybe. I was only extracting from the printed characters, and only configuration which I made was There's specifying the language you're predicting and a path to Tesseract files. So it has some files which it's using in the process of OCR.
Nice. Okay. Next question. Is the way you set up your pipeline similar to the way we could set it up with Keras?
I don't know too much about Keras, but from my experience, Keras is a little bit more complex because you have to set up architecture, the whole architecture for the model. And here I was using the pre-trained models from TensorFlow, and I've trained them on my data. So this was the transfer learning.
Right.
So the architecture was predefined. I wasn't specifying architecture.
But if there is one similarity, right, is that Keras is like this really simpler API on top of TensorFlow, right? So you don't need to get as low level. So in a similar way, the AutoML API and setting up the AutoML pipelines, it's just a higher level abstraction that sort of automates and makes it a little bit simpler to build your machine learning model. So if there's any similarities, that would be, and that's a stretch, right? But that would be one way.
Yeah, that's Keras is some kind of wrapper on top of the TensorFlow.
Yep, exactly.
Okay. And last one so far from Jose. Instead of using Python to remove the sensitive data, why not use Sharp CV?
Well, as I mentioned, the business user made this solution, so I don't know why have they chosen to create a TensorFlow model or Python model.
Gotcha. So not your decision.
No.
Gotcha. Okay, Jose, hopefully we answered all your questions. If you have any other ones, feel free to post them in the chat. Andre said, which .NET version are you using in your projects?
So in this API, I was using .NET Core 2.1, as far as I remember, and for the training as well.
Gotcha. Okay, I think we've covered all the questions in the chat. If anybody else has anything, feel free to post it in the chat. And Louise, you want to get that feedback button or feedback link in there?
Yeah, absolutely. Let me paste the feedback link. We can have just find that because I had something else that I was looking for. But as I'm looking for that, there's one thing that I really caught my attention in your presentation.
Okay.
And that is sort of the last scenario, right, of removing. Okay, there we go. Paste it in the chat. So please make sure to go to that link and give feedback. Again, this helps us as well as our speakers sort of gauge how well they're doing and how they can improve. So with that, so sensitive data detection and removing or sort of blocking out sensitive data, and this particularly caught my attention because whenever you're doing machine learning, there's always the question of ethics and being responsible with machine learning, right? And specifically for these image classification type scenarios, or just in general, because these machine learning models, they have these, they're sort of black boxes to a certain extent, right? There's very little visibility into how they're built or how they're being used. There's always that question of like, hey, as we're implementing these things, there's concerns that it may violate privacy. There are concerns that it may be unfair, right? But in this case, you've actually just taken machine learning, and instead of applying it to one of those scenarios that may be a cause for concern, you're sort of flipping that, and you're actually using it to protect people's privacy. You're using it to sort of make them, sort of help them preserve or helping, using machine learning to be responsible in your day-to-day practices. So I was really interested in that use case and how you went ahead and did this. See, we have our next speaker who's actually coming on saying that those are great use cases.
Thanks.
In terms of the data, how large, and maybe I missed it, how large are your data sets that you're working with?
For this, for ID cards detection, I had somewhere around 1,000 samples of ID cards and 8,000 of things that are not ID cards. So the set was quite unbalanced. And for the previous assigning documents to a team task, the test set was that almost every class had 1,000 samples, and the two classes had 400 samples.
Okay, so it does sound like your samples
They aren't very, very big, so of course maybe I should have gone with bigger ones, but I hadn't them. I need to ask business users to provide such samples, right?
Yeah, but it does
But
like,
even if they weren't that big, you have seen that the statistics for them were quite nice.
yeah, absolutely. That's kind of what I was going to mention. That it does sound like even though you don't have a lot, at least it seems like there's variety and variance within your data set, or at least enough that you're not going to say over predict for certain classes or categories versus others.
Yes, especially in this case with text classification, where I had 10% of the samples for the training, which is around 100 per each class, and still we're getting very good results of recall accuracy close to 100%.
Yeah, so you mentioned actually a few times, you sort of alluded to that, there's sort of this relationship between the business and sort of yourself. How do you manage that relationship, and how does the business impact how you fine tune and how you tailor your models?
Well, those models and examples which I was showing you was mostly experimental, so we're not having a flow between the business and the developers. We're not using machine learning extensively. It's just a starting point for us in order to check if it's even possible, right? So now I have some results. I can prove that it's working. So maybe next step is to, I don't know, maybe take some bigger data set, check how it performs on production, what's the performance of the model, and so on.
Gotcha. Yeah, no, that makes a ton of sense. Let's see here. Let me just check if there's any other questions. I don't see any at the moment. With that being said, Rafael, you want to leave us with any sort of parting thoughts? The ways people can find you, interact with you.
So yes, so again, thanks everyone who joined this presentation to listen to it. Well, if you want to reach me, I can show you the very last slide, which I have here. So you can either email me or write me into LinkedIn. Okay. And that will be all.
Great. Well,
for you.
Thanks a lot. We really do appreciate you coming on and just doing this talk, because it's it really shows the diversity of use cases that you can sort of implement with ML.NET. And yeah, again, folks, make sure to reach out to Rafael if you have any additional questions.
Yes, I will be on Slack either.
Okay, yep. Make sure to join the Slack if you have questions on there as well. And in the meantime, let's see, we have a few minutes before we go on. So we're going to take a little bit of a break. So if you've tuned in since the beginning of this, which is now almost 3 hours ago that we started, feel free to give yourself a break, maybe grab a snack, and get ready for sort of the second half of this conference. Again, thanks, Rafael, for joining us.
Thank you too.
Yeah, appreciate it. We'll see you later.
See you next year, maybe.
Hopefully. Yep. All right. Take care. Bye-bye. All right. Let's remove ourselves and just start soon, I guess. And of course, it had to happen again.
Hello.
Hey, so we have two wonderful guests here. We have Gregor joining us, who's going to be speaking, and John joining us as well. He was unfortunately not with us this morning, but he's finally able to join us here. Yeah. So have you? I think I saw you in the chat, John. So I know that you were around, but
yeah, I listened in most of it, and man, it's really good stuff so far.
Yeah. Awesome.
Totally. There's again, kind of Alexander mentioned this in the beginning, but there's tons of use cases and sort of case studies, that is, folks using ML.NET in various scenarios.
Yeah, I'm super excited. And if anyone has seen Gregor's hackathon presentation from last year, you'll probably have very high expectations for his talk today. No pressure, but
oh no pressure at all. Good that you told everyone about it.
We'll have to find the link to that, because that was one of the best videos I've ever seen.
If we would have had a category for video production, that would have been it.
Yeah, that was like my girlfriend. Like, she spent so many hours like cutting on her Mac to make it perfect. So like that's like that directly goes to her.
Nice. Let me before we get started here, let me pull up the schedule real quick just to remind folks kind of where we've been and kind of see where we're going. So let me share my screen here. Okay. So we started off this morning with JK's Machine Learning Simplified for Developers with ML.NET, and this kind of gave you an introduction of how to get started with ML.NET, specifically with Model Builder, which is a UI in Visual Studio that allows you to basically, create machine learning models without really having too much machine learning knowledge at first. And of course, if you're a more seasoned practitioner, there are some advanced options that you can fine tune. So later on after the conference, you can go check that out. Then we have Priyanka talk to us about ML.NET and BERT and how she's using it and her company's using it for financial sentiment analysis and Q&A bots, or question answering bots. Right. We just heard from Rafael, where he talked to us about enhancing back office operations with ML.NET, and there were two really interesting scenarios there. Coming up next, we're actually going to have Gregor talking to us about two of my favorite topics. I'm a bit biased, but I really like F#, so I'm very interested in this. And of course, interactive notebooks, or .NET Interactive, which is, if folks may not be familiar with it, well, Gregor's going to be talking to you about it, but the gist of it is using .NET in Jupyter-like notebooks, right? After that, we're going to see how you can unlock Xbox achievements using .NET and ML.NET. Object detection, right, which is a recent addition to Model Builder, where you're able to train custom object detection models with ML.NET. Arafat is going to be talking to us a little bit about that. And then last but not least, Bruno will be showing us some cool demos with drones and IoT and performing anomaly detection with ML.NET. So, we still have a lot to go, and I'm super excited to hear what the rest of our speakers have in store.
And then we have a whole other day tomorrow. It's going to be great.
But wait, there's more.
And we can go over the schedule later. We can send people the link. We want to make sure, Gregor has all the time to present.
Of course. Yeah, absolutely. So with that, it looks like we're getting close to the time. Actually, we are at time to start. So with that, we're going to get off here and let you do your thing.
Cool. Then thank you a lot. So I hope everyone sees my screen okay. And I just start with the presentation. So this talk, like we just had a schedule, will be about ML systems and vertical slices. And I will be using F# and .NET Interactive to create basically the pitch for a system. First of all, thanks to Excella sponsoring the event. If you've ever did any event in your life, you know how taxing it is on your personal resources and monetary resources. So if you have a company who is nice enough to sponsor you, that's a big thing. So thanks, Excella. So hi again. I'm Gregor. That's me. And I'm a software engineer who turned data scientist. So I'm still in the process of becoming a data scientist. I'm also a functional programming enthusiast, mostly coding in F#. And I am currently employed for like Harcom Time Series GmbH, which is an Austrian company. And we do a lot of time series management and time series processing. So this talk will also be a little bit time series oriented today. One of the big inspirations for this talk was actually this tweet from Greg Holt. He was talking about DeliverCon 2021. And I especially liked the infographic you have here, where you have the non-MVP, like the classical waterfall approach, and the MVP approach to product development. And I have seen this a lot. It's not always called MVP. It has a lot of different names, and you see it in a lot of different branches. Like I personally work in research and development right now. And whatever you do, it's basically a game of pitches. You try to sell an idea to get your project into a pipeline. Of course, you're always working for customers who have wishes, but a lot of the times they don't really know what they want. And you have some inkling that maybe you know what they want, and you have to sell this idea somehow, like to get feedback and to get funding. The same problem you'll see in startups, like basically any startups, and also in game development. I used to work for a startup which did VR development, not exactly game development, but you very often have these use cases where you want to have a mechanic and you won't build the whole product. You will build some vertical slice, some MVP to get the idea out and to get feedback from like your clients and your customers. So this is something you often see, especially because launching a perfect system doesn't happen. Like you see the non-MVP Mona Lisa approach. How often do you really see, yeah, I'm working on a perfect base part and I'm putting a little bit on this part. The thing is still not finished, but everything is perfect. And then the end is also perfect and people will love it. I haven't seen that like ever. So maybe you have. You are a very lucky person. But I usually see more success with an MVP-based approach. Yeah. So go ahead. Like that's just general MVPs. How can we use this sort of MVP and systems thinking when working with ML applications, ML MVPs, and finally ML systems? So on the left-hand side, we see a funny comic, XKCD, describing an ML system. What is it? Basically, a bunch of linear algebra, and you just push something into the bunch of linear algebra, you shovel it a little bit, and in the end, something will come out and it will be okay or not. And it's, as you can see, a big mess. And we do not want to have this. Like, we want to have a more structured approach. And a more structured approach usually starts with a real problem. Like, we never set out, like, we should never set out without having a problem we want to solve. Very often we see a shiny toy and we just want to play with it. But in the best cases, we want to have a real problem to solve. If we see the problem, we usually go to through this semi-scientific workflow. Like we develop an hypothesis, how to solve it. We collect enough data for a prototype. Like we will never collect all the data we need, but enough is usually something we want to start with. We sample it, transform it, look at it, try to get a good understanding of the data we have, build and evaluate models, and then deploy this model to have something you can carry to your customers and say, hey, that's what I have. What do you think of it? Is this something you could work with? Is this something that resolves your problem? And afterwards, you can just do the same thing again, like iterate on it until you have this, it's never perfect, but perfect-ish thing that you have as like maybe the next big thing in your company. Good. So already like teased it, we start with a problem. And for this use case I want to present you today, we do energy load forecasting. So you have an energy grid in your company, not in your company, but in country. And as an energy provider, just assume you're working for an energy provider, you want to forecast the load, maybe a day ahead at an hourly rate. So you know how much energy you have to produce, and if you cannot produce it, how much energy you have to buy to supply like your customers, your clients. This is something like, at least in Europe, the energy markets are liberated, so you can choose whoever provider you want, and they will supply you with energy. This is transparent for you. Like, you just pay those people, and they do all the trading and producing. You'll never get bothered with that. But that also means there is pricing competition, which has to be resolved by the producer. Like, you want to have the best information to get the best prices. So what tools are we going to use? We don't write everything ourselves. That would be inefficient. As usual, we are standing on the shoulders of giants, and those giants, in this case, are all .NET based. So you see a bunch of logos in this logo cloud. One of them is Jupyter. We are using Jupyter notebooks, which are driven by .NET Interactive, because interactive programming, when you can think with your fingers, is pretty efficient when you're banging out a prototype. Like, if you want to pitch something, you have to think fast, basically. Thinking fast means that you also need some concise way and expressive way to give your fingers a little bit work to do, so you can express an idea. F# is a very good language for that. I know functional programming sounds a little bit scary because it has this mathy touch, like only very smart people can use functional programming. This is not actually true. One of the points I can prove this with you, is me writing F#. I am not a genius. I am just a simple man. So F# is a good language for me because it helps me a lot. You will see later on how it does that, but it's a good choice if you want to get a little bit speed into your project. Then we'll also use visualization. Plotly.net is a very nice project. If you've ever used Plotly, maybe in JavaScript or Python or R, you will find this be very similar from the API and what it does, because it's Plotly. Then to wrangle data and to work with data, we'll use DataFrame Deedle, which is a very nice F# library. Then, of course, we'll use ML.NET. It's ML.NET conference, so it would be weird to use anything else. And then we built everything on .NET Core. I will be using .NET Core 5, .NET 5, it's called nowadays, which is rock solid, performs very well, and it's enterprise ready. What do I mean with enterprise ready? It means that I can interface with boring. This sounds weird, but if you think about big companies, like energy producers are very big companies, very old companies, they have a lot of boring technology, because boring technology makes money appear. It's already there. It's not super funky. It works, which isn't super special. You won't get articles published on boring stuff, but boring stuff works well. And a lot of fancy technology is bad at interfacing with boring. .NET, also very fancy, but it has a very long history, which makes it easy to interface with boring stuff. So, good choice for your next ML project when you're working with well-established companies. So, the next part, we have to set out getting data. There is no modeling, no data science without data. Where do we get data? Where could we get data if we are not directly working for a customer who wants to give us data, because we don't have a product which warrants the effort of giving you data? So first we have to pitch. So we need an open data source. And there is a lot of open data out there. You maybe don't know all the sources. A lot of them I have here are Europe-centric and Austria-centric. Kaggle is the one everyone knows, because on Kaggle there are data sets. But you might not know how much data is actually available for you. If you are in Europe, there is a big chance that you're missing out on a lot of very interesting data, because it's not generally publicized that there is the official portal for European data, and that there are a lot of national open data organizations which supply you with pretty rich, sometimes very dirty, but pretty rich data. In the Northern Americas, you also, Canada and the US, you have good data platforms usually. They are not always well kept, but like in general, they're not that bad. Like data.gov is one of the points you can start out, and maybe your local municipalities, your towns, your cities, they might also be working on supplying you with rich real-time data even. So maybe go there. And all of those data sets are usually a little bit more interesting for your use case than benchmark data sets. Like everyone loves benchmark data sets because they're well studied. Like if you go to the ImageNet data set, yeah, it's a good data set. But you won't really find something new and different you can pitch on them because everyone works with them. And they might be a little bit too general for your specific use case. And if it's too general, there has almost always someone been already there doing the stuff you are doing, but with more time at its hands. So yeah. Yeah. So now we could get our data, and that's exactly what we're going to do because it's demo time. Good. So I directly jumped into .NET Interactive. .NET Interactive is wonderful. Louis already told us about it being the .NET version of Jupyter Notebooks, or rather, Jupyter Notebooks is the interface, and .NET Interactive is the kernel, which runs everything. And with everything, I mean a couple of very interesting functionalities we'll see in a bit. Like one of the things we can do in an interactive notebook, first of all, we're mixing prose, like markdown cells, with code cells, which is really cool. Then we are not only limited to what we can write, because I told you we want to stand on the shoulders of giants, and we can't do this if we have to write everything ourselves. We can also reference NuGet packages, like from every NuGet source you can imagine, you can reference a NuGet package. And there is even more, you can extend whatever you have in your .NET Interactive kernel. There is an extension mechanism, and like the .NET Interactive team is working on a set of extensions, the .NET Interactive Extension Lab, which showcases a couple of those extensions, what you can do. Like this code is open source and out there, and it does a lot of great stuff. I will get a data set from Open Power Systems data. That's basically e-governance portal where like energy producers have to be accountable for, or like regulators have to be accountable for what happens in the energy network. And there they will post data. Most countries do this, at least 32-ish European countries do this. Not all of them super regularly. Austria, like the country I live in, is one of the countries which tries to be compliant. One of the cool things, like interfacing with boring, I told you before that. .NET, this also means F#, can do like basically all the things you would expect from a general programming environment. You have your HTTP clients. .NET Interactive is new and fancy, but it does all the things you would expect of any .NET program. So now you can just download a resource and save it to your local file system. You're working relatively to the notebook location in this case, and I'm currently saving a data file, like which I already prepared because the demo gods usually hate me. So we are seeing this data file already exists because I tried this before and forgot to delete it. But nevertheless, it's already here. So we can connect it. And connecting to it means that this is, I downloaded a SQLite database, which contains a lot of data. And the cool thing is .NET Interactive was, in this case, with the extension lab, extended to know about SQLite. So now we can just query SQLite. And I feared that this would happen because the SQLite extension is unfortunately a little bit unstable, which leads it to sometimes die. But that's not a problem because I will try to restart it because this usually works. If it does not work, I will skip this part because I anticipated this part might need to be skipped.
While that's loading,
We'll see it in a
is it
bit.
possible to zoom in just a little bit in Visual Studio?
Yes, of course.
Thank you.
So my laptop is unfortunately a little bit struggling, but we should have it in a second. Good. Yeah. In any case, like this would showcase how we would be using SQLite. So I decided to do a live demo, so it's my fault. But this is not important. Yeah, that's the fun thing about showing experimental tech. Your environment breaks, but it's good. That's how we make progress. So I will try it one time, and if it does not work afterwards, I will just leave it with that. Good. I will. Okay, I will leave it like that. What I would have shown you would be just querying SQLite using SQL queries in this editor, showing that it is also able to use all the SQLite features you would expect, like stored procedures, limits, queries, all that nice stuff. And now the whole thing is dead. Well, let's see if the next notebook wants to work, because if it doesn't, it will be a very pitiful talk. But it wants to. Wonderful. Good. So just a little bit of input I wanted to give before all of this happened. Next to SQLite, we can just work with .NET. And .NET means we can also use just whatever database data access library we want to use. The simplest one is ado.net, where we can just pull out the data we are interested in, which I would be doing here. These are like this little data set has around 50K data points, which is like not that much, but okay for hourly data for a couple of years. What I would then be doing would be loading everything into a DDL data frame and performing a couple of data cleaning operations. Like you can do this at home. The source code will be shared afterwards. And it's not too too difficult what we're doing here. Just looking at how much would it be, looking for gaps, looking at very basic statistics, and looking at how much data is missing, which would be just a couple of data points because of daylight saving time, which is something you very often encounter in time series data sets. We would clean all of this, do a little bit of forward imputation, and then save this as CSV for further processing afterwards. Like in the exploratory data analysis, a point which you should always be doing, like having a graph of your data, feeling your data. And interactive notebooks are very good at helping you exploring your data, because you can iteratively just look at it and change the way you look at it. In this way, I'm looking at it as a table, which is nice because I see a couple of values. and I have a feeling that they are like in an ordered manner, like time series are usually ordered on a time scale, but I can't really tell how this looks. So I can use visualizations directly in .NET Interactive. In this case, I am using plot, and it works wonderful. This always works. I knew the SQLite stuff doesn't always work, but Plotly always works. And here you see your data. And if you're working in energy, you already seeing a couple of things you would expect. Like here you're seeing the seasonalities. This is a year, this is a year, this is a year. This year is a little bit dirty. And here we get 2020 and we don't talk about 2020. We can also do resampling. Like if I think, okay, this is hourly data. Do I see different patterns if I resample the data? Like make it daily and just take the median of the day. And you see it's the same pattern. It's more distinct because you don't have the big bodies of your yearly values. You just have like a more condensed version of what you had before. And then you can look at maybe just a year. So you have your January going up, like in Austria, it's usually pretty cold around this time and this time. Oh no, this time. Why wasn't it cold that year? Oh. Yeah, and then you have less energy usage, especially before you get in the height of summer. And you have more energy usage. So this is a pattern you would expect. And then, because in energy data, you have seasonality. You also know that you have a weekly seasonality. You're just looking at 4 different weeks, and you can see, yeah, there is the working week, there is the weekend. Weekend, always lower energy. Working week, weekend, working week, weekend. So you have the possibility, you could also say, I want to have an additional week just to make sure that it's not a fluke. Yeah. And this here, what I'm doing here right now, is one of the things which makes interactive programming like pretty powerful. You can just put the outputs, look at it, analysis, and just run it again, run it again, run it again, changing just a little bit to get a better understanding of what you have in front of you. Good. Back to the presentation. Just a little bit of time. So we are speaking about data loading, and a little bit of wrangling, which unfortunately didn't work out as well. But we still have the data. We looked a little bit of the data. We can go on. And the next point would be modeling. Like we want to at least set a baseline of what we can do with modeling, in our case, forecasting. And one of the first things you usually do when you model something is a linear model, like linear regression per se, like as an example. And they usually offer a pretty good baseline. And even if this baseline is not good, it's at least a baseline. So if it's a terrible model, you know that you can evolve on a terrible model. And if it's a pretty good model, you already know that advancing could be a little bit more difficult because you're already like, there's such a high point. And you, in any case, you know where you are, which is pretty important. For systematically stable time series, like energy, which is something you have your fixed seasonalities, humans are always changing stuff, but we are pretty predictable in what we're doing. Like we work during the week and we do not usually work during the weekends. And if it gets cold, we use heating. And if it gets very hot, we use aircon, which is something we tend to do always. There are cases where our behavior is severely disrupted, like in times of crisis. I think we maybe have a couple of examples for that one. But even then, our like certain things stay pretty stable. And we will do exactly that with the next notebook, like modeling with ML.NET. That's why we're here. So in this case, we'll also use Plotly to have a little bit of visualization, deal to load data, and wrangle it still a little bit. And then we're using ML.NET and especially the MKL components package. Why are we using that? ML.NET has a couple of very interesting algorithms and trainers, which are already pretty well tuned at working with a lot of data and being very efficient. Like the linear regression model, I might be mistaken, but the one which is in the base package is the stochastic gradient descent model, which is like its own thing. It can work with a lot of data, and I think it even allows online training. This would be a little bit like, that's not the base model I would be going for. I would be going for like a very basic linear regression, which is in the MKL components package. It's called the OLS, like ordinary least squares model. Good. This is still loading, most likely because my laptop is a little bit overly taxed, but we can. Okay, good. When this loads, everything gets, yeah, and it's loaded. So first of all, we load our data. We always at least look at the first couple of rows just to see if anything very unusual happens. Like you have a big field of not available values, or something is negative where it shouldn't be negative, or so out of order. Even if you saved a data set, it could be that you did something wrong or your tag just blew up, and you don't want to work with something which is already set out to fail. So yeah. And then we can do a very interesting thing with linear models. Linear models have great opportunity for feature engineering. And in like all the things I spoke of before, like all the seasonalities we see, all the predictable behavior we see in this sort of time series, they can be feature engineered. And so even with a very, very, very simple model in ML.NET, we can do a lot of things. I'll show you in a bit. Like, what will we look at? First of all, we get like linear regression as a supervised learning task. So we need our targets. So we just shift the values we have a little bit to get maybe like the value of the next hour. Then we encode the day of the week because of this weekly seasonality. Like, is it a Monday? Is it Tuesday? This has big impact. The same for the month. And then we can sprinkle in a little bit of domain knowledge. Like in energy trading, there are two words which are very often used, peak and off-peak. Like, I imagine for the trading folks, this is known news, but this usually refers to the time between 8 o'clock in the morning and 8 o'clock in the evening, where you have your peak time, like people using energy. And off-peak, it's usually cheaper. So there's more to that, but this is like the basic gist. And then with our data frame library, we can just add all the columns and separate them. Like I just separate the years, like everything before 2019 is our training set, and everything after that is our test or evaluation set in this case. Have a quick glimpse at the data that comes out. And we see this is what we would assume. We have the current value and the target, which is the value of the next hour. We have the day of the week. We have the month, everything here. In the beginning is in January, which makes sense. And then we have like our off-peak and peak hours. That's good. But last data points are all just important for us to know where we would evaluate. Like from this point, we evaluate. And then we do a little bit of mapping. Like we usually do a lot of mapping in .NET. One of the reasons the auto mapper like a NuGet package is that well known and often downloaded is that we want to like have some separation between the types we work in one domain and then the types we work in another domain. And we do this here as well. Like we load all out of the DDL frame and then something we can map it to our .NET, like ML.NET types we use for the modeling. In this case, like this type here would be a record, like in C#9. You've already seen the records. Like this has been a thing in F# from the beginning. So if you want to use records even in older .NET versions, you can do if you use F#. And here you see a little bit how we would define this type. It's basically just all the features we want to use, or in this case also the value, and a couple of annotations to tell the runtime, like you can create this record and mutate stuff if you need to, but only at the runtime level. Every other case of records in F#, you speak of immutable data types, like a string. You never muted a string. You recreate a string. And at this place, we are already creating more pipelines. In this case, we have 2 pipelines, a processing pipeline where we just do one-hot encoding on our nominal values, like the day of the week, the month of the year, and peak of peak. And then we concatenate everything we want to use in a feature vector. Here we just tell the OLS trainer that we want to have the statistics of the linear regression. And here we build our trainer, which is just this ordinary squares. Here we train everything. So we create a data view for the training set, data view for the evaluation set. Then we have the transform data. We transform the data and make predictions and get a little bit of evaluation results because we tell it that we want to. What we see here is an R² of roughly 59%, which is not great, but for a very easy model, it's not bad. Like this is the point we want to start out with. And then we can look at the prediction where we look at the actual values in blue and the predicted values in orange. And even with this very, like, you have no additional information other than the date and your target, which you trained. And this is what you get. Like that, I don't know if you find it impressive. I personally think that's cool. Like you see so much of this variance is explained only by this very limited information you give it. And you can even, like, if talking about like just get rid of this feature, you can interactively also look at how your model behaves if you get rid of features. Here you see like the peak off-peak behavior, like this very easily attainable domain knowledge. That was actually a big part of your model. And then you can go and hit back just to make sure. Okay. So you have your model back. Then you can also look a little bit at statistics. We will jump over this right now and look a little bit at use Plotly for some other very like cautionary glances at the data. Here you see the actual values over the predictions in a scatter plot. Usually in regression problems, you want to be on that line. And you want to, at the very least, be not too far away from that line. And then you do not want to be like, not like, you want to have those, this line partition your residuals in like similarly. Like this is not good, but at least it is systematically bad, which is also something you can root for in your very basic models. Like if the badness is systematic, it's not as bad as randomness. Randomness is like complete randomness would be you're completely off your path. And then you can save the model because we want to use it a little bit later. And I'm already a little bit late. So I'll try to keep into time. So now we still have nothing to pitch. All those workbooks, like all those notebooks, are very fine for you, and if you're talking to other analysts, but like your customers still can't use it. So it does not really exist. So if you fit a model and nobody calls it, does it really exist? Like this is very zen, but it's also a real problem because yeah, you did the work, it's there, nobody's using it, so it could also not exist. Like there is no difference basically. And here comes the good thing about being a .NET developer. We are not known for data science and machine learning. Like that's not like we get known for it now. And in Azure, there is a lot of wonderful machine learning capabilities, and it has been for a long time. But generally, if you think about .NET, you think about services and applications. And that's good for us in this case, because that's what we need. Like an analysis, there are so many analyses nobody has ever seen. So they're basically not there. And with .NET and Emma.NET, we can make them appear in the big world and get them into production more stable than many other people can, which is good for us. So let's do exactly that. And I already have prepared this, and this time it's quicker. So you might know that in the F# world, we usually do things a little bit differently. Like ASP.NET is great, but ASP.NET is also very object-oriented, and that's not so great for functional programmers who usually don't do object orientation that much. Like we can, and sometimes it's the best thing we can do because it makes sense. But we usually tend to not want to do this all the time. That's why very good people created Giraffe. Giraffe, maybe you have heard of it once or twice, seen it on Twitter, and seen it in some benchmarks where it does do really well. It is ASP.NET Core middleware, which allows you to use it more efficiently from the F# side. And all of this, like those 111 lines of code with a little bit of filler and like formatting, this is a complete ASP.NET Core application, which is cool because it's not the most minimal form of ASP.NET Core application. It already has an error handler. It has configuration, which allows you to do like the usual stuff, like your HTTP, HTTPS redirect. You have your cores. You have a couple of things configured if you're in development or in production, everything set up from the template. And then adding MLNet is just the same as you would do in all the C# examples. In this case, you have your configure services. You say you want to add a prediction engine pool. You say, I want my forecast input, my forecast result. And then you say, yeah, where does my model live? And here's one thing I really love, especially when I work with interactive notebooks and like add a lot of different places at the same time. You do not have to tell it the place on your hard disk. You can also tell it, I have a web server which hosts everything for me. And please take this model there, and maybe every minute, take a look if it's changed. And if it's changed, use the new thing, which is great, especially if you're iterating really, really fast. The whole functionality of creating inputs is not that interesting, but it's also not really that much. You basically say, hey, I get a request. Based on this request, I create predictions, and then I return those predictions. And if we want to look at that, we can. So because I don't have a web server or anything special, I just use the things that .NET Core give me. In this case, nifty little tool called .NET Serve. Does exactly what it's told. Like you can imagine, it's a .NET process that serves stuff over HTTP. And I run the process, and I can use another notebook to showcase how to use this model. I can, of course, also use Insomnia to do the same thing. But in Insomnia, I basically just see a bunch of data points. And as I said before, just seeing a bunch of data points is not super interesting. Like there are people who just look at data points and know exactly what the data looks like. Those are the people you want to work with. They're usually not data scientists or ML specialists. They are the people with the Excel sheets. The people who maybe sitting in the trading rooms, the people who know the data very well because they are the people responsible for producing the data. And those people, like they overflow with knowledge. And they will, that's the reason why you want to be quick producing results for those people. Because those people will tell you when those results are wrong. That's the most important thing. Yeah, what I'm doing here is just testing if the service is up. Also very cool of .NET Interactive. There are lots of formats like baked into the thing. This one is for HTTP response. So you wouldn't even have to just look at everything, like the notebook does it for you. Very, very useful if you're testing endpoints. And here you're just using plain old HTTP client to talk with your forecasting service. And then you are looking at your forecast results. And we're still looking at the linear model. And the linear model, like it basically isn't doing super great, but you see those patterns which are close to the actual data, which is for a basic model, good, like not bad at all. Talking about fast iterations, this one has to be fast. The forecast we have is okay, but it's not great. Like in general, all forecasts are wrong, but some are useful. Some are more useful than others. And currently we are not like close to the mark where we want to get. Like in the industry, you basically have to stay at 4% of the actual value in your forecast, like over time. We're not there. Like the industry pros with very, very, very like sophisticated models and a lot of data, they are like at the 1% mark, maybe below that, even though like, I think that was 5 years ago. So we won't get to this mark in this talk, but it's possible. One of the problems we have with our model right now is that we are giving only point estimates. So this is the value, and we're not telling our users more than that, which is bad because we're not factoring in uncertainty. And ML.NET offers more advanced forecasting models, which give us this information about uncertainty. And for a univariate time series, like we only have a value and look at this one value, we can use singular spectrum analysis. And we are doing that. And we are doing it quickly. So what we're doing here is basically the same as in this notebook. We are loading data, we're loading a couple of dependencies, and we're transforming the data. Like we're not doing a lot with the data, we're just splitting it and then building a new model. The very cool thing about singular spectrum analysis is that you don't have to do a lot of things. It already does a lot of things for you. Like you're not specifying, I have this inherent knowledge about the seasonality, I have this knowledge about the patterns in the data. You just give it a couple of hyperparameters and it will find it out for itself. Like it doesn't need our input, basically, only in tuning the hyperparameters. Types are pretty basic, look basically the same, only for the result type, which has a lower bound and an upper bound, which is interesting for us because it models this this uncertainty. While this is calculating, and this could, like it usually takes about 20 seconds with this data set. Depending on how you tune it, it can take a while, but that's okay because, yeah, like ML models take a little while, which is what you would expect. You give it basically your output column in your result type. You give it the value it has to look at, and then you give it the train size, like how much data should it take to train, and then a series length, which it will look at, and it will slide through the series with a window of a certain length. In my case, I specified a series length of 2 months and a window size of 1 month because that works pretty well for this data type. Then you can give it a horizon, like basically this is the amount of data points it will predict if you don't give it another like forecast, if you don't give it another value, and then you can tell it about the confidence level you're looking at. In my case, I just wanted to specify a confidence level of 90%, which is okay. Like usually go for 95, but in this case, I thought 90% would be okay as well because visualization looks a little bit nicer. Good. I will not wait for this because I already built and prepared the model, so we can look at how a customer would consume the model. In Insomnia, this would be basically one result type having a couple of arrays with the length of the horizon. And you can see this is the forecast, which we got before as well, and the lower bound and the upper bound. So, and if you want to consume it, we can call it just like Insomnia, just like we did it before, but in the interactive notebook. As usual, we load our data. Then we create a new HTTP client just for the little sanity check, especially in long-running analyses. Like in this case, all our code runs usually pretty fast if you're not working on like a little laptop. But there are analysis steps which take a long time. Like we heard it in the last talk. Just computer vision on a lot of data can take an hour more. So you really don't want to work from a failed state when you're doing this sort of work. And yeah, the forecast works just as expected. It's just an HTTP call. And what I wanted to get at is looking at the uncertainty. Here again, it's really nice having visualization right baked into the pipeline because you can visualize this uncertainty right now. The training data ended in 2018. This is somewhere in the March 2019. So the forecast horizon is actually pretty long. And what you want to see in forecasts is very high uncertainty if you're moving too far away from known points, which gives us additional information. We now know that we have to update our models regularly or give our customers an opportunity to do exactly that if they have new data. So this should already have run. Yeah, it took a little bit longer than it should. And we see, in contrast to that, if we're very close at our actual data points, our uncertainty isn't that big. Like there is still a lot of uncertainty here because it's forecasting and you cannot know the future. If I would know the future and I had a way to predict it, I would be rich. So would every other ML engineer and data scientist. What I also wanted to look at was here, this one. Like I told you, you want to be at this line. You want to be a little bit like you will be a little bit dispersed, but generally the direction is good. That's what you want. That's a better model. This visualization was just here to tell you that in this horizon, the model behaves better. And you can tell this because you can visualize it. Good. Where do we go from here? The possible next steps would be implementing experiment tracking with MLOps.NET, perhaps, because you see us having 2 experiments and 2 models. There will be more models. There will be a lot more models and a lot more experience. And maybe you want to have some way to do this in a ordered fashion, especially if you want to deploy all of this. There are never just 2 models. There are tens, dozens, whatever models. Then we want to get more domain knowledge. You saw what a feature which is commonly known to domain experts did for the very easy linear model. If you can get more domain knowledge, you get more like get better outcomes. So yeah, ML algorithms are very important. Domain knowledge is always more important. Then we can try new models because certain models do better. The new rage is hierarchical time series forecasting. And then you can do a lot of good with recurrent neural networks. Usually the naive approach, just putting an LSTM into the mix, doesn't work that well. But if you really know your use case, and if you know what other researchers are doing, you can do this as well. And you can put those things into Onyx and then use ML.NET to make it actually operational well, which is very, it's the thing you want. Then you can get more and better data. And talking about data, there is a shameless plug. That's the company I'm working for. SQLite and comma separated value files do not scale, especially like this was all the work we did with one time series, very simple time series. You will usually have like more than that, so much more than that. And you want to be all the work, which didn't work in the first notebook for me, you want to have a reliable system that does exactly this work for you. Like you want to have your grids, you want to have recalculations, you maybe want to recalculate units, you want to align certain time series with each other, maybe you want to have a little bit more functionality. Everything that we can offer you in the software we produce. Also, we have auditing, metadata handling, compression, years of experience, and ASLA, which means you can call someone if stuff doesn't work. And usually there's always something that doesn't work. Useful community links. The company has a YouTube channel where we post stuff that is interesting and endearing. There is the .NET Discord. So .NET Interactive, the channel where most communication happens, is the Discord. And people are really quick to react, and they are really happy to hear about your work. Like, I can't put enough emphasis at how happy they are hearing about your work, because for you, it's obvious why it's good and why it works. For them, they have inkling, but they live from feedback. Everyone lives from feedback, so give them feedback. If you are interested a little bit, like learn a little bit more about F#, but you need help, the F# Foundation has a Slack, and people are really nice in this community, and they'll help you because everyone started out somewhere, and there are so many sub communities. If you're interested in like doing data science in F#, there is a channel for that. And then something I unfortunately didn't discuss was FS Lab, which is F# focused data science set of libraries. And there is a lot of goodness in that. I know it's not ML.NET, but maybe if you're inclined to look a little bit more into the data science-y stuff and a little bit of the statistically inclined stuff, you will find there. And yeah, don't be a stranger, get in touch. You'll find me there, and there. And thanks very much for your patience.
Thank you very much, Gregor. That's awesome. Good talk as always. Always fun to have you on. I always enjoy your talks a lot. You get some great feedback here in the chat. I'm just looking through what kind of questions we have here. I think we can start off with one. I think that was answered as well, but it could be good if you can reiterate that. It was from Jose here. Which code extension did you install to run your .NET notebooks?
Yeah, that's a good question. It's a wonderful question. I installed .NET Interactive, which is currently like it has made a transition to stable fairly recently, and it's .NET Interactive Notebooks. This will also install the Jupyter extension, which is used. Other than that, you don't really need anything. I also have, for coding F#, like doing ASP.NET Core applications in F#, I have the Ionide F# extension, which gives you like one of the best editing experiences out there, like on par with Visual Studio and Writer, even though the Writer people are very good, and the Visual Studio people are also like the last couple of releases have been.
Awesome, perfect. We have a question from Andre here as well, asking if you have code samples available on GitHub somewhere for use.
Yes. So that would be, I have posted in the chat, so you can post it in the chat. That's ML and vertical slices. There's all the source code. I try to document everything as well as possible. So with the presentation and the comments in the notebooks, you should be able to like really maybe go through stuff and think about it, because this was a very this was a tour de force in .NET Interactive, I fear.
Perfect, that's great. We have another question actually from Jose here. What is the main purpose of MLOps.NET?
I think I'm not the best person in the room to answer this question, but I know someone. Alex.
Yeah, I'm happy to answer that question actually. MLOps.NET is there to kind of help you get your machine learning models to production more easily and track the data that comes from, which models you have in a versioned way, deploy it in Kubernetes cluster with one click, as well as deploying it through a UI and those kind of things there. So there's an open source project. It's completely free. There's a stable version out there for you to use.
And I want to add something about going back to the interactive notebooks. We've been doing some user studies recently with interactive notebooks these past few weeks, and we're looking into whether it makes sense to have interactive notebooks in Visual Studio. So obviously there's a VS Code extension. But if it's something that you would want to see in Visual Studio, if you think it makes sense there, let us know. You can reach out or chat, email, Twitter, whatever. Yeah, just my quick shameless plug, something that we're doing on the team.
I love the shameless plug. I think I never heard that expression before, but I'm going to use it all the time. I'm going to shamelessly steal that from you, Gregor.
Do it. Like, always be plugging.
Yeah, exactly. As you said, you know, have to reuse good words and expressions always. Cool. I don't see any other questions in the chat right now, at least, but a lot of awesome feedback to you from people watching the talk.
Yeah.
So I think so I would just want to thank you as well for going on this virtual MLOps community conference again and sharing expertise, Gregor. It's fun as always, and thank you for joining us.
Thank you for having me. It was a pleasure.
Wow, thank you. Have a good one and enjoy the rest of the conference.
Yeah.
All right. And we now have Michael joining us here. Is that the way you pronounce it?
Yes, it's Michael. Yeah.
Perfect. All right. Well, welcome very much.
Thank you.
How are
Thank
you
you for inviting me. Yeah, I'm great. It's already 8 in the evening here, but I guess for some people it's just in the afternoon. But I'm looking forward to it.
So whereabouts in the world are you currently?
I'm in the Netherlands.
Oh, great. Fantastic. Which city?
Nijmegen.
Okay,
So,
awesome.
Almost at the German border.
All right, well, fantastic. We're glad to have you today. And you're going to speak about unlocking achievements with Xbox, right?
Yes, indeed. I think I'm pushing the boundary a little bit, just not normal machine learning models. I also want to use it for other stuff.
Well, we're excited to have you here. The stage is yours. Good luck with your talk. And any questions to Michael, put them in the chat and we'll ask them at the end.
Thank you. So welcome everybody. Thank you for joining my session here. My name is Michael Hompes. I work for InfoSupport in the Netherlands. I'm a software architect. But yeah, today I'm not really talking about my work, but more like my hobbies. So this session is called Achievement Unlocked, use .NET to unlock Xbox achievements. So that's what I'll be focusing on for the next hour. So first, of course, I like to thank the sponsor of this event, because that's making things possible to share our knowledge, and yeah, great thanks to them. Like I said, I'm going to talk about my hobby. So I'm a developer by day, but I'm a gamer by night. And it means I play a lot of Xbox games for quite some time now. So currently, and this is a screenshot from this morning, I'm standing at playing over 538 games on the Xbox, or the Xbox ecosystem, and also unlocking over 12,500 achievements. And that should be giving a little bit of an indication that I like to gain. So yeah, that's a little bit also why I got to this topic. One of the games I've played in the past was CNET, and maybe not familiar for everybody, but CNET is an interactive film trivia game, and maybe you know the game, or you might have seen it in the game catalog or the toy store catalog in the past. But basically, it was a DVD with a board game, and while playing the board game, you could watch clips of movies on your TV, and then you had to answer questions about those movies. And in 2007, this game was also for the first time released for the Xbox 360. And it was famous for its big button controllers. So really to give you that quiz feeling where you had that big buzz button, but also, of course, the 4 multiple choice answer buttons. And this is really where this game is also known for on the Xbox. So in 2007, the first edition came out. And of course, like movie games and like movies, you need sequels. So in 2008 and 2009, 2 sequels came to the Xbox as well. And then on 2011, they released another online-only version. Sadly, I had never been able to play it because it was US and Canada only. And for this session, I will be focusing on the 2009 edition. So it's called Bright Lights Big Screen. And like most Xbox games, the game has achievements. And of course, I want to unlock all the achievements in the game. But there's one of those achievements, spotless performance, which I couldn't unlock on my own. It's basically a very simple task. Answer all questions correctly in a long play game. But a long play game is 70 questions. And they are always in random order, random different puzzles. So getting 70 questions correctly in one go, yeah, that was not up to me. So back in 2007, when I was playing this, I already was thinking about, okay, should it be possible to use my webcam I had at the time to look at the screen, get the text from the screen? But yeah, in 2007, software was not that far yet. So a little bit background on Bright Lights Big Screen. There are about shy of 3,000 different questions in the game. And there are 23 different types of puzzles in the game. So that's why the random factor, well, doesn't help if you want to learn everything on top of your head, because yeah, getting 3,000 facts in, it's quite some studying. So for this session, I will be looking at the setup, how I approach this on a hardware level. Then I will go through the different parts I went through to get things working. So first, of course, looking at video capturing, then some Azure Custom Vision I have been applying, Tesseract OCR for text recognition, and then we'll be looking at more how do you do image matching and how do you do animation matching. And of course, on several parts of this session, I will be using ML.NET, not very surprisingly. So first, looking at the setup. I start, of course, with an Xbox. So I have an Xbox 360S, been having that for a while. And like many people, I've been working from home for quite some time now, and I want to use my desktop PC. So I want to connect my webcam to my desktop. And for that, I needed a capture card. So I ordered that capture card. I used it for my webcam. And then at some point in time, I was thinking, hey, I can use that capture card as well for my Xbox. I just have to use the HDMI in port. And very nicely, the card also has an HDMI out, so I could just put my monitor on it to see the actual output on my screen before I had any software working. So this is the setup. And the capture card I've bought was just one of the few available on Amazon. It's a Chinese brand, never heard of it, but it works fairly well. As an application, I'm a Microsoft developer for over 20 years, so doing .NET for all the time. So yeah, doing .NET Core was my go-to platform when I started developing here. So it started as a .NET Core 3.1 console application. Later on, I moved also to a desktop UI version using WPF. I will be showing that later on. And for people doing ASP.NET development, or maybe also for console application development, you might be familiar with Host Builder. I also opted for using dependency injection, which comes with that, and for an event-driven architecture approach. So I'm not only going to show slides, of course, I'm also going to show code. So this is my program CS. I have my host builder, and then I start registering all the services. And of course, some might be familiar. I add some logging to my application because I'm using event-driven. I have a service bus, so that's a microbus in this case. And then, of course, registering everything in my application. So that's the background services, the matching services, OCR services, everything I need for my application. For example, I register all my puzzles. So all the different types of puzzles in the game, I just have a simple class. What kind of question it is, text only, do I need a bus button, yes or no, things like that. So fairly simple .NET Core application approach. So of course, then the first task we need to do to get something from the Xbox. So how do we do video capturing? Looking online, I found a library, MGCV, which is basically a .NET wrapper for OpenCV. And when I started, it was version 4.3. I think we have moved ahead a little bit now. And one of the great things of this library is that it has both CPU support and it has GPU support. So I have an NVIDIA card with CUDA support, so I could even run everything on my GPU. It's not that I notice much performance difference for my case, but it's nice to be able to do it. OpenCV, and therefore also MGCV, has the video capture clause. And this allows you to use any direct show input device. And if you're not familiar with that, basically every webcam connecting using USB will be using direct show or be available in direct show in Windows. And to use this clause, we need to set some settings. I'll be showing you in a bit. And to make this work in my application, I created an hosted service and a timer with a callback. So first, let's look at video capture class. And for this, I have a simple demo application. To show you, I, at the moment, also have my Xbox 360 standing by. So I have my controller. I can control everything on my screen. And I will be trying to capture this image. The video capture clause has an integer input. So, and of course the type of capture. So direct show I already mentioned, but this is a hard one. Which capture device is 0, 1, 2, and even this changes over time. But for now, my capture card is number 1. And then I can simply say capture a frame and store it in a file. So if I now run this code, yes, it has run. I have a capture of my screen. Well, it doesn't look really HD. It's 640 by 480, but at least it's something that came from my Xbox. So we have to improve a little bit on this. And by setting some properties, like I want to have a 9020 by 1080 resolution, and run this again. And this looks already a little bit more HD. So if I now pull this full screen, it kind of looks like the output of my Xbox. So this is working, and this way I can get frames from my Xbox. To make it a little bit easier, I also wrote a simple NuGet package where you can say, give me all the input devices, and I can do a textual comparison, and it will give me back that number 1. But it's easier to use the name, because if then Windows changes the order of your devices, your code still keeps working. So, like I said, very video capture, very simple. Just set some properties, and you can query a frame. And I also mentioned the hosted, the background host. So let's look at the application again. Here I have my video feed background service. So it's a hosted service, which means it has a start function. And basically I create a timer, and every time as the delay has passed, it will say, hey, video feed service, do a capture. So this is my background service, and this will be calling my video feed service. My video feed service is configured to run 4 times per second. And every time it runs, I say capture a frame. And this should look familiar for the demo application I just shown you. And like I already said, it's an event-based application. So I create an event, put the frame in the event, and then use the service bus to publish the event, and the rest of the application can use the frame, the captured frame, and does that 4 times per second. And when I was developing this, I also thought, let's store every 4th frame, so basically a frame per second, on disk. And that was very handy, because sometimes the application didn't work, and I needed to do some investigation, some debugging. But because of the randomness of the game, I could not be sure what could come the next time. So by storing these files on disk, I could create a test video feed service. So because of dependency injection, it just inherits from the same service or the same interface. And I say, okay, play back. And this is basically because the frames were stored once per second. This makes the playback go tripled the amount of time. So that makes me wait a little bit less. And basically just load the files from disk, and then just create those events again with the file, with the contents of the file as a frame. So that was how I was able to capture the live feed, and later on also play back the captured feed. The NuGet package is also available, the source code is available on GitHub. The NuGet package is, of course, on NuGet. If you ever want to make it easier for you to capture devices based on the name. So I have the output of my Xbox, but still I don't know what I'm looking at. And for this, I thought it would be nice to use Azure Custom Vision. So for those not familiar with Azure Custom Vision, it's part of the Cognitive Services suite of Azure. And it's a very simple way that you can just upload images. You can classify and train a model. You can evaluate the output of the model and then basically use the model. I use the free tier. It has support for 2 projects. Well, okay, I only have 1 project. It can contain up to 5,000 images. Okay, no problem there. It can only have 50 tags per project. Well, for now, what I want to do, to classify what am I looking at on what type of screen am I looking in the application or in the game, 50 tags is enough. I have an hour of training, no problem. And there's an API available to do predictions. But here you see only 2 predictions per second and only 10,000 predictions per month. And I'm cheap, so I don't want to use the paid version. But this is also a problem if I'm capturing 4 frames per second. It will mean I can run this application for maybe an hour and then I have to wait for a month. But luckily for that, we can solve that. So first, let's look at the Custom Vision portal. So this is my project in the Custom Vision portal. And what you see here is images I've uploaded. So these are screens captured during the gameplay. And every image I've uploaded has been tagged. And these are the tags that I have chosen that were relevant for me. So for example, I have a tag that says questions with a visual. So questions with a visual are all questions where there is an image or a couple of images or an animation, a movie poster, anything that has a visual question. Also have a tag called questions with text. So these are all the question types where there was some text in view. So these could be questions like if you just shown a video clip and name the actress, or a fact, things like that. And there are also different types like sequences. Also very important, I need to know when does a new puzzle start. So that's, for example, this screen. So every time this screen is on view, I know a new puzzle is starting. If you're creating your own model, it's also very important to have a negative tag, because models tend to try to match always whatever you throw at them. So if you put on the Xbox boot screen, it will try to match it with one of the categories you already have, even though it doesn't make any sense. So always make sure you also have a negative category and put stuff in that is just nothing you want to match with any of the other tags. And this gives you a better quality of your model. Once you have trained your model, you can look at the performance. There are people that can tell you what this means. I'm a developer, I don't know, it just works. But also very important, you can have an export button. And that export button has a couple of models which you can use. And in this case, I'm working with Onyx. And Onyx, although it only says Windows ML, also works very good with ML.NET. So using this export option, I could download the model to my local machine. And then it's not a problem that I want to capture more than 2 times per second. I don't have a network connection that might be a problem. I don't have bandwidth issues. I don't have rate limits or only 10,000 captures per month. So like I've just shown you, it's very important if you're using cognitive services, tag those, or create those tags, tag all your images, train your model. And in case you want to download your model, make sure it's one of the compact models, of the compact domains. And I use the general domain. And then you can export it, in this case, in the Onyx format. Onyx is Open Neural Network Exchange, so it's very usable. And there's one quirk. And if you use custom vision, it will be using RGB, which is more like the standard everywhere, except for OpenCV, because OpenCV works in blue, green, red, BGR. So I had my model trained. I had scores over the 96%, ran it on my application locally, and it only scored, say, 70, 80%. And that was because the blue and the red channels were swapped. So very important to know. If you look at the Onyx model that has been downloaded, well, it's a fairly big model, but very importantly is you look at the input. The input says it's a float of 3 channels of 224 by 224 pixels. And that's something we need later on. The outputs is a class label. So basically, which tag does it think is matching the input, but it also has a loss. That's a sequence or an array of labels and their scores. And that can be interesting if you want to know how good did this classification score. Like I said, the input is 224 by 224. So that's very important to resize your images to. And this is the code I use ml.net to read a Onyx model. So you extract the pixels and then you say apply this Onyx model. Class label and loss are the output and data is the input. And then I can do predictions. And this gives me at least a view or a label. What am I looking at? So in my application, I have my screen service, which is the chain you just saw. And then every time I get a frame, I have to do that conversion of BGR to RGB. And then say I want to have that bitmap as input for my prediction model. I get the output and it contains my label and it contains the score. And in this case, I want to have the score of the match label, and this gives me a precision. And if the score is too low, then I will ignore this, this frame. So this is also very important to take into account. Always use these kinds of scores and thresholds. So if something scores below 70%, I will ignore it. It's not something my model has any confidence in. It has matched it with a correct label. If you don't do that, even if it matches a label for 0.0000001%, it will still give that label back as the most probable recognized image. So for that, always use thresholds. Yeah, this is what I just shown you. And this basically gives me, am I looking at a puzzle screen? Am I looking at a movie clip? Or am I looking at a question with text? So now I know where in the game I am. But I still don't know what's happening on the screen. Yes, I know I'm at the beginning of a puzzle, but I still don't know which of one of the 23 puzzles is in view. So for this, I need OCR software. And I chose Tesseract, which conveniently was part of the MGCV library as well. So if we look at text puzzles or text recognition, we use that for puzzle titles, but of course we use it for text puzzles, and we need to read the answers for the multiple choice options. And these are randomized every run, so I still need to know, does the answer stand with A, B, X, or Y? There are different types of text puzzles like anagrams, but also other where you need to know facts, you need to fill in blanks, you need to answer true or false based on the question, things like that. And all these are text-based. So like I said, I had Tesseract OCR available for me because it's part of the MGUCV library. But Tesseract OCR is quite old. It already exists, and it was created by HP in the 1980s. So if you ever had a scanner that was able to do OCR in the past, it was probably using this software. In 2005, the software was open sourced. It was adapted by Google, and they have put it on GitHub. When you use this software, you need to provide a language file. So in this case, the game is completely in English, so I want to use the English file. And normally you would create that file yourself or train that file, but luckily there are pre-trained files available on GitHub as well. When you are using OCR or Tesseract, you need to do two things. You need to pre-process your input, and you have to correct your output with common mistakes. So I will be showing that as well. First, I will go back to my demo application. And this time, I'm not going to do the video capture demo, but I'm going to show how Tesseract works. So like I said, when you use Tesseract, you need to provide a language file. And basically, in this case, I'm reading a file, and I will be showing this file. This is the file that was used as input. So it's a file screen, and basically, if I now do a complete screen, I will get this whole thing. But I also have set up a frame, a rectangle, which basically only is this region. And I'll be showing the difference in capturing that's happening. So I read this file. Here I have my rectangle, and I do two things. First, I will check the whole screen. So I pick up the whole screen, and then give Tesseract the command to get all the text in UTF-8, basically Unicode, and output it to the screen. Then I will only pick up that rectangle with only the title and do the same. So this will be showing you what happens when I capture the whole screen versus a very targeted section. So let's run the application and also put it side by side with the screen. So if we look at the whole screen, we see some zeros. Well, okay, that is right. Those are here. Then we see some text I can't match. It sees the title, movie clips. Then some random stuff again. Some text is matched, but it doesn't look like the whole text that's here on the screen. But if you look at the frame, it certainly matches movie clips alone. So that's working great. The whole screen, not so good. So how can we improve on this? And for this, you need to do some simple things. For example, you can change the mode Tesseract is working on. So let's say we want to capture only a single column. Let's see if that helps. Well, at least it's become longer, but no, not really. It's still messy what's being captured. The frame still works fine. But what if I now just change the input and make it grayscale? So remove color and go to grayscale. So if I now run this application, what it does, is it has created this version of the image. So just black and white or a grayscale, but nothing more fancy. But if we now look at what has been captured, we suddenly see a very crisp text, and it has captured very nicely this column of text. So just changing some of the properties on the input and on the capturing of the tesseract really makes a difference in how text is captured. So this is the demo application. Let's look at the actual application. So the capturing is basically the same as just shown, but also here I have a method that does common mistakes. So for example, if you have Star Wars 2 and 3, those Roman literals are very badly captured. So I really need to accommodate for that. And 2.5 needs a space in between, but it doesn't see that. It removes the space, so I have to introduce it again. Because I have, of course, a very limited set of input, the mistakes are very common, and it makes a small list of replacements already good enough. Also, why it's having these issues is mainly because of the font. The font that's being used is very condensed, and therefore it's very hard to read. I could create a tesseract model with this font, but it's looking at the documentation was way too complex for me, and I was fine with just making some corrections. So tesseract OCR, load the OCR model with your language, choose the correct mode, and then you can get text from your image. So now I also know what's on the screen, but I need to answer questions. Well, I was lucky. Like I already said, I like to get achievements, and like many people that do a lot of achievements, they are on the website of trueachievements.com, and there's also a page for this game. And somebody put a zip file on for shared, and it contains an Excel sheet, and it contains a lot of pictures, photographs. So to dive into the Excel sheet, this is the Excel sheet. It contains over 3,000 lines, so it's way too small to read, and it doesn't matter. But basically, it has for every question type most of the answers that are in view and what is the correct answer. So this was very helpful. It was not completely correct. It was not completely covering every question, but it was very helpful. To use Excel, I used EP+, which is also a free for non-commercial use library to work with Excel files. And basically, you load up your Excel file, and then you can do link queries against your Excel. So in this way, I could use the OCR software to look at what's on the screen, and then use the Excel file to look up what's actually on the screen, what should be the answer, or what is the question. The image that were provided inside that zip were not of great quality. So this is somebody taking photos of his TV screen under an angle, and this is not really usable for machine learning or doing image matching. To compare, this is the actual image if from my capturing the output of my Xbox. The same for other images. The quality is quite low, but it was the only thing I had when I started working with this approach with my application. Also, the image was skewed, so really hard to use it. So to have machine learning models work better with images that were in a bad shape, I started to look at, okay, how are the dimensions, how are they skewed, and come up with averages. And then I encoded those in a console application and basically used MGCV or OpenCV to do a transformation. I used the perspective transform with a warp perspective. And what it did for me was, as this was the input image, I did some modifications. And you also can see on the left bottom, this is a near perfect transformation to something that might look more what would be the output of the Xbox compared to this image. So this was at least giving me something to compare against. But then I need to do the actual image matching. So there are several types of image puzzles in the game, and these are still images. So, for example, something is removed from an image, and you need to know which movie or actor is in the image, or it's a famous, recognizable shot from an image, or there are pictograms, these kinds of things. But there are still images. So it's fairly easy to compare them. For this, I used OpenCV image hash. There's a very great blog article on HackerFactor that dives into how you can use OpenCV image hash. And even the simplest hashing algorithm was already good enough for me. So how does image hashing work? Let's take a very big image. First, it's getting resized, basically 8 by 8 pixels. So I've blown up the resized image so it actually is even visible on the screen. And then it's basically turned into a grayscale or black and white representation of that. And if you do that at the same time for all images on disk where you want to compare against, then it's very fast in giving you a match. So looking at the actual code again, I have no mouse cursor at the moment. Here. A service called still image service. And basically, when this service is loaded, I will enumerate all the images on disk and already load them in memory, resized to 1/8 of the original size and converted to grayscale. But they are all in memory. And then every time an image comes in, I will just loop through all the images and use the hashing algorithm to compare and get scores. And basically say the best scoring match wins, and that would probably be my match. And this is really fast. This is milliseconds. A little bit harder it comes when we are talking about animations, because when we are talking about animations, the chance that we have a still image on disk and the input from that's coming in from the capture card are exactly the same is low, especially for movie clips, because they have different camera angles. So that's really hard to do with image matching. And for this, I used, of course, ML.NET. So a couple of categories of puzzles is where we have basically pixel versions of movies, we have distortions, and we have sketches. So over time, changing images. Like I said already before, Azure Custom Vision was not sufficient for me for using this, because the amount of puzzles with images, animations is well over 50 labels. So that would not fit. And also, of course, like I said before, I do much more recognition than the 2 frames per second I could do using the API. So I had to learn my own models. And for this, I used ML.NET, and in this case with the ResNet v2 50-layer model. So going back to the code, I had a visual answer trainer application which for the animation categories would look at the disk to all the files, and I would create a pipeline to train. So this is basically following the simple samples of machine or ML.NET on GitHub. You load all the images from path, you fit them in the pipeline, you transform them, you create a training set and a validation set, and a test set, and then you have in class trainer options. And in this case, like I said, I use the ResNet V250 architecture. And of course, I had some location on disk. Then I started training. And in the end, I say, export this model as a zip file. And after the training is done, I get a zip file about 75 megabytes big. So I have 5 of them, and I can use them in my application, just like I did with the Onyx model. So in my application, for example here, the animation service, when it starts up, it will look at all the puzzles that are of the type animation, and it will create a prediction engine for that and load it in memory. So this is not a very memory efficient application. It has 6 machine learning models in memory, and also a couple of hundred of images, but it was not too bad for me. So here I load the model, I create a prediction engine from it, and then I have to do some magic to get all the labels out of the metadata of the model. So there are some funky data types like vbuffer, read-only memory, and also you need to do something with dense values, and then you can get an array of the actual labels in the metadata of your model. But once you have that, you can use the labels to get later on your score. So when an image comes in, I encode it as JPEG to compare it against the prediction engine. I get an output. I use that label that's been predicted to the Excel service to get a movie title. And then I can look at the scores to get the scores. And if the score is below 50%, I ignore it. And is it above 50%, then I use it. So basically what it does is matching movie clips. So I have snapshots of different camera angles for every movie. So basically what I did was create 4 snapshots per movie, and then train a model. And now if it comes up with the label MC1, in the Excel sheet it says, hey, that's the rocker. Or it comes back with MC8. The Excel sheet says, hey, this is the Terminator. For animations, it's a little bit easier because we don't have different camera angles. So basically, I have a snapshot of the beginning, the middle, and the end. And then it says CP2 is Planet of the Apes, and CP7 is Castaway. So for most of the animation, this works quite nicely. However, sketches are a little bit harder. Sketches are drawn from a basic empty sheet of paper, and then you see it being drawn to the complete picture. But if you take, after 3 seconds, a screenshot, and these are 4 very different images, a machine learning model will basically say they are identical because they're all a lot of white, a little bit of black in a centered location. So this is not here. Machine learning is not really the answer. But luckily, I have OpenCV. I can do a lot of image calculations. So if I have that beginning, middle, and end shot, I can use my current screen input, and they basically do a subtraction. And if I do that, I can count how many pixels do I have. And if the difference between the original image and the subtracted image gives me a delta, and the images with the biggest delta are probably the image I'm looking at. And calculating this, I can also care for sketches. Well, I've talked a lot. I've shown you some code. Maybe it's also nice to actually show you the end result. Like I said, first I had a console application. Then I thought, okay, WPF with view models and bindings is much nicer to give a UI. And because I used dependency injection and event-driven architecture, I could fairly easily switch between a console output and a Windows UI output. The only thing, and if you did Windows Phone development back in the days, you might recognize this. Background threads cannot update the UI, so you have to do some ditch patcher trickery. But if you have it working correctly and have the updates on the right UI thread, then it works very nicely. Of course, I needed some nice buttons representing my Xbox controller. So I found a very old project where somebody did for Vista some buttons, so I could adapt that for my Xbox buttons. And I then had a nice UI. So let's look at the end result. So this is my application starting. We'll see that the memory output will go to about 2 gigabytes of memory. We will see some debugging information in the lower left corner. Here we see the start of the puzzle. We see already it has recognized that the text is movie clips. Currently, it's trying to recognize the movie. It already did. It's for your consideration too. And when the movie clip is done, also you can see that all here in the debugger, the questions will pop up and it will immediately start recognizing text. So it will show here the detected question. It will show here the answer, and it already shows Navy because the answers are not in the image already, but already the recognition is so fast it already knows what the answer should be. And as soon as the answer matches up with one of the textual answer with one of the answers, it will show the actual button. Here it doesn't show an answer because here it doesn't recognize the text correctly. So here I have some OCR fixing to do. But immediately the other questions, all the text is recognized, and you see it's answering the questions immediately and showing the right order of the buttons to press. And I'm playing this now 3 times faster than the actual game, and still my model can keep up. It's also very good stress testing because I now see my memory is constantly on 2.1 gigabytes. Also, and I didn't show you that, you see here the console image popping up on the left. That means you have to press the buzz button. Also here I use OpenCV to match that image. And as soon as it matches, then you will see the buzz in button. So this is the application working correctly. So now, of course, the question is, I put a lot of evenings and weekends in this. Did it actually help me and work for me? Well, luckily for me, yes. It was achievement unlocked. So back in August last year, I had my spotless performance answering more than 70 questions in a row correctly. Only 4% of gamers in the world did this at the moment, or at least in August. So all that work brought me at least something. But it also shows that with existing knowledge, with tools that are around nowadays, it's easy to build something like this. We can use the output of our Xbox. We can create models for every situation we want. We can use Azure Cognitive Service as a very nice way to tag things, or we can use ML.NET in a console app to create new models, and we can really combine these things. During this creation of this application and the demo I've used in this session, I've used quite some libraries. I've put them all on the sheet. If you want to dive into one of these techniques, these are the links. If you want to know more about this application, I did 3 .Netflix episodes on YouTube. So if you want to see something again, or maybe other details which I left out for this session, there are 3 episodes online on .Netflix. So that's also an option to look back at this. And with that, I want to thank you for your attention. I hope you liked it. I hope there are some questions so I can answer them now.
There are some questions. Thanks for that awesome session.
You're welcome.
I've been wanting to see something with like gaming and ML.NET, so that's really awesome to see. So I guess we'll start with Jose. Of course, got lots of questions. How do you is it MGU CV? How do you pronounce that?
Yeah, I also just called MGU, but maybe it's EMGU. I don't know.
Well, they say that they've used MGU CV too, and it's a good library. But have you already compared this library and Sharp CV?
No, to be honest, no. This library just worked for me. So yeah, if it works, I didn't have a need to look at a different library, so I can't compare them at the moment.
If it ain't broke, right?
Yep.
Okay, Luis, have you had experience with both of these and can comment on this, or?
With no, I have heard of them, but I typically haven't really used them. But yeah, I do know that there's some of the more popular ones.
Gotcha. Jose has another question. Does MGCV grab images directly from your Tanzia capture card without any other API?
Well, it uses the Direct Show API of Windows itself. So basically from OpenCV, it's using just a capture device, and from Windows is doing the middleware, basically. So MGCV doesn't know it's connected using USB or PCI or whatever is in between. I also use, for example, my Elgato capture link card, and that's a USB stick. The application just doesn't know it. It's just Windows providing that API for you, and MGCV or OpenCV talking to the Direct Show API of Windows. Yeah.
Okay. And then Andre, could you show us again the slide of the Onyx model, and which software are you using to show the Onyx model on the right part of this slide?
I can even do better because I have the application open without the slide. This is called Neutron. It opens on the, it's also on GitHub. It's open source, and it can open the Onyx model, and you can then click on all the parts of your model. And this is where the part where I really don't know what I'm looking at. The only important thing I know is what do I have to put in, and in the end, if I come on the end of the model, which is quite long, what comes out, and here you see that class label and the loss, and also something like there are 17 labels in the system. But yeah, so this is Neutron. Yeah, it's a nice tool to look at your model and to look at what kind of data types are going into your model and out, because, for example, that 224 by 224, I could not find that anywhere online beforehand. Afterwards, if you know it, then you start recognizing it in the documentation, but it's not really documented that you need to resize your images to exact that dimension. So that's why Neutron is a nice tool to look at your models.
Yeah, and I saw that they recently added like a preview feature that you can actually see ML.NET models in Neutron as well, which is cool. I haven't checked it out in a little while. It's been a few weeks, but
yeah, for me the lucky thing is, of course, because I create my models with ML.NET, I can already use them immediately with ML.NET. So
yeah,
no compatibility issues there. So I only needed it for the Onyx model. Yeah.
Yeah.
And you're not alone in that. I don't think anybody knows what it means. It's just like, yeah, let's try this out and let's see if it works.
Right.
So you're not alone there.
Yeah, the great thing is it works. And so, yeah, why do you need to know more?
Right.
Sometimes a tool is a tool.
Exactly.
Right. So Jose has another question. Why did you choose ResNet v250 for your application over the 4 available ones here?
Yeah. I did try out some of them. Also, I had various, basically, especially when I didn't know the RGB versus BGR conversion issue. I was also looking into what are the differences. I did use the 101 layer. Basically, what it meant for me was that the zip files with the model were twice as big. So they were 150 megabytes instead of 75 megabytes. But quality-based, the recognition wasn't better or faster than using the 50 model. So that's why I also just used that one. And in the end, when I was comparing them, I didn't see much difference because, and that's of course, I have a very limited input set. I'm not using a webcam to the outside world where constantly the weather changes, lighting changes. So I'm lucky that my input is fairly consistent. It's always that full HD screen for my Xbox, and the set I'm testing against is very limited. So that's why maybe it doesn't matter really which model I'm using. And yeah, so I took a ResNet V250 because it worked.
Seems to be a common theme. It just worked.
Yep.
So Andre, oops, wrong one. It was a very
It is a very cool talk, though.
But the question
well, thank you for that.
if you could post the GitHub link of this project.
I'm currently only have it on my private GitHub at this moment because of 2 reasons. I don't know the legality of all the images I have and the models. So I think the models are fairly safe because the models are not containing intellectual property. The other part is I have bought the font because I like the font to use it in my application, and the license doesn't allow me to share the font. So I have to look into how can I share the models without all the input images, and how can I remove the font and upload it to a public place. But it will be coming to GitHub. Also because my next project will be that I will be trying to use an Arduino and an Xbox controller and solder it together to also start actually answering without me myself pressing the buttons.
Wow.
So that will be my next project.
Well, that will be very cool. Okay. And then I think you have your Twitter handle here. So
yes.
if, in the future, if it ends up in a GitHub repo or future projects, you can see his GitHub.
Also on GitHub, I use the same name. So it's the same name on GitHub. So if you want to reach out, use Twitter, use GitHub. And I'll be happy to also share a code because it's I really like to share it. It's just I just can't put it as is on GitHub.
Makes sense. Let's do one more question. Angela asked, the hash technique you presented, what is the limitation? 8x8 pixel and gray? Is it too much, reducing the image complexity?
I would expect that, but it's really surprising how fast this hashing is. Of course. Here again, and I think that is just my benefit in this case, my set is fairly limited. And for some reason, and that's why I tested also different hashing algorithms between very fast and very simple versus more complex and more CPU bound. Like I said, I have about 300 input images to compare against. It's going almost instant. I think it helps I use the CPU or the GPU because GPUs are very fast in these kinds of workloads. It really performs on fairly limited set. And my input is a 920 by 1080 image, and it gets resized to basically 8x8. So it's really amazing how those algorithms are still able to make a distinction between the different options, and it doesn't fail me. But again, I have a very limited set to compare against, and that's my benefit.
Gotcha. Well, awesome. Thank you so much. And Jose, we see your question. We can answer in the chat because we want to make sure we've given Arafat enough time. But yeah, thanks a ton. This was an awesome session. And it will be recorded for anybody who missed it.
Make sure to leave your feedback. This was a great talk. So let Michael know, how he did, and let us know how we can improve as well. So with that, again, we want to thank you. This was a really cool project, and we're looking forward to when you solder that Arduino and you are completely automated running this project.
Yep, I'm also looking forward to do that, because that's a new challenge of new technologies I never used before, and that's always a nice thing to do.
For sure, we'll be looking out for that. Thanks a lot for joining us.
Thank you.
Okay, awesome. So Louise and I are both trying to control it at the same time.
All right, I'm gonna hands off.
We're going to introduce our next speaker, unless Louise, you have anything else before?
No,
Cool.
that was great. Yep, let's keep it
Okay.
rolling.
Then let's bring Arthur on. Hello.
Hello. How
Good
are
morning.
you guys doing?
Where are you calling in from?
Yeah, I'm joining from Sydney, Australia. So it's 5 a.m. in the morning over here.
Ooh, I feel I was on at 6, or I guess 6:45. So you win in this case. Win or lose, I don't know.
Yeah.
But thanks for joining us.
Yes, no problem.
And I guess with that, we can start your presentation. You'll be talking about object detection. And yeah, so we're already 2 minutes in, so we'll let you get started.
Sure. All right. Hello, everyone. Thank you so much for joining me. I've seen a couple of sessions before joining this one, so I can safely say that they were super good. If you are new to this space, which is ML.NET, then this one is going to help you out a lot of. It is going to help you out for sure. So I'm going to talk about beyond sentiment analysis. What are the other options you have with ML.NET? And object detection is one of the latest offerings which we are going to see. So before that, I'm going to just introduce myself, and I'm Arafat Tassin, joining from Sydney, Australia. As I said, it's morning over here. I'm a Microsoft MVP for AI, and I work for EY. I also run a couple of things. So Azure Sydney user group, if you are around over here, we will be conducting our first in-person meetup. So this is super cool in Australia. If you are interested in learning about bots, bot framework, if you are a developer of bot framework, you want to contribute to the community, we have a project called Bot Builder Community Project. You can always go and check it out. I also run Global AI podcast, and this podcast covers different Microsoft AI platforms. We invite different guests from industries, and this is the special month. So I'm announcing it for the first time that Global AI podcast will be featuring ML.NET team. When it is going to happen, we will be keeping you posted about it. So let's move on. So what are we going to discuss today? As I said, that if you have started your journey with .NET, or if you are fairly new to .NET, or if you have been using .NET framework or .NET Core, and you were not aware that there is something that ML.NET, which is a machine learning framework, then you are at the right place. So we'll discuss a couple of theoretical stuff first, and why we are discussing this. What is the projection of AI? What is the no-code or low-code AI landscape, and how does it look like? Then we'll talk about ML.NET. What are the scenarios? What are the problems? What machine learning problems ML.NET solves? And then we'll look into the ML.NET CLI and the model builder, and how I used within my projects. So we'll see those demos as well. Moving on. So I start with this quote of the Microsoft CEO, what they are looking after and what is their vision. So this vision, although Microsoft is one of the leaders in this space, but this is not restricted to just Microsoft. And I've seen small startups as well who are very visionary, and who share the similar vision of empower everyone or democratizing the use of AI and enabling everyone to use that. So now, why we are not discussing any other technology and we have been discussing AI or machine learning? And the reason for this is you can see that by 2030, the value AI is going to bring to the businesses is much more than any other technology, from retail to travel to automotive industry. It is going to have a big boom, and where automation will go from 33% to 47%. And when we see that in today's world, retail industry is booming, imagine that by 2030, what it could bring to us. So this is super fantastic, and humans will be focused on what is important for them. Definitely, they have been doing it, but they will be focusing more on that. And the main catalyst or main player around it to achieve this target from 33% to 47% are the cloud AI developer leaders. Cloud AI development platforms. And those platforms are built by some of the leaders, some of the visionaries. So this is the Magic Quadrant of 2021, which was released by Gartner. And you can safely say that all the big player in the software market is investing heavily in this space. So you can see that Microsoft, Google, IBM, or Amazon, they all are spending with others as well, like Paidu and Alibaba or others. They are also investing heavily into this technology or into this cloud AI development platforms. And you can recall the quote which I shared 2 slides before, and I was talking about the democratizing everyone and enabling everyone by giving them tools. So those tools can be developed in this space, and that's why a lot of companies are investing heavily into this. So now, what the tools which are empowering everyone, it must be they must be created in an accessible way and in a way that everybody can use it. It's not just for developers or people like us who have been doing or who have been writing code as their day job. So it's for everyone who is not writing code, who is just a subject matter expert, who knows how things work but cannot write a code. So in order to create that, there have been a lot of no code or low code AI tools available now in the market. And if you see the amount of expertise required, where we see that advanced expertise is required, there are just handful of tools available over there. It's not just about availability, it's about what other software players or industry giants are building their products around. So according to Gartner, again, by 2023, 50% of the medium to large enterprises will have adopted and low-code application platforms as one of their strategic applications, one of their strategy indicators. So this is super cool, and you can see, and if you have worked on any of these products from Microsoft, you can see there are a couple of Microsoft products over there as well, along with others, and all of them are in power tools or accessibility promoters metrics rather than in expert tools. So you don't need to be an expert in using those no code or low code tool. And that's why I was saying that in order to enable everyone, you need to build something which is very accessible or which is very relatively easier, and it's not just made for developers. So for your interest, I have also shared the latest graph of the Google Trends. So I was just looking at what people are, if people are looking for no code or low code, and I could see that there is a trend which is going up. it's been up and down, but according to Google Trends, it shows me the projection is going up. So this is super cool, and the world is moving towards that. I know that it's not 100% there yet, but it's good to see. Now let's talk about Microsoft AI stack. What Microsoft AI stack has to offer. So from pro code to low code to no code, you can build fantastic models. You can use these capabilities into your products, whatever you wish for, and whatever your platforms permit you. So if you are a pro machine learning expert, or if you are a data scientist, you can definitely use Azure ML Studio to build sophisticated machine learning models. If you are a developer like me, I work on C#, so I can use ML.NET for almost everything. If you want to use the capability of cloud and use your pre-trained models, cognitive services, then Loeb is one of the latest offerings by Microsoft. It was, I think, acquired last year or something. Then it was improved a lot, and there is just one case right now, image classification, which you can do this using Loeb, but an AI builder as well. Fantastic stuff. So as you see, you can consume these models in different in almost everywhere, in almost all of your applications. So except for WinML, you cannot create a custom model, but you can, I think, train now. So the amount of expertise, you can see that it is not required at all, except for Azure ML Studio. So literally, if you are a C# developer, you don't even need to know what are machine learning concepts, although it's good to know. It's always good to know, but you don't. In order to start building these things, it is not prerequisite, and I'll show you. I built one of the things with just a very basic stuff, and it works, and it still works. So little bit of history, how ML.NET came into being and what is ML.NET. So I think in 2002, Microsoft research team built some machine learning capabilities into their applications. They built some platform or some library. By 2011, that library was renamed as the Learning Code, and that Learning Code was used in almost all the mainstream products of Microsoft, where the AI capabilities were used, such as if you use Microsoft Excel and you see recommended charts in Microsoft Excel, or if you use the design suggestions from PowerPoint, Windows Defender or Windows Hello, and a lot of stuff like that. So everywhere these libraries or that library or the variant of those libraries are being used. Then in 2018, Microsoft decided that they should make that library a little .NET friendly, and open sourced it and named it as ML.NET. So what is ML.NET? ML.NET is an open source and a cross-platform machine learning framework for .NET. So it works on Mac, Linux, Windows, and it can definitely work with Azure on-prem or any other cloud, and we'll be looking at the Azure part soon. So what is the benefit of ML.NET? As I said, I'm a C# developer, and I want to utilize my skills. I did not want to use Python, not because I don't want to learn new things. It's because that if I'm comfortable with something, I would like to remain in that ecosystem, and I want to use my existing capabilities to build those models. So you don't need, as I said, data science or sophisticated ML expertise, but if you know these things, it is always good. It's always better. So you can use .NET if you want to stay in the .NET ecosystem, like you want to build some model and you want to use in any of your your .NET application, be it a mobile app, be it a web app, a bot, or any other .NET application. If you want to train a custom model without any low-level complexity, so there are a couple of scenarios, production-ready scenarios, and which are being used in production as well, where you don't need super complex stuff. You can still use ML.NET without even writing a code. So if you want to use pre-trained models which were created by TensorFlow or any model running on Onyx runtime or built on Onyx runtime. So I'll quickly go through these. These are a couple of problems machine learning. So classification, regression, forecasting, and all that. Classification is the sentiment analysis where you classify whether it is A or B. So whether it is eligible, customer is eligible or not, whether they will buy or not. Regression is a problem which we will be seeing as a machine learning workflow where we are predicting the price of fuel. So how much or how many kind of problems are the regression problems? And then it has, there are different capabilities. So forecasting, and I'm just writing some of the examples to show you that what are the examples you can use or where you can use these techniques to solve your problems. In the last, we have got the machine learning, image classification and object detection. So image classification is to identify what kind of image is it, and object detection is to locate or categorize the object or the entities inside an image. So how do I do that? Is it just SDK? Is it just a NuGet package? So definitely there is ML.NET API. On top of that, we have got that ML.NET API, by the way, can be used in Visual Studio Code, Visual Studio, Jupyter Notebooks. And then we have got ML.NET API, Auto ML.NET API. So I'll discuss this, I'll touch this part briefly in my upcoming slides. So just bear with me for now. On top of that, we have got two tools, which is ML.NET CLI and Model Builder. So for both of the tools, you don't need to be an expert in machine learning, and you can still create cool models. So before we get into any thing further or any other details of technical machine learning stuff, let's see how machine learning workflow works. So first you prepare your data by feature engineering it. And if I'm using any of the jargons which you don't understand, the simple way is to Google it or ask us if you have any queries. So you just tailor your data according to your needs, and then you just give it to the system to build and train. So you give it to any framework, which is machine learning framework, you build and train, and that machine learning framework pops out the model, and then that model can be used into your applications. So the process of preparing your data and building and training your data is called model creation. And whereas if you are using it in any of the applications, this is model consumption. So it sounds super easy, right? But it's not that easy to create some cool models, to create an accurate model. It's not always easy to build or come up with the accurate models. And why is that? So we'll have a look at this problem. So how much is this car worth if we want to find it out? And so this is, this is a regression kind of a problem, as I said, that this is how much or how many when we are going to predict the problems, or we have to solve problems like these. This is a regression kind of a problem. And in order to solve regression problems, you need to use regression algorithms. So the workflow would be, we have to select first couple of features. So as I said, my features of car on which my cost would be. impacted can be mileage, condition, or let's say a car brand or year of make. So, and then these algorithms are regression algorithms. So I'll choose gradient boosted, let's say. And if I choose this, I will just select some of the parameters. And if I give it to ML.NET, let's say, I'll get 30% of the accuracy. Now, you know that with this percentage of accuracy, nobody wants to use this model. Even you also never want to use your model into your applications. So how to improve this? How will you improve this? Then you will, so first of all, what you need to do, you need to tailor your process again. So you may have to include some more features and then choose some other algorithm, and you may come up with 50% of the accuracy. So cool, 50%, it is better than 30%, but it is not there yet. So now what you will do, you will keep iterating this process until you get the perfect result. So the problem with this process is you will spend a lot of time in identifying what is good, what is not. Secondly, in order to build a fantastic and accurate model within just few attempts, you need a good amount of experience or good amount of skill set in machine learning space. So if you don't have it, then what should I do? Wouldn't it have been better that a machine could do this process automatically rather than we do it ourselves? So because to solve this problem, AutoML came into being, and in AutoML, what we do is we just provide our input data and select these are the features, the choice of algorithms, and the iteration of algorithms, as we discussed in my previous slide, will be handled by a machine itself. And so how it works, it will automatically try different combinations with the algorithms, and at the end, whatever is the highest accuracy will win, and then it will be created as a model. So an optimized model will be created, and then that model can be consumed into your applications. So for this one, you don't need a specific skill set. You don't need specific. You save your time, and it's helpful in many other scenarios. I know that there can be there is a lot of still there is a lot of improvement required in a couple of scenarios. So there are cases, and not all the scenarios are covered in an AutoML library for ML.NET right now. But for some basic stuff, you can always use that, like sentiment analysis or classification or multi-class classification and something like that. So what tools do I have? As you may remember, we discussed. So ML.NET CLI is one of those tools which you can use, and since it is CLI, so you can just write a single command to create your model with AutoML. It always removes the implementation headache from you, as I discussed earlier, that you don't need to go and iterate yourself by choosing different features, choosing different algorithms and parameters and all that. It is cross-platform, so you can use in Windows, Linux, or macOS. Then the best part of it is it creates the code and the example for you to use in your applications as well. So you can see that how you can consume the model basically, and this is super cool. So if you see this GIF or GIF, because this has been a debate in our current YouTube stream as well by Lewis. So if you see this command, I've just written simple command, and it is creating a model, and it has given us the good output, what is it doing, and then it is creating a model. You don't have to worry about this. I'll run it in front of you. So I'm just showing you that it is as simple as writing this command, And by writing this, I created one of the libraries called Sentiment Analyzer. So it has been downloaded standalone, just 7,400 plus now. It's the number is wrong. I checked it just a few minutes back. And and it is also used in different projects like bot builder community middlewares, where standalone they were like, I've not included those download numbers in this because I think they were more than 14,000 as well. So I created that library using the simple command like this, although my data set was a little different, but it was not super cool data set or something like that. I'm improving that. So I'll talk about that in a bit. Now, before we get into anything else, let's have a look at the demo. So this is, first of all, I'll show you how you can install this. So in order to install this, this is super easy. You just go and write this command into your terminal. So like .NET tool install. So since I already have .NET tool, so I did not have to use it, install it. But this is the ML.NET library, which I have already installed on my machine. And you just have to do this, and you will find you will find it. You will have it installed. So ML.NET CLI with AutoML has got limited scenarios to cover. So you cannot solve, as I said, a lot of problems, but I think 4 or 5 problems are covered over here. And I'll show you the link where it is mentioned, I think. But then it's super simple. You can go and check how you can use the sentiment and how you can utilize this. This is a very fantastic tutorial. It includes everything. So and how you can utilize this and build your model. So I did the similar stuff. What I did that I have written. So this is first of all, let me show you my data set. So this is my data set, this one. And you can see that it's just a text file, nothing fancy in it. One sentence and the result of that sentence. So 1 is positive, 0 is negative, because it's just a classification type of algorithm. So or you can say a binary classification. And so this is my data set, and I am going to write a simple command. So this command, what it does, that it solves, as I said, classification problem. My data set is this, my label is this. So before I get into this, yeah, so this is my text. My label column is 1. So this is my label column, 1, 0, and all that. And it does not have a header. I want to train it for 10 seconds. And if I just run it, then what is going to happen is it will just run it for 10 seconds. And then within 10 seconds, it will create a model with the example. So this is cool. Example is very helpful for you. So since the example has been created, I'll just try to open it very quickly. And once it is open, we will try to run it. So we'll also see that what is there. So everything is created. Your model is here. Your schema or input and output classes are here. How you can consume it is also here, and how the AutoML does this behind the scenes, it's also here. So if I just quickly run this application or console application, you will see that it is going to give me this result. Wow, love displays. And I think this was the part of my data set, and that's why it is giving me this cool result. But if I come and I change this, so like this, and it is going to give me some result. And it is giving me a positive result because I think it is quite similar to the last one. But you can build, now you can utilize this model in any of the .NET standard application. So what I did, I used this, I created a sentiment analyzer. So this is the code of my sentiment analyzer, which I showed you over here. So this library, this is, as I said, it has been downloaded for around 7,500 times. It's being used by bot builder community sentiment analysis as well. So over there, it has been used more than 14,000 times. And this is the code. So I've not done any super fancy stuff. This is my class, which I've just written. I'm using reflection to load my model, and then if anyone uses this predict function, passes text, and I just return the sentiment, whatever is there. So that's it. And if you want to check out, definitely this whole source code is available, so you can check it out. If you are new to this space, you want to work on the model, on the improvement of this. So this is for you. You can. I've written this. We have shared a couple of ideas over here, and you can improve this, fork it, and you can submit a PR if you want. So this was about sentiment and analysis, but the world does not stop here, right? And we should not stop over here, and we should not label us as, oh yes, I've done a lot of things, now I'm a machine learning expert. No, but solving classification problems solves a lot of business problems as well. And I personally have used ML.NET in production, solving one of those classification problems, and for one of our customers, and they are quite happy. So now let's talk about the other capability, which is model builder. So what model builder does is, model builder is absolutely no code way to build models. You can see on the animation right on your right. We will also see this in the demo. So now with the March update of model builder, so this is in preview, by the way, but with the March update, we have seen a very big improvement, and that is with the .mb config files. So you can keep your multiple models over there as well. And this is super cool because you don't lose these changes which you have built. Earlier, when we were working with model builder, we used to lose our changes after the model is created. So now you can still use them. And then, so it solves a lot of problem. Bree has written a fantastic blog post on this on March update. You can use that. It utilizes the Azure Machine Learning Studio experiments for resource-intensive operations like object detection. So what is object detection? If you see on the image on your left, there is a image classification problem solved, and over there it is just the machine is recommending that this is a person in this image, whereas on your right you see there's a person, there's a footwear, there's plant, laptop. So what it does, it goes and locate and categorizes the object in images of frames. So this is a basic difference between object detection and image classification. Both come under the computer vision field or computer vision area of machine learning. So as I said, object detection capability is there in model builder. We will see that in a while, but let's talk about tagging. So how will you tag your image? I remember the Michael's session before me, and he was showing custom vision to tag his images. So now, if you don't want to use custom vision because you want to use ML.NET, How will you do that? So in order to use that, there is a fantastic tool available called Visual Object Tagging Tool. This was built or created by Microsoft CSE, the Commercial Software Engineering team. This is fantastic tool. It also works on web or local. So I've got it locally installed. You can just go Google VOTT and you will see the URL. You can download it. It's on GitHub. It's open source, so you don't have to worry about licensing or something. So we'll see that in a while. Now let's see the demo and then we will check it out. So before we get into this, I will show you this blog post by Bree. So this is Model Builder preview. It has got all the information of mb.config file and all that. So you can check it out if you want. This is the visual tagging tool, but let me do something. So I'll create a very simple project. Sorry, I'll create a very, yes, that's fine. I will create a simple project, create a new project and console application. So we will first do this. I'll tell you why we are doing this. So the reason why we are doing this first is it is going to take a lot of time in training. So I will try. So in order to use machine learning capability in this experience, you need to enable model builder in your extensions. So you can go over here in extensions. You can see how you can enable this. You can sign up for a preview and Bree can send you the fantastic details how you can enable that. Once you have enabled, you will see machine learning over here. So I will just create an mbconfig file. With the mbconfig file, I will have object detection over here. It will give me an error. So as I said that it is in preview, so it will give me an error and then it will work fine. So I will just have to allocate my Azure subscription and my compute name, my experiment, and all that. So I will just write it like this, and it will go and create Azure Machine Learning. In Azure Machine Learning Studio, it will create an experiment. On my next step, I will have to provide my data. So in order to provide data, I will just do this very quickly, but I will show you what I'm doing over here, so you don't have to worry at all. This is my file. So I've already tagged it. You can see some tempting results. And I will go next page and I'll start training. So the reason why I've done this, because it will take a lot of time, and meanwhile we will learn about visual object tagging tool. So what it is doing behind the scenes, it is creating an experiment. If I go and click on Azure, so you can see that the experiment has started running over, or it has not yet started, but it will start very soon. And so it is running now, and meanwhile it runs. Now we will wait for it, and it will take some time to complete. So meanwhile it does that. Let's talk about object tagging tool. So this is the tool which I said that you can download it from here. You can go check out the releases and download the Windows version. So I've downloaded the Windows version. You can also see that this is available on web. So the only difference between web and the local is you don't find this local project option over here, right? So this is my local, and I've already created a project. So I will just show you first what I've created, right? And then I'll show you how I've done that. So these are my images which I have tagged. So I've created two of my Like I've just taken 2 types of images, one with lotus cups and the other one is fruit tribal. I know these are very tempting for you, but equally for me. So I've just tagged them, and you can see that it's not just a square. So I've also drawn polygon images as well, and this is super cool. How I've done this, now let's talk about that part. So I'll just close this. First of all, you need to set up your connection, and connection as in your source. So I will say my source is flowers. I'll just name it differently. And so my source is here. This is my model builder, and my source of flowers are here. So this is my source, and I will save it. Then I will set up a target. So my target flowers ml.net target, and I will also choose my target. So ml, this is my target. Okay, this is my target. Now this is my target. Okay, fine. I've created the source. Then I'll go to home. I'll open up a project called flowers. This is my project. My source is flower source. My target is flowers target. If I've got any tag like sunflower or something like that, sunflower, tulip, and daisy and all that. So you can add these tags later on as well. But if I save it, I will open all of these images. So now this is rose, but I don't have a tag of rose. So I can just go and create a rose. And now 4 tags are there. So I'm looking at the first image. And if I want to tag it, I'll just tag it like this. Click. Damn. So this is tagged now. Okay, so this image is tagged. Then we will go over here. I will tag it as tulip. And if I keep on going like sunflower, and I can tag, as I said, that you can have a different have a different kind of shape as well, whatever you want, right? Like this, and then once you are done with this, you can. So once you're done with this, you can just export this project. When you export this project, you will come to the target folder which we created. So this is the file I uploaded on my ML.NET project. So this is still going on. Sometimes it takes good amount of time. We will just wait for 1 more minute. And if it does not work, then I do have a very sweet backup for you. Don't worry about it. I've already created one of the projects with the similar approach, but I wanted to show you real life, real time. But imagine that it has been created. So this was my model which was created earlier. Although it has given me 100% accuracy. I don't know how, but it has given me 100% accuracy. Anyway, this is this exact similar data set. So you can see that exact similar data set I created earlier. And so if you want to test it, how it looks like, I will just go pick up some of the image, any image like this, and it will test whether this image has got this. So I can also run on an image which it was never trained upon. So I think this is the image I never used for the training. So you can see that it is predicting, but although it is not there yet, that's why I was surprised how it is 100%. But anyway, so this this is the way you can create your object detection model. Then when you go to the consume step, you can add a solution, add this whole application to your solution as well. And in a similar way as we see in sample classification project, you can also get this added to your project. So this is the project which was created earlier. I'll quickly see if it is okay. It's not trained yet. So I will try to run this. So this is the project which got created, and if I try to run this, what it will do, it will go and run and oops. So it will give me the predicted boxes and the labels. So I have given this model a different image, and it has correctly detected everything as fruit trifle. So this is very cool. I tried to do a couple of things with this now, so I'll talk very quickly about that. So what I did, I wanted to build, you see this experience, the same experience over here, this bounding box experience with this, but I could not do this, and I'll show you first what I meant. So I wrote a code to draw the lines, and I could only end up with these sort of lines. I thought that this is some of my problems, so I wrote a code. This is the code. Of course, it is commented out, but this is the code I was trying to play with, and I thought that it was something inside me which was wrong. I raised an issue, and I learned that Jake from team has said that this issue has been resolved. There is a public release coming up soon, so I'm still waiting for the response. But yeah, so this problem, maybe this is something which is being fixed, and it will be released soon. So I'm just waiting for that, and once it is done, you can unleash the capabilities of object detection with your applications, other applications as well. So it is still going on anyway. So what I will do is I will try to see if it is completed. If it is not, then we'll so it is still running. That's fine. If you see the different experiments I tried to run even yesterday, it worked fine. So these are my different experiments. So yeah, going back to model builder, and then I am done. So if you want to see what I've presented over here, there's a blog post which I've written. If you write object detection with ML.NET, I'm sure you may see this blog post on the first page for now. So that's it. If you have got any questions.
Awesome. Thank you, Rafat. It was a great talk. We got plenty of questions in chat here. I'll start off with Jose there. Let's see. What's the difference between MLNet API and AutoML.NET API?
So with ML.NET API is the base on which the AutoML API has been built. With ML.NET API, you can write your own code to create your machine learning models, whereas ML.NET AutoML API does it automatically for you by providing some of the data sets.
Awesome. We have another question from Andre here. He's wondering if we can use NLP and recurrent neural networks in ML.NET.
NLP, I have not seen any example. Maybe Louis can tell, but yes, I think for RNN you can use it. I'm not really aware of this specifically about natural language processing. If you want to use some industry level stuff with NLP, you should use some other service like Louis and other services.
Awesome. Luis, any thoughts on that?
Yes. So if you go back to I believe it was our second talk today, and look at Priyanka's talk on using BERT and ML.NET, she was using it to do sentiment analysis, as well as to do Q&A. And she took a BERT model, or at least different implementations of that, for her, their use case, and embedded it and used it inside of an ML.NET application. So while it is true that you can't natively, like let's say, build a custom machine learning model for NLP, or I guess state-of-the-art NLP models, you can certainly bring other models that exist in, for example, that are in Onyx format, and use those.
Great. And we have a question here from Jose. Why you choose to use .NET 3.1 instead of .NET 5.0? I think it was in one example.
No, yeah. So nothing. It was just in my default setup. So I've been using, for my day job, I've been creating some of the applications with .NET 3.1 as of now. That's why it was chosen. Otherwise, you can use .NET 5. No issues with that.
Cool. Awesome. And we have a question again from Jose here. Awesome questions. He's wondering if you could talk a bit more about WinML, Lobe, and AI Builder from your first slide there about the Microsoft AI stack.
Yes, so Lobe is a tool which is as I said, that Lobe was one of the startups. I think it was acquired by Microsoft last year or two. They have got a tool which you can tag your image on. So it is just like an easy version of VOTT. You can tag your images with Lobe and download those models as Onyx as well, and used in your ML.NET applications or any other applications. So this is one of the tools. AI Builder is one of the capabilities of Power Platform. So if you are the Power Platform person, if you want to use you infuse your AI capabilities into your Power Platform solutions, use AI Builder. And WinML is the Windows machine learning Windows machine learning capability. So what you can do is, if you are using UWP applications or creating UWP applications, you can use WinML to use these Onyx models in your Windows applications.
Perfect. Awesome. I don't think we have any more questions right now. We'll give it a few more seconds here and see if anyone has any more here. So definitely post them in chat in the meantime here. I'll hold off a little bit here. But yeah, very interesting talk. Really appreciate that myself. It's been so many good talks today. When did you get up this morning, Arafat, to start watching the conference?
I think 3:30.
3:30. That's dedication right there. Well, are you gonna go watch some more talks? The final one today with Bruno, and then the rest tomorrow, I guess.
Yeah, definitely. I'm looking forward to Bruno's one. Bruno has always been an exciting person to look at. He's very inspirational. So yeah.
Absolutely. Well, we posted a link here to the feedback again. So if you have any feedback to Arafat's talk here, or if you have feedback to our conference, please go ahead and submit that feedback. We will love it. We want to improve, and we want to do things that are engaging to you and to the community. So take a few moments there to give your thoughts down, and we will make sure to listen.
Yeah, just to add, if anyone wants to connect with me, definitely I will be in the chat box. So if you have got any questions, please let me know. I'll be there.
Perfect. Yeah, that's perfect. Luis, anything you want to add there?
Oh, this was a really good overview. I think it kind of followed quite nicely the last talk that we had with Michael. So in that one, I believe Michael was using more of a image classification, sort of approach to solving problems. But in this case, right, it's sort of a step further, and you talked about that a little bit more in detail, where it was like, okay, well, if you're trying to just categorize this one whole swath of this big picture, right, like, you can certainly do that with image classification. But then if you want to dig a little bit deeper, object detection is certainly a really good case. And, while you can certainly use custom vision to do that, you can also, or Lobe or any of these other frameworks, ML.NET can also do that for you.
Yeah, I absolutely love the capability of object detection. And if I think that the bounding box problem solves it, so I've got a very interesting use case to showcase. And in fact, I wanted to do this in front of my boss, but gladly that I could not do that, because I did not want to come up with a bug that, okay, this is a product bug or this is in preview. So normally people do not understand what is going on in preview. So I just wanted to keep it away for now.
Do you get to use ML.NET in your day-to-day work, Arafat?
So I've used it last year, and when we built one of the models for one of the financial institutions over here, and they have been using it happily. So there's no issues. Super good.
Cool.
And it was to tag different kind of transactions, by the way. So those tagging was super good by their team, and we built the model. It has been doing a great job. So no issues till now. So I think it is working fine.
Awesome. Well, that's perfect. Well, I think I would just want to thank you again, Arafat, for coming on this early hour for you on the other side of the world and speaking about a fantastic topic. And thank you for being part of the community and sharing it with all of us.
Sure. Thanks, Super, for inviting me, and it was lovely to be here.
Thank you, Arafat. Have a great rest of your day.
Thanks.
Bye.
All right, and with that, we would like to introduce our final talk of the day, and we have Bruno here on the line as well. Welcome, Bruno.
Hey, hello everyone. It's a pleasure to be here. I'm closing the session. So many pressure on me.
Yeah, you're like the final keynote, basically.
Yeah, so I need to try to speak slow so still keep the people engaged.
Yeah, I love that you have put a flag up in the background as well, so people know that you're in Canada. Because I think I saw Michael as well put a Netherlands flag as well in his background to indicate where he was, which is kind of fun. I love that people are like indicating how widespread and from everywhere in the world people are calling in to do this conference.
Yes, and long story short, not a Canadian, probably noticed the accent. I was born in Argentina, lived in Spain, came to Canada 5 years ago, I think, 5.5, something like this. But yes, I have this Canadian flag somewhere here. I have a green screen in my back because I moved into a new house. So this is the photo of my old office. But yes, from Canada, speaking here with not a very big time difference like Arafat, same Arafat, if you're still there, you make a big effort to be here.
Well, that's awesome. We're excited to have you. So what are you going to talk about today, Bruno?
So mine is going to be kind of half and half or something different. I am going to talk about detecting anomalies. And my excuse to detect anomalies is going to be, hey, let's pick up a drone, let's pick up a toy, like this one, very simple drone. I will want to talk a little about this. Let's read some data from the drone and start to try to understand how we can detect an anomaly, what can we do, what we can't do. And I really want to share this because when I was trying to do this in a different context, more enterprise level context, I was amazed how easy it was to do this with machine learning.net. I am not a machine learning expert. I'm most like an enthusiast here, also kind of a crappy developer, but it was super easy for me to connect the dots and put something together that can really be helpful for us to get some insights detecting anomalies. So yes, the drone is kind of the excuse to do some cool stuff and learn a little about how you can work with anomalies and detect them.
Well, that's exciting. I mean, we all love drones, right? And if you can throw them in a talk, that's even better. So you got my attention, and I think you got everyone's attention for the rest of the afternoon here. So I think with that, I think we should give you the scene and the stage. So take us away.
Okay, perfect. So I hope that everybody can see my screen fine. As I mentioned, Bruno here from Canada. You can reach me if you have any question. The best way to contact me is probably via Twitter or my blog, mostly Twitter. And today, as I mentioned, hey, let's talk about drones and anomaly detection and what we can do. I've done a lot of this drone session the last year, basically talking about how you can program a drone. And in the last 6 months, I started to get some specific requests about how we can improve the computer vision detection to do AUC and other ones. And hey, someone also asked about anomaly detection. So this is kind of connect the dots in both worlds to do this. And I'm going to do half of the stack in Python and the other half in C#. I am not going to go deep in any of the topics. Feel free. I will be happy to talk if anyone else wants to do this later, to talk about this. But hey, this is me, and this is basically explain what you are going to see. This probably going to be nice, probably going to be cool, but not ready for production. Please double check your code. And I'm so sorry for the bad jokes and the puns and everything else. So let's start. How this all started? It started, I think it was last year or 2 years ago. Sorry, the COVID days made my calendar miss, but a colleague here from Canada told me about this drone. This is a toy. This is not expensive $1,000, $2,000 drone. This is a $100, which is not so expensive. And he told me that, hey, you know what? This drone has these features, which I really like. I already showed this it's basically a small, it fits in your hands. And it's not very expensive, but it's a couple of very cool features. Like an example, you can connect to the drone via Wi-Fi, which give you a nice signal to interact with the drone. It has a 10-15 minute battery life. It's automatically stabilized automatically, do a couple of very cool things. But what I really like about the drone is that somewhere in the drone page, they put some example of how people can program the drone using Scratch. Scratch is this programming language mostly for kids, created by the MIT, where you are connecting blocks and do the stuff there. So I started to think, oh, if there is a Scratch, there should be probably some kind of SDK that you can use to connect the drone. So I couldn't find any SDK. There was no SDK available, but somewhere deep into the Rise Robotic website, you find this PDF. And this PDF, this is a 5 or 6 pages PDF, basically explain what you can do if you want to create your own SDK. So basically explain that, okay, you connect to the drone. Once you connect to the drone via Wi-Fi, you are going to have access, you need to open and connect via 3 ports. UDP, by the way, this is not TCP. This is not the amazing TCP when we have messages. This is UDP. UDP is hell. If you never work with UDP, it's not a fun and happy protocol. But hey, when you open this port, UDP port with the drone, you are going to have one port where you can send commands. And you can take a look at the sample commands that they have here. Basically a string. You need to send UTF-8 strings. So you can say to the drone, okay, drone, take off, and the drone will start to fly. Flip, it's going to flip. Move right, move left, land, or you can start to send information to the drone. Another part is to read state from the drone. Is where we are going to read information from the drone, like an example, the battery value, the temperature of the drone, the accelerometer information, the time of flight. So there are a couple of values that we can read there. And the third port is for the camera. If we want to use the drone camera, we can open a new port. I am not going to do this today, but we can open a new port and we can start to get frames from the camera and we can analyze or do whatever we want with the frames. So I haven't done this UDP stuff in a while because I was using mostly Python. I think, okay, this is going to be a good chance to put it all together and start to see how we can do multi-threading, UDP, these kind of things. And this is what I made for this demo, for the setup. And I am just going to explain this to you because I think it's important that from time to time you're going to see that the drone get disconnected. And I am connected to the drone via Wi-Fi, via wireless. I am connected with a cable to my network, sharing with you. So it's kind of a tricky environment to do this, but just keep in mind that if I get disconnected to the drone, I will probably need to connect and again, connect again. And the hello world that we can do with the drone at the beginning, just to read drone information, is basically create a set of actions to connect to the drone, and then create a set of actions to read information from the drone. And the first thing that you can read from the drone is basically the battery value, and that's it. In a real life event, I will probably make the drone fly, which is kind of nice. I will leave the flight to the end of the demo because I don't want to hit the drone into the wall, break the drone and stop the meeting right now. So I will leave the flight demos until the end. But the hello world is kind of super boring. Let's read the battery value of the drone. But I need to set up this context so you can understand what we are going to do. So as I mentioned, I will start with Python. Let's go here. Let's create a new file. Let's go for demo.py. I created a Python file here, And let me make the font a little bigger. There it is. So I am going to import a couple of libraries here, basically sockets, time, and threading, to open a couple of sockets, to open different sockets in different threads, because I don't want to block the main app. And the time I'm going to use to do some crappy programming to control some timeouts and these kind of things. So once I have this, let's start to write a couple of functions to receive data. So later, I am going to create a client socket and a state socket to send commands and to read the state from the drone. But here you can see that, again, remember first slide, don't do this at home, don't do this in production. I make an eternal while loop where I am reading information from the drone. There are better ways to do this, I know. This one is just for the demo. In the other one, I am going to read the state socket. The state socket will give us an array of values, so we need to understand which are these values. And I know in example, I already done this, that in the array, the number 21, the item 21 is the battery value. So I can read the battery and start to work with this. Once I've done this, let's write some commands to send information to the drone. How we can send commands to the drone? Basically, I have this client socket, and I am going to send a command, which is a text, that I am going to encode in UTF-8. That's it. There is nothing more complex than this here. And what I am going to do here, I am checking for a response. The response is one of the values that I read before, and if after 5 seconds I don't have a response, I don't have any kind of response available, I will assume that the command didn't work. And this is mostly because UDP. In UDP, you send message, and you are most of the time you're not sure in which order are going to be delivered, if they arrive or not. But hey, it's fine. We need to do some defensive programming. Then I have some overload here to read the command, so I can have an okay or not okay. So basically, I'm sending information, but I can start to basically to connect to the drone, to start to do some stuff to the drone. And I am going to stop here a little. When I connect to the drone, I have, because I'm connecting via Wi-Fi, I have an IP address. So I know in my network that when I connect to the drone, I have this 192.168.10.1 as the address that I have for the drone. And I also know, because of this document that I show you, that I can use port 8889 and 8890 to read information. So I can create the client sockets and the state socket here. But before even start to do this, let me show you how can I connect to the drone. This is the moment that I stop my presentation and I show you what's happened here. So when I turn on the drone has a very small button in the right. We have a LED here starting to blink. I don't know if you see the LED or not, but trust me, there is a small LED there blinking. And if I go to my Windows settings here, I am going to see somewhere here, let's start zooming it so we can have a better look. I am going to see somewhere here, there it is, that, hey, this is the drone. I have my Dragon Ball network, this is home, Cosico is home, and this Telo 589327 is the drone. So I can go directly here and connect to the drone. I can go here and connect. And I can even check Windows to automatically connect. The problem is that Windows is a mess. I don't want Windows to automatically manage my connection. So what I am going to do, I am going to go very, very old school. I am going to ping this IP, and I am going to send, let me maximize this. I am going to use a command, a net wireless LAN connect, to connect to that network. So at this moment, at any time, after a couple of seconds, I am going to be connected to the drone. And this is how I check that I am connected to the drone. I have an eternal ping to the IP of the drone. If I go back here to my networks, I am going to see, you can see here that I'm connected. I'm connected to my wireless and to my Ethernet cable network. But hey, this is what I am going to use to see if I am connected to the drone or not. Let's go back to see the code. So if I go back here, I already defined the connection. So let's create a couple of threads to receive data and to read the state. Remember, I done this using threads because I don't want to block the main application. So once I have this, I can start to work, I can start to create my application. My application is super simple. I have a battery, which is a global variable that I have here, I will send a command to the drone, which is command, is a first string is command. This basically starts the drone in SDK mode, and then I'm going to send the read command for the battery. Somewhere inside the documentation, define that if we want to update the battery value, we need to send this comment. And I'm going to wait a couple of seconds, 5 seconds, and print the value of the battery. So that's basically it. This is a very simple, let me copy this. It's a very simple way to connect. I can probably pick up everything before these lines, 90 lines, and wrap this into SDK. I'm going to leave this open, everything, so you can see how we can evolve this code, but let's run this. So I'm going to go back here, I'm still connected. This is Python. So let me move to that stage, and let's take a look at the files that we have here. I have my demo file created 10 seconds ago, and let's run this file. So if I run python.demo, this will connect to the drone, and after 5 seconds, again, super boring, hello world, sorry about that, my drone has a 22% of battery, which is not good at all. I need better battery for my drone. I have extra batteries here if I run out of battery. But hey, I read one of the value, which is the battery. Let me show you how, changing a couple of lines here, we can see how this works. So I am going to make the sleep a little longer so we can have more interaction. And when I receive the data here, when I receive this list, let's print this list. Let's print the list of value to see what we have. So I change the values, I change the file, just updated, and let's run this again. So you can see there that they have a lot of values, and you can even see that if I start to move the drone, can you show my desktop also? If I start to move the drone, the values are going to change because the values that I have here, and this is 20 seconds of value, the values that I have here are all of the stuff that I get. Are all of the stuff that I get from the drone. So I have the pitch, I have the roll, I have the yaw, which is basically the axis that we are using. We have the accelerometer value somewhere here, AX, AY, XC. We have the temperature low and the temperature high, the time of flight, the battery, which is 22. So, hey, just using these lines, I can start to read information from the drone. And this is kind of interesting. It didn't took me a lot of time to write 100 lines of code to read this value, but these values basically represent what the drone is doing. Let me start this again. Let's hope I'm still connected. And when it's there, if I start to move the drone, if I basically turn the drone upside down, the values are going to start to change. You are probably going to see very slow there how the values are changing because the accelerometer is changing. If I move it from side to side, it's going to also change. So this is real-time telemetry that I'm getting from the value. If I make the drone fly, if I send a command and say take off or land or whatever, I am going to have a lot of info here to work with the drone. So it's kind of nice, it's kind of easy, and you don't need to write a lot of lines of code to do this. Just to show you how easy this could be, let me write another quick demo. I know that I told you that I'm not going to show you the camera. Oh, sorry. But let me show you how the camera works. If I want to connect to the camera, what we can do. So it's going to be basically the same code. The main difference is going to be that I am going to use OpenCV to access to the camera and to read the camera frames. That's why I have an extra import here for CV2, which is OpenCV, but then the lines are the same. And before starting here, what I am going to do, I am going to start the drone, start the connection, and I am going to send an extra command to say, okay, let's start the camera. Stream on, give me my camera, because I want to access to the camera frames. Then, if I go here and start to do, let's start the camera. And start the camera, it's probably the easiest lines of code that I need to write. I've done a lot of OpenCV stuff for computer vision and playing around with things. And if you want to access, for example, your webcam, you can add here, basically set OpenCV, open a video capture object in my local webcam or an HTTP webcam. Because this is a UDP webcam, I basically define an address and the port, which is UDP, the address, and the port 11,111, and I open the camera. And once I have the camera open, I can start to read the camera frames. So I will start to read each one of the frames, and then I am going to show the frames in a frame. The only thing that I need to do at the end here is drone 34, I think, which is basically stream off, stop the camera frame. But it's super easy, and let's do this ml.net virtual rocks. Let's name this window like this, and let's run this demo event. I'm still connected? No, it's disconnected, so I need to go back, turn on the drone again, send the WLAN connect. This also gives me time to drink some water. And after a couple of seconds, I am connected. If we go here and see, and see our files, I have the camera file here, so I can do Python camera.py, and it's going to open it's going to connect to the drone. This is all OpenCV logs that we are seeing there, and at any moment, you can see here virtual ML logs, and this is the drone. I am pointing to myself. You can see that in my back, I have my green screen. My desk is a mess, as usual, but hey, I am moving the drone here. It's kind of moving fine. As I mentioned, what I like about this drone is that it's super easy to start to do this kind of things, to start to play around, and I like it in the way that, hey, with 10, 20, 100 line of code, you can start to do stuff here. So let's go back to the drone. And by the way, it's a question that I have here usually is how fast this works. So let me show you. If I delete this and I have, basically this is the same lines of code, but I use the time and I do some calculus here to see how frames I'm processing per second. What I have here is still connected, yes. Sorry. What I have here is going to connect. I'm going to overlay how many frames per second I am using with the camera. And oh my God, I think it's literally gets disconnected when I run the process. So no problem. Let's go back here and stop this. Wait a couple of seconds until the program stops. I probably need to show. This is what happened with the live demos with the toy, that it gets disconnected, and there it is. So once I get back to the connection, let's see if the ping starts to, yes. Okay, the ping is there, so I run the camera again, it's going to connect again, it's going to do the magic, and in the camera frame, you can see here that I have between 30 and 40 frames per second. If I start to move this again, still going to have a 34, which is kind of nice. So hey, it works really, really great. I think these values are great to start to do some stuff. I'm not going to do any more camera. I can show you later a couple of other things, but just to give you a sense of what we did here, let's recap. I create a couple of functions to receive data from the drone. I create a couple of functions to send commands to the drone, and then I connect to the drone using 2 sockets to send commands and to read information, open these sockets, open these reads, and send in different threads, and I have kind of a main program which is basically connect to the drone and do something in the meantime while we are getting information. The important stuff for us right now is how we are going to work with the telemetry. Because as I mentioned at the beginning, what I really like when I start to see, okay, I have all of these telemetry values like the accelerometer value, the battery, and these kind of things. So I start to figure out, hey, maybe we can work with this data. Maybe we can do something with this data. So of course, I get back to ML.NET. I did a couple of tests. And what I really like is, as part of all of the scenarios that we have here in ML.NET, we have the anomaly detection scenarios, which are kind of great because If you don't know anything about anomaly detection, which is basically like myself, it's a nice way to start. It's a nice way to use a couple of algorithms that are already there to do detect spikes or to do some point change detections to understand what you can do. And basically, the best way to explain this, the best way that I have to explain this, is to use one of the out-of-the-box demos that are available here. So there is a set of data. Let me go here we are. So there is a set of sample data that, as part of the anomaly detection, is this CSV with product sales. This is a product sales, 2 columns here that we have basically a date with month and date and a sales value. What I really like about this is that we can easily go here in Excel, open these files in Excel, create a chart of the file, and hey, we've read this. So this is kind of nice, I understand this, and if you ask me, okay, these follow a pattern, which are the anomalies here? So myself, as a developer, I will probably say, hey, there is something wrong here because this went from a very low value to a very high up value. Something probably similar here. For sure, this section will have something. So just looking at this in Excel gives me a sense of what is happening here. The cool thing about the anomaly detection in using machine learning.net, when I started to read the value, and by the way, everything that I am showing today for this one came from the machine learning samples. I love this page. This is in my top 3 best samples page ever, because I can go here, we'll go quickly to, I don't know, I want to do anomaly detection, so be somewhere here, sales spikes, the same that we are looking, go to the C#, start to take a look at the problem, the data set, the couple of description of how this works, the process to do this, the solution. So I love this. And when I go to the code, because at the end I like to read code, what we have here is we are going to read this product data from the CSV file that we have. We are going to detect the spikes. We are going to apply one of the 2 algorithms that we have here to work with anomalies, working with the prediction, trying to work with the sales column here. And then we have the confidence that we can use, so detect everything that is an anomaly, which is over 75% of the spike that we want to do, and a couple of other values here, so the length and how you chunk this, we can go that later. But once I have this as one of the transforms, and again, I'm not going to go deep into the machine learning.net, this is the session that I am basically told how I learned this, I am going to analyze this data, so I'm going to have a set of predictions, and this set of predictions is going to give me a set of values, which is basically an array of 3 numbers, and I'm going to have the first number is going to be 0 or 1, is an anomaly true or false, then I'm going to have the value that I was working, and the p-value, which is basically the delta there. And copy and paste for the original code. If this is an alert, if this is an anomaly, it's going to change the color of the output here, showing this in the console. So let me set this as start project and run it. I will directly run, not going to go deep. I will directly run this one here. And after a couple of seconds, I'm seeing this is in the right version. Yes, perfect. After a couple of seconds, I am going to have a full console application with a lot of values detected as anomaly, but I can easily go and start to take a look at this. So let me put this one here. Let's open Excel and set up my Excel here, and I start to try to figure out if this makes sense. So the first value that was detected as an anomaly was 127, which is probably going to be 127 is going to be this one, no, this one, no, this one, 150. So where is 127? Detected as one of these, somewhere here. I think it's this one. Yes, there it is, 127, because it was a huge spike here to the other. So the next value detected as anomaly was 341, which is this one here. So is the first 2 values detected as anomaly are this one and this one. And I am detecting a lot of anomalies because in my code here I put a confidence of 75. If I raise the confidence to, I don't know, 85, and I run this again, we are going to have similar values, but you see there that I have less value. So these two are not detected with anomalies, so that's kind of nice. The first one is going to be 426, which is probably going to be this one here, yes. So my first anomaly is going to be this one. So, hey, I was starting to play around with this, and I understand how this works with real data. And again, I use Excel to see how we can do this, to see how we can understand what we can do. So once I learn this, once I get to the point that I can figure out how to use this, it was, okay, let's go back to my, let's close this one, not this one. Let's go back to my drone sample, and let's try to figure out how we can read and save this data, how we can detect anomalies here. So I am not going to write any more code. I'm going to show you some code here. So the first demo that I did is basically the same demo that we already showed you, but I am going to also read values from the accelerometer. I want to have the value for accelerometer for the 3 axes, X, Y, and Z. So when the drone is flying, if it starts to get shaky or if it moves, I have this value. Also, I will read the values for the temperature and from the battery. Everything is happening here at the beginning, where I am reading this value from the list. Remember, I don't know where are the values, but I can read the output and start to figure out where they are. So when I read these values, I am going to do something very, very simple. I am going to create an array in Python, add a header, and when I read these values, I am going to add all of these values to the array, and then I am going to change this to save to CSV. I'm going to basically save this at the end into using a CSV writer, an object from a module, an object from Python to save the CSV, and the value is going to be drone data CSV. Let's change this ML length, so we know that this is the one that we want to use. And remember, I am going to fly my drone, make some noise, and write it down, and start to read these values. Phone call. Let's run this. So let's go back here. Let's minimize. Let's clean a little couple of screens. So it's going to be kind of a simple one. Python, this is my file. I am disconnected, so I need to turn the drone again one more time. Connect to the drone. Let's wait until the ping make the magic, and we are connected. And in the meantime, by the way, let me connect this. Let's take a look here before running this. So the only 2 files that I have here is the Python file and an image that I'm going to use for the back. So let's run this. Now I'm connected. And let me show you this one from here. So let's put it there. So I will run the Python file. We're going to connect. I'm not going to use the camera, but I am going to use a window here. This is the frame, this is the value. I can start to make it fly, wait, 1, 2, 3, make it fly again, 1, 2, 3, and let's stop this. Let's put this one here. And once I have this, once I have my simulation of flight, if I go here to see the files, we have a new file here. Let me clean this. We have the CSV of the file. So let's take a look at the CSV so we can take a look at what I saved here. So let me go back to my file, and let's take a look at this file. I will open this first with Notepad++. You can see here that I have my header, then I have my date, and first line are basically zeros, first time that I read this, and then I start to get information from the accelerometers, X, Y, and Z. And I have all of these values. I have a problem with this file that you see that I duplicate all of the lines here. And let me delete this. So this is cleaning data. This is the work that we do when we work with a lot of data. And let's open this with Excel. Let's try to figure out what's happened with Excel. So if I open this with Excel, I have, I don't know, 20-second flight, 300 lines. If I insert a chart here using lines, you can see here, remember that I was flying the drone, I have my drone here, I started to fly around to start to do ABCs, ABCs, ABCs. So, hey, take a look at this. The gray one, the gray line, the one in the bottom, is the C value. So it's the one that reflects how I am moving this in the C value. But the others, because I have shaky hands, I can only play the guitar, not the piano. When I move this, it also affects the accelerometers for Y and from X. So, hey, I have here a set of data that I can use to analyze data, to detect some patterns, to try to figure out, hey, maybe there are some kind of anomalies here. I know, I should probably done this flying. I remember that I told you that I'm going to make the drone fly later, but let's use this file as it is right now to try to detect anomalies. So once I have my file, I don't want the chart. What I am going to do is I am going to save this in the drone location. And going back to Visual Studio, I have here a very similar file to detect anomalies. No, not this one. Let me use the number 2. Let's go to the completely processed one. A very similar file to detect anomalies. But what I am going to use is the file that I have right now. And in order to do this, I also using some typed classes here. I have drone data, which is have basically a datetime with the first field with the time that I record, that I make a record of the of the value. Then I have the 3 values, the 3 columns, 1, 2, 3 for X, Y, Z. And then I have the predictions, which I mentioned before, is a vector type, is an array of 4 to show the predictions. So I am going to use these 2 as the typed values to do my predictions. And what I am going to do is let me add the file that we just saved. Should be somewhere here. There it is, drone data, ml.net from 4:30. Add as link. And let's let's copy this into the output file because we need it to read it, and then let's use this as the input. Drone data ml.cv. So drone data ml and drone data anomalies, and this is the output. What I am going to do here is the same that I did before. And by the way, I haven't mentioned this. I am using a standard console application here, .NET 5. Didn't change anything. It's basically what we have with Visual Studio. I am using Visual Studio 2019 preview just for fun. You can do this if you want in code or in 2019. I have here, I have here, in order to work with anomaly detection, I have 2 dependencies installed, ml.net, of course, and also the time series to work with time series. I think I'm using the latest version, 1.5. I may miss one. No, that's fine. I don't have any updates. So it's up and running until today, and hey, it's super easy to set up and start. So I will read these files, I will read the CSV with the data that I just showed you, and then I am going to detect some anomalies using the data. I am going to use the confidence of 95 to detect anomalies. We can change this later. And the main difference here is that at the end, when I finish this, I am going to create a new CSV file with the original values and the new values that I have from the prediction. I'm going to still show this in the console, but basically I am adding here the telemetry lines that I have at the beginning, plus if anomaly is true, false, the score, the p-value, and a new line. So let's run this one. Set a startup project and run. It should be fast. I am not working with tons of data. This is CSV with set of data. I have at least a couple of anomalies here, which is kind of nice to be detected. Let's see what's happened. And as usual, I am going to go to Excel to try to understand what's happened there. So let's go here, bin, debug, net, and anomalies.net. This is the one that we just created. Yes, there it is. I have here my seven columns, the date, the accelerometer values, and then the anomalies true false. So let's create a chart here and start to try to understand what is doing. When I create a chart, of course, I don't need all the values. This is kind of good. I am going to only work with the when I define, I'm sorry, I didn't explain this, I missed this one. When I am analyzing the telemetry and try to get the anomalies, I am only going to do this in the accelerometer X value. I'm only going to use one value. So let's pick up only this one, and let's also pick up, I don't want to do the p-value and the score, which are basically the same that we have at the beginning, but just the alert to see that we have a value. Let's go back here and go back to the chart. This is my chart. And I have here very, very small the alert, which is basically the anomaly. So let's change that one. Let's do this a mixed one. Let's use a line for this one for the accelerometer values, a stack for the other one. And hey, this is kind of a nice way. Oops, sorry. This is kind of a nice way to see where are anomalies here. You can take a look that this value was detected as an anomaly. And then here, when it's go very shaky, I start to get a lot of anomalies there because it's here. But everything that's happened, remember that when I make it fly, I make it like this, then I didn't move it, then I shake it. So everything that's happened between here, between this section and the last section, and maybe this small portion here, is not detected as an anomaly. So, hey, you can start to learn a lot. And by the way, I can start going back here, start to change my predictions, start to change the confidence from 95 to 85 in example, and it's going to get, to close this one. It's going to get a lead, much more messier. A lot of data is going to be detected as an anomaly, as you can see here. I can even also change the size of the chunk that is going to use to detect the anomalies. So there are a couple of things that I can do to start to figure out what are anomalies for me, because one lesson learned for me working with this, like this, is that the algorithms are fine. By the way, we have, by default, we have two ways to do this. We can do spikes, or we can do change point detections to detect anomalies. And the algorithm fine, the data is going to be fine, but I spend with my team a lot of time trying to understand how to read this data to get insights later, to see how we can do. So in example, I can do the same. I am using here, as I mentioned, detect ID spike, but I can go here and use detect change by point. It's similar similar values here and parameter. This one has a different name, I can't remember. It's something like the change history length. So I can use very similar. I have another sample doing this. You need to spend some time here trying to figure out what we want to do, how we want to work with this, but we have this data. And hey, as I show you here, in the Excel, I close it. As I show you here, it took us just very few minutes to start to get in our hands with real data and real insights, start to figure out what we can do, what we can change, how we can get insights from here. So I still have 10 more minutes before going to the Q&A, and I'm going to show you, I have all of the pieces all kind of separated here in different places, how you can put it all together, how you can make it work in a real environment. So the idea here is that there are a couple of ways that we can do this. I am going to treat this drone, I am going to consider the drone as an IoT device. And by default, in the Microsoft stack, we have two ways that we can do this. We can use Azure IoT Suite or Central. Azure IoT Suite is, Azure IoT Hub is kind of the PaaS solution. It's the super extensible and powerful platform that we have. We can do a lot of amazing things and requires a lot of work if you want to make it, not a lot of work. You make it, if you want to have charts, insights, reportings, a lot of things, you need to build everything from zero. IoT Central is kind of a different approach where you have out of the box a lot of features available for you. So you have an easy way to connect devices and send telemetry. You have visual wizards to create rules. You can define dashboard in a very easy way. So, hey, Azure IoT Central if you want to prototype something like this, it's a very easy way to do this because you can also connect this later with other pieces in Azure that can use machine learning.net to detect anomalies. So what I have here, if we want to go to Azure IoT Central, you can go to AzureIoTCentral.com. And when you go to AzureIoTCentral.com, you have a couple of options here. Of course, you need an Azure account, but you can build a solution, and they have templates for already packaged solution for retail, energy, healthcare, and whatever. Or you can create a custom app. When you create a custom app, you basically need to define the name. It's going to be your URL that you want to use. Then a template that you want to use. This is going to be a blank template for a custom application. And you have a couple of plans that you can work. I already created one for free. I usually create this on the store. It's not super expensive. I mean, we have other Azure IoT Central demos and created for this, which is kind of cheap because you can have free devices with 300, 3,000 or whatever messages per day. So it's kind of nice. But I already created one. If you want to create one for free, it's not going to let me do another one. But if you want to do something else, you basically need to connect this to your Azure subscription, and it's going to be here. And let me show you what I created. So this is the one that I created. I created one, it's going to be expired in 7 days, because I created and playing around and created it today to have it here. And what I have here, I can create templates, device templates. And what is a device template? I can create a new device to use in my machine. There are plenty of devices that are already compliance with Azure, like the Azure Sphere, the Flick button from Rigado, the Rigado Gateway. There are plenty of things that we can use out of the box, or you can create your own device. So if you want to create your own device, you can set a new name like BGI Telo, and then you can create your device and you start to create your model. What is your model? So basically you can define capabilities from your device. So I want my model to have battery values. It's going to be a telemetry. It's going to, I don't want a semantic tag here, but I want to have acceleration, which is going to be again a telemetry, but it's going to be an acceleration vector. So it has some kind of data types that you can use out of the box, though, so we can use this. And you have this for acceleration, for velocity, for location, area, distance. There are plenty of out-of-the-box stuff. And you can create a device like this. No? Once you create and finish your device, you can create views from your device. By default, you have a raw data device, which is basically a grid with all of the data that your device is consuming. But we can also create a new view like this one, where we are going to add an example. Hey, let's add the accelerometer values for X, Y, and Z, and let's create a chart. And let's add also a property, let's add another telemetry value for the battery, and I'm going to have another chart with the battery. And I have here a very simple set of charts for KPIs, bar charts, heat maps, line charts. So I create a template here. This is what is called a template. Once I have my template, I can publish my template, very simple. And once I have this, I can start to add devices. So I can go here, create a new device, BGI2, select, the device BGI2, select one of the templates that I have here, BGI Telo, and if I said this is going to be a simulated device, it's going to be created. And when I enter to this device and I start to look at the information, it's going to show me information in real time that is coming from the device. One important topic here is that Azure IoT Central it's real time, but it's not going to show information in real time. Here you have to wait a couple of maybe a minute or 2 minutes to get information from your device. But it's super amazing to prototype. It's super great to see what's happening. If I go here to raw data, at any moment is going to start to simulate data. So I have my first value. This is all simulated that I have here. So I have accelerometer value, the battery, and the time of telemetry. If I go here to the chart, start to draw a chart. So I want to do the same, but with a real DJI drone. So what I created here, I created a template for my drone. This one, example, the B5, where I have a set of properties. I have AGX, AGY, AGC, battery, temperature, and a last report value. Then I have a couple of views. I have a default view with an image and a couple of charts here, an historic view with a bigger chart with all of the info from today, and a heat map, and the raw data, which is basically a full screen. And I created, well, yes, no problem. And I created one device. Let me go back to the dashboard and then to the device. I created one device, Drone 01, which is a real device. This is the one that I'm going to use with my drone, and it's going to show me information in real time. So in order to do this, I have some lines in Python to do this, and I need some connection information. I have here a scope, a device ID, and a primary key. And with this, what I did, I created, again, a super crappy, but very simple app that has this value, has the scope, has the drone, and has the key. And then I have a couple of support classes here for the drone device. But when I am reading information from the drone, I will read the battery, I'm going to send the telemetry. And every 5 reads, I am going to also send the properties, which is going to be the battery value, the temperature high, temperature low, and I will not read this every time. I will wait every 5 seconds to read this. So if I copy the path for this one, let me minimize this. So I don't have data here. Let me set up my environment. Where is my ping window? There it is. So I will turn on the drone one more time and connect. Let's wait until in the meantime, I'm going to go here to my file 66. Okay, so I am connected. So I run this and it's going to connect to the IoT hub. So it's going to open everything. I am not using, I will move this to my other monitor. So I am sending information, a couple of frames per second. It's not important. There it is, sending information, telemetry, -9.3. So at any moment here, I have my drone here starting to move. At any moment here, it's going to start to show the data. So it's going to start, take a look here, some data came. The battery is 61. It's need to change to my very low battery here that I showed you before. So when it sent one of the battery values, hey, it went down to 12. So this is information, but which is the cool thing here, that I only use what I already have to send information, and I can start here to do some stuff, like in example, in my chart, in the chart that you've seen there, I defined a super easy set of rules that is going to show the battery in red if less than 25. It's going to be orange if between 25 and 50, or green, anything else. And I can also do, and this is the part which is important, I can also do export, data export. So out of the box, I can create some kind of export rules that are going to pick up the data that I have here. If I have an exist accelerometer information, I am going to send this to a blob, an Azure blob storage, and I can pick up here an event hub, and a blob storage, a service bus, or even a webhook. So I can easily connect this with an external information. So it's sending information. If I go to my storage here and I open the blob containers, I know that I am on time, just one more minute. Let me refresh this. This is refresh, there it is. So this is the information, 21, 5, 7, which is today. Let's go for 15. This is all of the value that I have here. Let's pick up this one. I can download this, and if I open this, you will see, oh, I don't know which is going to use to open this. Let's open this with Notepad++, and What you see here is telemetry information from the drone. When I have schema, default, and queue time, and I have here the part that I want, which is the telemetry. And I can start to connect this with an Azure function or with whatever other element that I have to start to detect anomalies. So you can connect this very easy using these out-of-the-box pieces in Azure IoT Central to start to do your magic. So just to finish, we're already at the end. Just do a quick recap of what we've done. Drone SDK, not available, so we created a very bad but working one. Getting with this SDK, the telemetry, is kind of fun, it's kind of nice to have this information, and then start to try to learn how to analyze the drone accelerometer with machine learning.net to detect anomalies, to see how far we can get. And then at the end, connecting everything together, missing the final parts. I can show you this later on in a blog post, doing this with Azure IoT Central. So this is kind of the end. I'm going to share slides. I have a lot of resources here, how you can start, how you can do. I wrote a lot about this, probably need to find something else. Of course, MLNet, this is what it is. Also, timing is great. We have this small drone flying in Mars, which is an amazing, I am happy about this, I'm sorry. I'm like a small kid seeing a drone flying in Mars. It's an amazing accomplishment for humanity, so I'm happy about this. And hey, I am happy to open and go to the Q&A section if there are any questions. It was a pleasure to be here. Sorry for the extra minutes. And hey, let's have some fun. Let's play around with drones.
That was awesome. Thanks a lot, Bruno. I mean, you could have honestly kept going for another hour because this stuff is just really cool. We did get a few questions here in the chat. One was, I think, when you were kind of showing off, the first samples. Let me see here. Let me just grab it. I lost it for a second there. But essentially, I think there it is. The question is from Andre. Could you recommend a good optical flow drone navigation library?
I don't know what is an optical flow drone. To be honest with you, I don't know what is an optical flow navigation.
If I'm going to guess, and Andre, please feel free to sort of, clarify your question. But if I'm going to take a stab at this, it's kind of like you kind of chart a path with the camera, and then it sort of follows that path. But again, Andre, please, feel free to clarify in the chat what you mean by that.
Yes, probably. I mean, again, this is a toy, and you can access the camera, and you can do some machine learning with the camera. Hey, we can even connect everything doing with machine learning.net here using computer vision. We can do this kind of path navigation and all of the stuff, but because it's a drone and there is no official SDK, I'm guessing that you need to create everything from scratch. If you move to the couple of $1,000 drone, professional ones, their SDKs have these kind of things where you pick up, because they also have GPS, where you define your map in GPS, go to A, B, and C, and the drone is going to do that. But that's another level, and I don't have a good excuse to explain to my wife why I spent a couple of $1,000 in another drone. This was fine for me, but I cannot raise this to another level. But if the question is around optical navigation, in this scenario, I need to create by your own, and I don't know anyone useful to do this. Sorry.
Yeah, and we I think we've got some clarification here. Optical flow uses the same technology that is used in mouse that has light and lasers. Okay.
Oh, kind of LiDAR. Oh, that's a nice challenge. I will pick up that one. I will start to write. I have a couple of LiDAR sensors here. Okay, you just make my weekend go away. I don't know anyone. I am doing stuff with LiDAR for other things, but not with the drone.
Great. And speaking of SDK, so you mentioned, and again, correct me if I'm wrong, it sounds like there was no SDK, so you kind of built your own for your Tello drone. And Andre here asks, there's a Windows SDK for some DJI drones. Do you know which features are available in I presume the DJI SDK that doesn't exist in the SDK that you sort of built for your own Tello drone?
So there used to be a kind of a big DJI drone, but very big with 4 propellers. And I remember 5 years ago, because I was still in Spain, we did a couple of demos with C# in the Windows world. But the basis of the SDKs are very similar. Basically, you have connection, you have movement, and then if you have a camera, you have access to the camera. That drone didn't have a camera, so it was just moving and not kind of reaction. And the other drones, the more expensive one, who has an SDK, has a lot of other features, like in example, because the camera has some movement and you can move the camera, so you can move the camera, you can access to a small, there is no file system here. With the other drones, you can take photos and upload to the file systems. Because there is no official drone SDK for this drone, basically everything that you do is going to be kind of new, but think about that connecting and moving is the ABC. The camera is kind of a nice bonus.
Great, wonderful. And you showed off a lot of samples here, but another question from Andre here is, are they available on GitHub?
Oh, yes, I am going to share this in Twitter. If you go for github.com/elbruno, myself, I have my two main repositories are my blog and the events. I am going to tweet, I'm going to post everything from today later today, but you can go to the previous one where you are going to see this. And by the way, I didn't mention this. I did a session for Microsoft Learn a couple of months ago when I do basically very similar to what I did today, but in C#. There's a couple of challenges there with OpenCV in C#, but if you only want to do C# 100%, you can also do that there. Somewhere I share the stuff there.
Awesome. Yeah, thanks. Definitely worth looking into for folks who are interested in sort of trying to implement and expand upon what Bruno has shown off here. You showed off some telemetry here, but is there a way to determine where the drone is in space using some sort of visual cues or beacons, kind of like you showed off with the camera?
Yes, what we did for a kind of internal hackathon challenge that we have here, we use the camera to do this. So basically, you have accelerometer information, but you also have the camera. And if the camera detects a couple of hidden QR that we put in the space, we know that the drone is flying or not flying. But there is no telemetry by default that says flying or not. You can access there is a small sensor in the back that shows you the altitude, so you can assume that if this sensor has some value different than 0, the drone is flying. But sometimes, because this is a toy, you have false negatives there, so you cannot rely on this information, but it's a fun experience to mostly learn.
Yeah, for sure. Yeah, and it's really nice how you were able to tie, and again, you mentioned it is a toy, right? But you were able to make a real world application, right? And architect it in a way that you're using Azure, you're using ML.NET, you're using Python. So you're using all these different services that, yeah, sure, it's for your own sort of edutainment. I like to think about it, right? Like you're educating yourself, but you're also entertaining yourself. So it's really cool that you could then take what you've learned and then just apply it to a real world scenario there. Let's see here. All right, folks, there's the link to Bruno's GitHub if you want to check out the samples and everything else. With that, we're actually getting close to time here. Is there anything last thoughts that you would like to leave folks with, Bruno?
No, but just a big thanks for everybody who's watching and you for putting all this together. I know that all of the work that I have to do this, so thanks, Brie, Alex, Luis, and John. I know that you really, really love and rock this. And the final thought, I am a very big fan of machine learning.NET since it was presented by Cesar, I think, 2 years ago, 2 builds or 3 builds ago. Yeah. I think 3 builds, you talk about the version, the beta, and in 2019 it was the big one. So I'm a big fan because I cannot talk about the real project that we can use it, but for C# developers, it helped us to do something like this, anomaly detection, very easy. Hey, I love this. Easy and useful. I will go everything. I will always say yes. So thank you very much. And thanks for putting all this together. It's great.
For sure. Well, thank you. Thank you for joining us, and thank you for coming on, as well as thank all the speakers. So with that, Bruno, we'll sort of close this out. And again, thanks a lot for coming on.
Okay, perfect. Goodbye.
Right. Take care.
Thank you, Bruno. Well, that was awesome. Full day.
Yeah. 7 hours I'm seeing here on the little ticker here. So that's awesome. So if you stuck with us for 7 hours, congratulations and thanks.
Yeah, tons of good content there. I'm glad we recorded it too.
Yeah, we learned a lot of things. I think, I mean, it's awesome talks across the whole day, and I'm even more excited about tomorrow as well. You know, a full day of additional content and diverse talks, which is going to be fantastic to hear as well.
Yeah, Louise, do you want to pull up the schedule for tomorrow and we can see what we've got coming up?
Yes. If you did not get enough of ML.NET today, 7 hours was not enough for you. There is another, what is it, like about 1, 2, 3, 4, 5, 6 hours. There's a full day here where we're going to start off very similar to how we started today with somewhat of an introductory talk, except this one's going to be a little bit more focused on using AutoML. And I know that there was a few questions here on, you know, the difference between ML.NET and so the ML.NET and the AutoML API. So this session here should give you a better understanding. And again, as we saw from some of the presentations today, there, you know, you can certainly use the tooling to leverage this, but I won't, you know, go deeper into that. Then if you are interested in Formula One, there is an F1 race strategies talk here from Mikal. And yeah, and I don't know, there might be Formula One, or is the season over? I know it usually comes on Saturdays. That's when I usually
think
watch
it's still going. I'm pretty sure it's still going.
Gotcha. So maybe you can watch this talk and then employ your strategies. We're not going to encourage you to go and spend your money, put your money on certain winners, but you know, this might be a good talk for you if you're into F1 and Formula One. Then we talk about a really interesting topic with Marco here, which is ML Ops and how you can basically manage the model lifecycle with ML.NET using Azure DevOps. So you're going to get to see sort of the part of the engineering aspect of machine learning. We've been hearing about use cases here and case studies, but this is more of like, well, how do you make sure that you are putting forward best practices as you're not only developing your models, but also deploying them. And this one here from Daniel is going to talk to you about consuming ML.NET native models by writing almost no code. So it's going to be interesting because right now you can kind of do that with Model Builder, but you know, in this case, it's using Roslyn. So yeah, we're looking forward to that. If you've seen this talk before, rock, paper, scissors with ML.NET, Luis is going to kind of you know, give that talk. There was actually a rock, paper, scissors, a lizard, Spock, I think it is. Is that right?
That sounds right.
Yeah, something like that. But in this case, it's using ML.NET. I think in that case, it was using Python. And then last but not least, we're going to talk to Faisal here, who's going to talk to us about taking a data science project all the way to a product. So I'm super excited.
So
Yeah.
is Shirley Dev. Very, very excited. In case you missed it, Louise.
Yes, we are excited to have you as well. Yeah, our weekend, we're really happy and excited to spend it with you folks as well. So yeah, there's certainly more.
Fantastic. Yeah, I'm excited for tomorrow.
Awesome. All right. Well, again, make sure to tune in. The link, well, either way, just go to YouTube and you can check out the channel because the link is going to be a little bit different tomorrow. The stream is going to be a little bit different. But again, if you sort of have our channel bookmarked on YouTube, or if you're following us on Twitch, right, you can certainly just tune in to either of those places and you'll be able to find tomorrow's stream. And again, this starts, you're seeing this at 11 a.m. I know there was a little bit of confusion earlier before the event started. Some people, when we did a stream with Bree yesterday, they were like, oh my God, it's starting in 6 hours. But no, it was not starting at midnight. The time that it shows here is your local time. So I am based out of the East Coast. So that's 11 a.m. for me. So wherever it is that you are joining us from, that this schedule here is going to adjust for your local time zone. So just be mindful of that. So it's not at 11 a.m., you know, your local, whenever it shows up, it's your time zone. So with that, are there any last thoughts that you guys want to sort of send our viewers off with?
No, looking forward to tomorrow, and I hope you all join us for another day of ML.NET fun.
For sure. All right. Well, thanks a lot, folks, for joining us again. Congrats if you made it through 7 hours of this, and we appreciate you spending your time here with us. So we'll see you tomorrow. Thanks.
Bye,
Take care.
Yeah.
Bye.
Later.